world in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grafing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Ooh, yeah. All right, let me get our Discord started. Look at that timer there. 23 hours, 58 minutes. About to be a long one. All right. What's up, Zach? Zach, you're always up so much earlier than me. So let me get my chats working, actually. Let me get all these things working. There we go. Shorts. Good. Let's get TikTok going. I'm up at 6 a.m. sometimes because I have to. Oh, no. I'm guessing that's because of the children. The chillins. The chillins make it necessary sometimes to be up at 6 a.m. Also because you want to. I don't know if I ever want to be up at 6 a.m. Unless I'm staying up until 6 a.m. Then I'm okay with that. Alright, let me make sure I have my... This 3-hour playlist is going to play 8 times. I maybe should have came up with like more music, but whatever. We're just going to keep it running. What's up, Amy? All right. Let me see. And then also, yeah, you made an announcement in your server. I love that, Zach. Let me see. What time did you say you were going to come on? Nice. 1 p.m. my time. Okay, perfect. That's great, actually. So you'll be coming in at the 4-hour mark for me. Love that. Awesome. I think, yeah, if we want to do like the handoff for that, if you just want to hop my Discord like when you want to like come on, and then I'll just like announce you or something, and then you can go to your own stream and Discord and stuff, and I'll just hang out and chat and stuff. Wow, we already got questions. Look at this.
Oh, yeah.
We already got questions coming in, dude. The queue is already becoming full of questions already. Look at that. With the first question at 8:59. Wow. Yeah, unless you can't do them. Totally cool. Yeah, so... Queue kind of long? No, the queue's only one question right now. We're about to do a 24-hour stream. Well, we're doing it right now. We're doing it right now. It has started. But yeah, Zach, I'll just... You can see things in the queue. Or if you want, I could put them manually in. But you can see them anyways. You just do your stream how you do your stream. And then whenever you finish a question, I'll throw it in the Discord for me, and then you can post a solution later if you want. You just joined my stream. Okay, great. Cool. Oh, perfect. Okay. All good. Super easy. Yeah, then just join my Discord. Love it. You just started a new chapter in physics? Hell yeah, Jay. We're here to help you out. Sean says, do I know partial differential equations? I do not.
Disqualified.
But E the 2I pi, Zach, who's in my chat right now, will be taking over questions at 1 o'clock. So in about 4 hours. And he knows PDEs. I think he does. So he can help you out. Gold didn't even buy dinner. I'm sorry, Poison. Let's see what we got so far already in the queue. That's crazy, dude. I start streaming at like 9 a.m. I usually don't wake up this early to stream. I usually stream at like 4 o'clock in the afternoon. It's 9 a.m. right now. How do I do a third order ODE? Oh wow, you guys are getting... Well, it depends if it's homogeneous. It's not too bad. Anyways, yes, welcome. Today is Giving Tuesday, which is the charity response. Oh, we already got a fucking donation today? What the hell? Wait, one sec. I posted this last night. Where do I go? I think if you go to our website here, which is where you guys are going to submit questions. Like, you can always put your username, drag a screenshot in. Click on donate. That should have our... Oh, wow, we're going to get $50. Oh, nice. Anonymous, dude. Don't be anonymous. Tell me who you are, please. Okay, love that. Anyways, yeah, we are doing... Giving Tuesday is supposed to be like the charity anti-capitalistic response to Cyber Monday and Black Friday. I only found out about it from my other like big charity friends. But in the spirit of that, we're going to be giving back the way we do the best, which is we're going to be just doing free tutoring all day, all night, 24 hours. I think the longest I've done is 10. So we're going to see if I can do 24. I have help. What's up, Bob? I have some other awesome friends who are going to hop in and help us out with questions, because my brain's going to turn to mush. My brain is going to turn to mush. How much did you sleep? I got a solid 7 last night. Solid 7, solid 8 hours. I think I went to bed like 1:30. I had some weird dreams, though. I don't know. My friend was like, you're missing 2 days, because I'm going to miss 2 days of the gym now, because I can't go this morning. And there's no way in hell I'm going to the gym tomorrow morning after I finish the stream. He's like, oh man, you're missing 2 days of the gym with me? So I was like, yeah. He was like, you could work out before your stream. I'm like, no. I'm not, dude, I want to be up 24 hours on the dot. I don't want to be up an hour longer than 24 hours. How early is this for you? This is 9 a.m. So not too bad for me. Los Angeles time. Is there any AI that's actually good at doing math? Yeah. I mean, ChatGPT is actually pretty solid at math. I think the latest Gemini is pretty great too. But yeah. Ooh, let me post this also in the Twitch Creator Club. Tell them what we're doing. Tuesday. Okay, I posted because we're in the charity club now for Twitch. Yes. Okay, I got in early. My question's gonna be answered today. Yes. Well, we have 24 hours to answer all your questions, so don't worry, we're gonna get all of them. What about writing reports? There's AI that gives if I give it data. I don't know about, like, you mean like doing like a lab report? I think if you give it enough instructions, it can definitely do it. Also, there's this feature called deep research on AI that allows you to spend more time analyzing through things. If you give it like instructions, be like, here's this data, how would you analyze it? And then it tells you what to do, and then you go step by step, being like, okay, here's this data, like, do a correlation analysis, do this, do this, do this. It will do it. Jesus is Lord and he loves you. You repent before it's too late. Everyone, thank you. I've been baptized. You have a test in 40 minutes. Oh, okay. Omar, which one was your question, by the way? Because I will say, we have some awesome other friends, actual educators, who just go through and like do questions. Which one was yours, Omar? Are you in our Discord? These are all the questions that got answered yesterday. I think almost all of them did. The dynamics and kinematics question second in the queue. Oh, that one. Oh, I can help you out with that one right now. Yeah, let's do it. Okay, cool. All right. I'll make more announcements throughout the day as we go. But let's start off the stream, get you guys some help. And then let's kick things off. All right, here we go. All right, welcome to everyone Office Hours. My name is Dr. Gold, Actual Education, stream that helps you with math homework, science homework. All sorts of fun stuff. We're doing a 24-hour stream today to help everybody out with finals. Final exams is coming up. We're here to help you guys up. What's up, Justin? Yeah, we are live. Yeah, we're live, dude. What's up, Ethan? Let me see what's in the queue.
Hey, Dr. Gold. How's it going?
Good, man. How's it going, dude?
Well, I have to say, look, after all that I've been through, I'm finally on my holiday.
Nice,
Finally
dude.
on holiday.
You're finally on winter break, dude? Hell yeah, dude.
Winter break, a whole month.
Oh, wow. That's awesome. What are you gonna do? What are you gonna do with a whole month of holidays?
Well, no, not too much exciting stuff. Sadly, like, my parents, or well, my parent and my brother is just going to. They are going to go to abroad again, but I'm not going. It's just going.
Are they going to Denver? They're going to Denver?
Yeah, they are. They are.
Oh, that's cool.
But
I wish I had another like Nintendo Switch to send you back home with. Would that be fun? Right?
Well, give me the first one, not the second one.
Yeah, there you go.
But like, you don't need to worry about that. Like, to be honest, I'm very content with this thing, with this.
Oh, hell.
Switch too. I really love it. I really do.
Send me the Switch, gang, dude. Justin says, "Send me the Switch."
Okay, well, yeah, I mean, like, you know, now that I'm just relaxing here.
Nice, Jay. I see.
I'm actually going to get my report card too. You know.
Sick. That's dope, dude.
That's dope.
Do you know how you did? Do you know how you did on it?
That's the thing. It's like, how do I say it? I think I took 7 courses throughout this year.
Mm-hmm.
6 out of 7 of those, they were 90s. They were just straight up 90s.
All right, that's pretty good.
But then the last one was definitely proving to be something else. Like, bro. If you look in our chat, I just said what I didn't want to say. Bro, I didn't even realize until I see that word, that number, bro. Oh
6, 7, dude. It's here, dude.
I said 6 out of 7, not 6.
6 out of. You said 6 out of 7. No, Edward, they got you, dude. They said you said 6, 7, dude. You said it, dude.
Really, I had to be called out for this.
You got called out, dude. You got called out.
Whatever. All right, but yes, 6 out of 7 of those were A's. 90s then. 90s.
Nice.
Yeah, but the last one was definitely something else. And like, if you remember back in the chat, it was that same subject where I had to cheat on an exam.
Yeah, well, I mean, you said like look stuff up. I mean, it's like kind of cheating, I guess. I don't know.
I mean, I literally looked at keywords, so I just knew what it was, and then I just memorized it into my head and copy and pasted it. I was just completely zoned out by the time because I just want to be on holiday already.
They were all A's except one. I like that. That's another way to say it. Yeah, you can say they were all A's except one. That's a better way to say it, so that you don't accidentally say 6, 7.
Well, then you could say that. Okay, you could say so. But like, seriously though, now just yesterday, I was literally contemplating on that exam, thinking if I even got a lot correct because I just didn't know what I was doing so much. So like, it's really just a question of whether I will get into the 90 or not.
I think you can. I think you'd be close to it.
I really do hope because this is like
we are live, Amir, all day, Amir.
All day you'll be live? What the heck?
Yeah, we're live for 24 hours today. One second, let me catch up on chat real quick. I got 6, 7 in lab today. Oh no.
Really? No, not that number, man.
Will says, I failed my method of calculus. What is the best way to go about studying math? You're not bad at math. Best way to go about math is by doing problems. Literally what we're doing here all day, just doing problems. That's the best way to get math. Ethan, how do you think you get good at math?
Yeah, to be honest, I agree with what you say. I do the problems. I just find problems online and then I just do
Yeah,
them.
exactly. Be proactive, find problems, do them. These days, you can get AI to generate problems and just like do them all day.
It's better to be proactive rather than reactive, is what they say.
Exactly. It's better to be proactive than reactive.
Good job.
No,
I like that. Proactive
Proactive.
than reactive. I like that. That's a good way. That's a good way to say it.
Seriously though, yes. I'm really hoping and wishing and praying I do. And geez, I've been hearing about other girls saying that they did so well on other classes. Is like they think that they'll get 4.0s. I want that 4.0. Okay,
That's yours, dude. It's yours.
My man.
like that. I would hope for. Okay.
Mm-hmm. Nice. That's
How long are
good.
you going to be for?
I'm gonna be live for 24 hours. So yeah.
Really?
Yeah, I'm live for 24
You
hours.
skip a whole day just for us?
Just for you guys.
My man.
Yes, just for you guys.
All right then. Well, save this to like. Let this be like an archive then. Like
This is a momentous thing. Hey, what's up, Eric? Good morning, Tutoronies. Good morning, Eric. How's it going? Good to see you, dude.
Might as well I grind up some channel points while I can.
Yeah, you can, dude. You can grind channel points all day today. we're gonna be online for a while.
But geez, Twitch has updated so much that I don't even know how it works anymore. Like, oh my gosh, I haven't been on this.
Oh,
for
they have
so
like a new
long.
app and stuff. Jay, I use Group World. Group World is what I use. Group World. People always ask me like what whiteboard I use. It's this website. They're so old school. Group World. Yeah, this is it. Powerful, cost-effective, secure web conferencing. I think I started this back in like 2014. But I just keep paying them 25 bucks a month. And I don't know, it just works. I've never had a problem with it. I just write it off as a business expense at this point. Nice, Ethan. That's fun. What are you gonna do on your first day off? Are you gonna go relax, go to the beach or something? That's what I would do.
I'm in Belize. What? How can I go to the beach if I'm in Belize like that?
Wait, isn't Belize like right next to the beach? No?
Oh, you can say so, but I'm in my house. My parents are out at their jobs right now, so I'm literally stuck in my home. Literally.
Dang.
I got legit no one to hang out with, so you could say I'm pretty bored.
Well, you can hang out with us, dude. We'll be online here all for quite a while.
I'm just thinking.
All right, nice, Amir. Great, dude.
I'm just thinking if I should just play games or something because oh my gosh, I don't want to be bored to death for the whole day.
Yeah, well, you did win that Nintendo Switch, so go have some fun with it or something.
Yeah, I mean.
What's up, Taco?
I have a PC as well, so
Good.
there's that.
PCs are fun. All right, let me. Yeah, I appreciate that, dude. Thanks for stopping by, Ethan. Come by later in the stream, dude. I mean,
I think I'll stay here for a couple of minutes just to see how things are.
Yeah, for sure, dude.
Wait, you think I can actually help out with some math questions? I'm not too bright in it, but I don't mind trying to see how I can help out because
look to see what's in the queue.
Oh, really? This is
where the queue is?
No.
Look in the queue. Look in the queue. If you go in the queue here, yeah. If you go to www.actualofficehours.com. This is a dynamics question we're gonna do later. Okay, and then Jay's got some physics stuff.
Please?
Yeah.
Say it again. www what?
Here, I'll post a link here. It's in the chat. Well, that one works too. Yeah. Yes, I got it, guys. Got all the questions. All right, here. Let me wrap this one. This one was from V. So they asked us. This is a transformation from XY to UV. So we had U in terms of XY, V in terms of XY, but then they wanted X and Y in terms of U and V. So all I did is I just kind of set this up as like a systems of equations, and I did like the elimination method to figure out X and to figure out Y. Then they asked for the Jacobian. So the Jacobian is usually kind of like a surface area element thing. That's kind of how I think about it. Whenever you want to integrate something in like a parameterized form, you use like the Jacobian as like the correction factor, I feel like, for like the dv or the dA part. That's how I would describe the Jacobian. You tell me if I'm right. What's up, Math Fanatic? Good luck today, Dr. Gold. Thank you, dude. I mean, we're 20 minutes in. I feel great. I got my Sammys. I got some sandwiches. Some little breakfast sandwiches I'm going to eat later. Or I'm eating like during the stream. It's alright. I have help. Zach's going to relieve me in like 4 hours. So, for a little bit. And then I'll probably eat some lunch. So cool. I think this is the Jacobian. I believe it's like dx and then reference to your two parameterized variables, and then dy parameterize to your two parameterized variables, right? But then they say, like, let R be a parallelogram in the xy plane with boundaries -3, 0. Oh, y equals x plus 1. Sketch the image in the UV plane by mapping the region. So wait, why did I calculate Jacobian? What? Why did they make me calculate? Usually I calculate this because I need to do like some area thing eventually. But okay. Let me like pull this down so I can like see this. Yeah, what's up, Sam? Good morning. Good morning, Sam. All right, let's see. I have to plot. So in the XY plane, right? That's at x equals 0. X equals -3. And then y equals x. Okay, so that's just this, right? And then they say y equals x plus 1. Oh. Wait. X equals -3. How's that going to work? When y equals 0, x equals 1. Wait, when x equals -3, y equals -2? I believe you use the Jacobian as a linear transformation matrix. Yeah, 24 hours of math. My brain's about to be like absolutely fried. Oh, wait a minute. I think I see what we're saying. Sorry. The boundary is x equals 0. So it's actually this. Uh-huh. Got you. Is this the parallelogram? Well, parallelogram means... Sorry. Means everything's parallel. So like this. Okay, there you go. That's what I wanted. Sorry. This is the parallelogram. And then it's like I believe. Yeah, there we go. This is the parallelogram. Okay, that's it in the XY plane. Or YX. But then they want it in the UV plane. So interesting. Am I supposed to use this to do it? I mean, I could just like plug the points in. It's kind of annoying to do that though, right? ChatGPT could solve it in 3 seconds, maybe. I feel like there's some unique trick here that I'm not seeing. How to map this? I mean, I can just manually say it. I can just be like, oh, if you can map these points, I know these corner points. I can map these corner points basically to like where we are. Right. So because what I have here is this is 0, 1. This is 0, 0. And then we have -3, -2, and then -3, 0. Or sorry, -3, -3. No, you just use the equations. A linear transformation will it should stay as a polygon. Is that what we're saying? Because this transformation matrix doesn't depend on x or y. Oh, okay. Or u and it doesn't depend on u or v, I guess. Yeah, okay. I think I see what we're saying. Okay. So if you wanted to map this into the UV plane, you just use these equations we have. Right? I think I'm seeing the magic now. I stopped linear algebra. I don't think I'd survive physical. You could try, dude. If you want to just keep this stream open for 24 hours, you too can join the fun, which is 24 hours of math. What's up, Kato? Okay, let's get this real quick. So for 0, 1, so x is 0, y is 1. So that means u is equal to -3. And then v is equal to 1. So -3, 1. That's where the first one goes. So well, I need like a little bit more space here. So here I'll map the points by colors. So -3, 1. It's probably like right here. 0, 0 is also going to go to 0, 0. That's fun. That's easy, right? 0, 0 is just 0, 0. Beautiful. These get a little trickier. -3, -2. Okay. Well, for you, that's going to be -6 plus 6. Oh, that's 0, 0. Right? Yeah. That's actually kind of weird. Right? -6 plus 6. Math was definitely one of those reasons. Oh no.
That's dope.
Or sorry, it's not 0, 0. Sorry. The first coordinate is 0. U is 0. This is not 0. That's 3 minus 2, which is 1. Cool. Got it. Almost made a mistake. And then this would be -6 plus 9, which would be 3. And then that would be 3 minus 3, which would be 0. Okay, cool. Got our points. Nice. Okay, so the orange point here is now at 0, 1. That's here. And then the other one is at 3, 0. Super weird. This thing got all messed up, dude. 3, 0. Okay. So, I mean, I think we can kind of see, like, some sort of flipping and rotation happened anyways. There are some pretty standard transformation matrices. Here, let me show them. There's some fun ones. Where are the fun ones? Matrices. Yeah, it's matrices. I know, technically. Where are the standard ones I'm looking for? You know what I'm saying? Like rotation. Like the 90 degrees. Here, is this some of them? Yeah, these are like some flips and stuff that are happening. But I want it in just 2 dimensions. This is like 3 dimensions. Or I guess they just keep the last axis. Morning, you beautiful gold bastards. What's up, Ben? Good morning to you as well. I haven't had my morning coffee yet. I'm saving the caffeine for when I really need it. I bought like 4 Red Bulls at the grocery store yesterday. Transformations, my beloved. Yeah. So these are the transformations. These are cool. These are kind of like some of the standard ones. So right, yeah. This doesn't change it at all, I guess. This is how you do a linear transformation. Okay, you need something in like the Z column. Oh, that's cool. This is scaling. Okay, so scaling is when that gets multiplied. So we obviously did some scaling, and we can see that, right? Look. This thing looks like all weird. It's still a parallelogram, though. What the strange version of matrices? Yeah, these are transformation matrices. So the cool thing is, yeah, this actually didn't change the shape of it. Right? We definitely scaled. We probably did some sort of rotation, it looks like. And then maybe some shearing happened as well, right? Because if the off diagonals are changing. Yeah. Okay, cool. Nice. All right, cool. Good question there, V. I appreciate it. First one of the day. One question down. How many do you think we're going to do today? I should have put a counter up or something. Put a little, like, we've done one question. We're going to do yours right now, Omar. You're next. Max, right? Is your name? I'm going to do yours right now. Let me just save this one real quick. And then, sorry, let me post this. No, that's that. Where's my, what? God damn it. There we go. That's what I want. Add my console. And then Jay, I got you. You're next. After Max. After Omar. Already making mistakes. Alright, let's see. I got A, but C is confusing. Vibe code counter right now. I think what I can do is I can have a bot go through and analyze all the screenshots I got submitted. Dude, I love this. Wait, how will linear algebra describe sheared sheep? Wait, wouldn't this sheep technically have no more fur on it if it was sheared? Right? That's funny. All right, Max, let's see. During a getaway, the gas uses a pogo stick. Oh, wow. How many of y'all have actually, like, tried a pogo stick out? I don't even know if that's a thing anymore. I feel like that's one of those old-timey, like, 1920s thing that... Your kids are kind of... Yeah, no. I was pretty good at pogo sticking. It's pretty fun, actually. Yeah. Okay, during a getaway, the Joker uses a pogo stick to reach a ladder dangling from the helicopter above. If the pogo stick has a spring constant of that, and he compresses at a distance of 1 meter, with what acceleration will the pogo stick apply to the Joker if he has a mass of 70 kilograms? Cool. Well, F is equal to KX, right? It's technically negative K delta X, but I just say, like, the force is applied in the opposite direction that it's compressing. So, in this case, if you have Joker and, I don't know, I'm going to just model the poker stick, the pogo stick like this. And then suddenly it's compressed by this amount. Let's say like delta X. Then there's a force upwards that's equal to that. K delta X. Technically delta X is negative in this case. So that's why negative means the force points up, but don't worry about it. Skip a step. Okay. So K delta X. So yeah, that's just 7,500 times 1. Oh, thanks Salvador. The laughing disco. That's fun. 7,500 times 1. That's equal to the force, but force is equal to mass times acceleration, right? So if mass is 70, now, but that's not the net acceleration, right? Because he also has gravity hurting him. But this is it's kind of a weird thing for him to say, what acceleration will the pogo stick apply? Yes, okay, good. Yeah, I don't know about, like, exactly. Yeah. So, okay. This is the force of the pogo. And that force is up, but you still have the force of gravity pulling you down. Where do you upload your questions? Actualofficehours.com. That website right there. Okay, so then sum of forces, which is equal to F net. So that's going to equal 7,500 minus mg. That has to equal ma. So that's going to be m times a. Okay. So 7,500 minus 70. Can we just use 10 for A, just to be, like, nice for G? I know, it's sacrilege sometimes. I'm just gonna do it. Okay, so you get 7,500. Well, you know, that's interesting, Mathematic Fanatic. Yeah. That's why I'm a little confused when it says, what acceleration will the pogo stick apply to the Joker? I think they want to say what force will the pogo stick apply. The acceleration depends also on gravity. The answer key has it's a poorly worded question. Teachers these days, dude. I tell you, man, dude. Yeah, okay. So 6,800 is equal to 70A. Divide by 70. Divide by 70. What is that? That's a very, very... Dude, that's incredibly fast. Sorry, what? Wait, what? 97... Dude, that's way too fast, dude. What? 97 meters per second squared, dude? What? Excuse me? That would, like, rip your organs out. This is not a good... You're not gonna have a good time here. What? Bro would become the joked. Yeah, dude. Yeah, you get fucked up, dude. What? This is okay. Teachers, when designing questions, need to be better about putting realistic numbers. Like what? We love math questions that don't make sense. Yeah, that's huge. Okay, whatever. If the Joker is accelerated at a uniform rate by the spring as it extends, with what will be the speed he is launched off with? A fuck ton, dude. What? So this is a little tricky because we have to take into account gravitational potential energy too. Yeah, without gravity, it'd be even worse. Yeah. Yeah, I mean, but the gravity only provides 700 newtons. You have to use kinematics, not energy. Fine. It's technically not correct, though. Because there's a lot of things wrong with this. First of all, he's not accelerated at a uniform rate. Because F is equal to K delta X. So as that X gets shorter, the acceleration becomes less. So again, this is another poorly written question because acceleration is not uniform. But okay, we'll pretend it is. So I guess what they're saying is they want to use this. V squared is equal to V naught squared plus 2A delta X. And they want to like shove this into here. And then delta X is equal to a meter. Yeah. And then this is equal to 0, right? So you get V squared is equal to 2 times 97 times 1. Again, it's not really correct. But for the sake of your teacher, we'll do it anyways. Okay, so that's 14 meters per second, okay? Which isn't bad. I think that's like 30 miles an hour or something. Yeah, you would need to integrate over time, correct? The easier way to do that, Mathematic Fanatic, would just be to do it at conservation of energy. Conservation of energy takes into account all the like acceleration changing as a function of distance. Okay, it's 13.95, whatever. Okay, it's fine, it's close enough. How high would the Joker reach? Okay, great. So this is where, like, I wonder if we're going to add the 1 meter, but okay. So this is now a kinematics question. It is, yeah. Conservation of energy skips all the calculus with algebra, correct? Yes. Physics can't use calculus to simplify stuff into algebraic expressions. It's pretty cool. Yeah, we'll see. So if the person's a meter, right, and they have a V naught equal to 14 meters per second, right? They want to know how high do they reach? Okay. Well, this you can use the same equation actually. You can use this as well. Because now you're just figuring out where the velocity is equal to 0. And then there's no more acceleration due to the pogo stick once he's been launched off. Okay, so you set this equal to 0. This is equal to 14 squared. And then this is now going to be plus 2 times negative 10. Because gravity is negative 9.8, I know technically, but I want things simple. Indian, just use the actualofficehours.com. That's the website down there. Or if you hit exclamation point submit, it'll tell you. Bum, 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 bum. No, they can be derived. Yeah, energy is defined as like the work done, which is the force times the distance. So if you integrate f dx, you get energy back out. I can show that later. It's actually pretty cool. All right. he said it was 13.95, so let's use that 13.95 just in case. I don't know, there's some like carry through errors. Yeah, I can show you, dude. It's really cool, actually. 13.95, and then we're gonna divide that by negative. Well, we're gonna divide that by 20 because I'm gonna move that on the left, and then it's negative, and then I'm gonna divide by negative 20. So just divide by 20. So I get 9.73. 9.73 meters. So max height should be 10.7. The answer was 5.5. No, it's not. I don't think so. Well, I think your teacher's silly. Yeah, it's okay. I mean, your teacher already said that you would have an acceleration of 97 meters per second squared, which is like, what? There's already some issues. Wow, Abdul, thanks for the donation, dude. Kicking shit off. Nice, dude. What's up, Femistral? Hey, nerds. I'm doing great, dude. We are 40 minutes into our 24-hour stream. 9.7 meters per second squared. No, this is just meters. Even ChatGPT was confused. Yeah, so when you're solving for delta x here, right, this is going to be in meters. These things were in meters per second squared. But that meters per second, but then this is meters per second squared, and this is when you divide out, you eventually just get meters. Yeah, don't worry, Omar. I think your teacher's just wrong. Which happens, like, you know, I'm wrong sometimes, for sure. Yes, semester I am. Yeah, we're going till tomorrow. We're going even further beyond. Real quick, for people who if you want to see, like, why this works for energy conservation, I'll just show you. So, energy for a spring is equal to 1/2 K delta x squared. Okay? So let me get the calculator out of the way, sorry. I think they're wrong, Omar, and I think even if ChatGPT is like, yeah, that's a pretty simple thing. It's okay. Teachers just maybe 7 years of teachers made mistakes, which I don't know. So this is the energy for spring. Work is defined as the integral of force dot dx. Yeah, watch him struggle, dude. Do it. Tell me what he does. So, for a spring, F is equal to, like, negative kx. Okay? So, if we integrate negative kx dx, this is a pretty easy integral, right? And then, let's say this goes from some x initial, xi to xf, right? xi to xf, okay. Then what you get is you get negative k, and then this is x squared over 2, xi to xf, which is the same thing as negative k, what is it, x final squared minus x initial squared. All over 2. And if you call x initial equal to 0, and then x final is your delta x, this gets you the same 1/2 k delta x squared. So that's how energy comes out from work. And I think the change in energy is like the negative work done by the field. So technically that's where the minus sign would come away, because then I think it's this. Energy done, this also comes from U is equal to negative grad F? No. F equals negative grad U. This is another big thing in physics. So the force from a field is equal to the negative gradient of the potential of the field. So, for instance, you want to make this kind of work, right? The force of gravity, right, is equal to mgh. Well, it's negative mgh, right? It points down, and that makes sense because that's the gradient of the potential. So potential energy of the field, which potential energy for gravity is equal to mgh. And do you see how the gradient of this pulls the h out? Oh, sorry, this is just mg. Yeah, sorry, that's what I meant to say. Force of gravity is negative mg, which comes out of taking the gradient of potential energy from gravity, which is mgh. Bum, bum. Yes. Well, here, I'm done with this one. Let me help Jay out. And then, yeah, we'll keep on the subject of springs, because this is fun. Nice. Okay, cool, Omar. Go tell your teacher they're wrong. It happens. It's all good. Bum, bum, bum. All right, mechs. Nice. Cool. Good question, Max. All right, let me see. Jay, I got you. This is also kinematics, which is fun. Doing a little bit of physics today. All right. An acrobat is launched from a cannon at an angle of 60 degrees above the horizontal. It's caught by a safety net at a height which was an inch. Wait, what? Is caught by a safety net mounted horizontally at the height from which he was initially launched. Oh. Oh, okay. I was like, wait, what's going on here? Okay, I see it. The acrobat is being launched from here. Let's just say that's 60 degrees. And then 26 meters per second. And then, yeah, it's a symmetric. Yeah. The net thing kind of messed with me. But yeah, here's what they're saying. They're saying that the net right here is at the same height. Okay. How long does it take before he reaches his maximum height? Because this is symmetric, right? The max height happens at the halfway time it takes for him to like reach the ground. Which is halfway back down to the ground. Oh, interesting. Okay, so then they want this like right here. Oh, fascinating. Okay, fine. Okay, to figure out maximum height, that's when your velocity in the y direction is 0. So we're going to say Vy is equal to Vy naught plus AT. Vy is equal to 0. Vy naught is going to be 26 sine of 60 degrees. Right? Because that's the y component of this velocity. And then AT, so we can say minus 9.8 times t. Okay. So then t is just equal to 26 sine 60 degrees over 9.8. So let's just get that real quick. And then yeah, I'll show you the next part. It's not too bad. 26 sine 60 divided by 9.8. 2.3 seconds. Okay. How long does it take for him to reach a point halfway back down to the ground? Okay. Interesting. So you need to figure out when he's here. Which is, it's not going to be, I know like this is the halfway time. It's not 3/4. Because it's the height is not linear with time. Okay. I think what you need to do first is you need to figure out what the maximum height is. Right? So if you want to figure out what the maximum height is, so step 1, so here for part B. Because then we need to know, we know that he has to be halfway at that maximum height. I could do this with conservation of energy, but I don't think you're allowed to use conservation of energy. So I'm not going to. So the max height occurs from y is equal to y naught plus v naught yt plus 1/2 at squared. So y is equal to 0 plus 26 Do we just solve the triangle at that side? Yes, user, I can definitely help you. Max height, because Vy at that point, max height is equal to 0. Yes, Vy is equal to 0, but I want to figure out what the position is. So you want to use this. This equation will tell me how high this is. And then I'm going to use this to set it to like half of that. To then find how much time it would take to get to the half height. So, and I have the max height because I know how much time it takes to get to the maximum height. It's 2.3 seconds. So I can plug that in for t. And then this is minus 4.9, and this is going to be 2.3 squared. Unless someone sees an easier way, I think this way will work. Okay, so you do 26 sine 60, which was this number, times this, minus 4.9 times this squared. So that gets me 25.9. So y max is equal to 25.9. All right. And now if I want to figure out halfway back down to the ground, I'm gonna say that like y halfway. Peepoo, what's up, Machine Rex?
Oh, yeah.
You can do 25.9 divided by 2, right? This will be the halfway to the ground, right? Because all the way up is 25.9. Halfway up, which is also halfway to the ground, is 25.9 divided by 2. So that gets you 12.93 meters. Okay, so now we're going to use this equation again to figure out at what time is the ball at 12.93 meters. So I can plug this in for now my height. So I say 12.93 is equal to 0 plus 26 sine 60 degrees. Yes. Yeah. That definitely works. Yeah, Ziza, that works because it's a parabola. You can also use this. I feel like this is also just using negative b over 2a. But that's if your kinematics equation is in standard form, which ours isn't. It's better just use the physics. And then this is minus 4.9 t squared. Okay. This is not the easiest thing in the world to solve. The Dirac equation. Oh, I mean, you can try it. Yeah, you can submit quantum mechanics. I can try it. Okay, Jay, do we understand this so far? Are we cool? Okay, great. So yeah, this is a quadratic equation that you need to solve. What was 26 sine 60 again? 22.5? Okay. So you have 4.9 t squared minus, this is 22.5 t plus 12.93 is equal to 0. I'm going to assume you know how to solve a quadratic equation. But if you don't, I'll do it anyways. Whatever. Okay, so x equals negative b. So that's going to be 22.5 plus or minus the square root of b squared, 22.5 squared, minus 4 times a, which is 4.9, times c. Good. Quadratic form, yep. I would just do it with the calculator, but I'm not sure if your teacher allows you to do that. And then all over 2a. Okay, so let's just get that. So she wants to see everything. That's annoying. It's okay though. Okay, it's that. Here's the cool thing. Do you notice how this is a plus minus? Do you see how this is a plus minus? Right? That means we're going to have a solution that's 22.5 plus something. And then we're going to have a solution which is 22.5 minus something. The reason why there are two solutions is because there are two different time points when the ball is halfway to the ground. So when it's starting to go up, it's going to have this. This is like T 1/2, but like the first one. And then also when it's coming down, it's also going to have a time where it's halfway to the ground. This is the greater T. So when I do my quadratic equation here, I'm going to want the bigger solution for T. So I want the bigger T. So I'm just going to, we want this one. Like, color it. Yeah, we want that one. So I'm just going to do the plus one just because we want the greater time anyways. So square root, and then that's going to be 22.5 squared. It's a quadratic. And then minus 4 times 4.9 times that 12.93 as well. Or we can get rid of this. Okay. And then we're going to divide that by 2 times 4.9. Which is the same thing, it's just G. Nice. So that gets us 3.92. Okay. Or so, sorry, this is really like T equals. So T is equal to 3.92 seconds. And that's your answer. These are projectile motion equations. Yep, this is a standard kinematics question. Nice. Does that make sense to you, Jay? How we did it? Yeah. Yeah, so here's what I'm going to do. You will get the solution on Discord. I'll show you where. So, anytime any of our questions get done, I save them here. And then we're going to mark this one as done. And you'll see it pop up here in the Discord. Where is it? There's your question. And there's the solution. Nice. So yeah, make sure, if you're watching us right now, go check out our Discord. So the same website you guys are using to submit the questions, there's a button here to join our Discord, and that's where all the solutions I go through will be posted. Okay. Yes, it is basically the same. Let me see, Jay. Let me help out some of the other people in the queue. I try to do at least one question from each person, but then if I have time, I'll go back and do your other ones. If we don't get to them, don't worry. They'll also get posted in, and also I have 24 hours. Like, I guarantee you, like, I'll have time to go through these. Yeah. Yes, you do take the cosine for the vertical. No, you take the sine. Well, it depends on the angle you're given, Akram. Right? It depends what angle you're given. If you're given the angle of elevation, or I guess either one is, but there's some other weird ones. Okay, limits. Oh, these are fun. This is from Millie. There's a very, like, easy rule for this. Right? I feel like there is. I think you always just divide the top and bottom by the highest power of n. Right? So, for instance, with this one, I just divide by n squared. I divide by n squared. Which would get me 3n squared over n squared minus 5n over n squared over 8n squared over n squared plus 4n over n squared minus 1 over n squared. So this goes away. This is just 1. This becomes 5 over n. This just becomes 1 times 8. This is 4 over n, and this is 1 over n squared. And then as n goes to infinity, This one goes away. This one goes away. This one goes away. So you're just left with 3 over 8. Yeah. I don't know what the arithmetic of limits is, Millie. But yeah, this is just 3 over 8. Same reasoning for this one. They both have the same highest power, n cubed. So this is just equal to negative 6 over 2, which is the same thing as negative 3. This is a little trickier. So square rooting something is like taking something to the 1/2. Okay. So the highest power here, it's technically the highest effective power. That's n cubed to the 1/2. And a power to a power is like multiplying the powers. So really this is 3n to the 3/2 over 3n. Okay. In this case, this power is higher than this. So this is going to go to infinity. Reason being for that is that if I divide both things by n to the 3/2, right, over n to the 3/2, I end up getting, sure, this becomes 1, but then that becomes n to the minus 1/2, which then becomes n to the 1/2 on the top. Or actually, you could just like cancel these as they are. You don't even have to divide. This just becomes n to the 1/2, and as n goes to infinity, this will also go to infinity. This one's interesting. Okay, so again, just look at the highest thing on the top and the bottom. So this is square root of 5n squared, which is the same thing as square root of 5 times n, all over 2n. So all over 2n, n's cancel, and so you get square root of 5 over 2. This one, the highest power is on the bottom, so this is going to be 0. Because, again, it's effectively like n squared over 2n to the 3rd, which is the same thing as n over 2, or sorry, 1 over 2n. And 1 over 2 times infinity is just 0. This is the 3rd root, which is to the 3rd power. So this is the same thing as 2n squared all to the 1/3, all over 2n to the 3rd. So I see right away, this is going to be 2 to the 1/3, n to the 2/3, over 2n to the 3rd. This power is bigger than this, so this will also be equal to 0. So there you go. Yeah, that's how to do limits. Limits are fun. Pretty easy, actually. It's also called like end behavior or horizontal asymptotes because it's limits at infinity.
Well done! Well done!
Cool question though, Millie. All right. Let's see, Cowboy. You had a spring question? Ooh. This is a little bit more complicated than springs. This is differential equations. What was the hardest part about grad school? Ooh. Probably sticking with it is probably the hardest thing. My PhD took me 9 years to do. Mainly because my project got switched halfway through. Also, I wasn't in like a hurry to graduate. I was having fun. But not quitting is probably the hardest part. There's a lot of temptations to quit. But as long as you stick with it, like, you can finish it. What's up, Jeff? I'm using your 24-hour stream as background noise, but if you need me help, just say my thing. Yeah. Is there such a thing as too old to be in university? No. No, absolutely not. I mean, I think it helps to be a similar age if you want like the same social experience. But I had one of my best friends in college was, how old was he? He was 36. I was 18. But he's a very cool dude. And he had been in the military, so he was like going back to school. And he had a great time. I had a great time. And he helped me a lot throughout my undergraduate career. So, and now he makes tons of money working at AMD, doing like processors and stuff. So it's never too old to go to college. I agree. It's kind of weird if you're a little bit old. I mean, yeah, if you're like 50 or 60 and you're around a bunch of children, I agree, like socially you're not going to want to be like invited to the same parties and stuff, because it's just like kind of weird. You're just like, wait, what? I had this experience. I was at a concert, was it on Saturday, for a DJ. It's a UK DJ. His name's Notion. I like him. He does like cool, like kind of like synth pop, like Fred Again type stuff. But he's blown up a lot on TikTok, and so as a result, most of his fan base is 18. And I don't know, it's been a while since I've been to an under 21 show, but then I was reminded why I don't like under 21 shows. Because like everyone just had their phone out like crazy. Like no one would put their phones down. They're just recording the whole thing. I'm like, guys, put your phone down. I'm like, what? Like, I guarantee you someone got a recording of this. Also, there was just like fights breaking out. I'm just like, what? Bunch of fucking children. No, he did physics, Jay. You can do a lot with a physics degree. You don't have to do computer engineering to get into like processors and stuff. What's up, T?
Good job.
All right. Let's see this. Suppose an object stretches 0.5 feet in equilibrium and the gravity is 32, meaning that the undamped motion would satisfy this. Okay. Interesting way to write that, but sure. We add an additional damping force proportional to y prime, meaning the equation of motion is now this. Yeah, this is very much not a standard spring problem. This is about to become a Diffie-Q question. What conditions make this system underdamped, overdamped, or critically damped? The reason for this is you have to end up... So this is a homogeneous differential equation where you say y is of the form... and I'm assuming this is... I'm assuming y prime is dy dt. Right? E to the at, then y prime is equal to a, e to the at. Y double prime is equal to a squared, e to the at. And so if you plug that in, you get a squared, e to the at, plus ca, e to the at, plus 64, e to the at, equal to 0. Well, all the ATs go away, which is nice. All these ATs, right? That goes away, that goes away, that goes away. And I'm just left with a squared plus CA plus 64 is equal to 0. Okay. Cool. So you can now solve for A, because this is a quadratic. See how this is like something squared, something to the first, and then like not there? That's a quadratic equation. Thank you, Mall Talk. I appreciate that, dude. Yeah, so if you solve this for A, right? So A is equal to negative B, so negative C, plus or minus the square root. B squared, so that's C squared minus 4 times 64. And this is all over 2. This is where the whole conditions of like underdamped, overdamped, or critically damped comes into play. It has to do with the determinant here. So if C squared minus 4 times 64, which is 256, if this answer here is less than 0, we could use Laplace. But you can also, I mean, this is homogeneous. If this is less than 0, then A is imaginary. Okay. And if A is imaginary, then your solution is y is equal to like some like, I don't know, some constant like C1. Well, let's not use C. Let's just say like, I kind of, right, it's underdamped, yeah. Anyways, it becomes like something e to the minus it, okay? And then this, e to the minus it, this in physics means something that's oscillating. So that would be a case of something being underdamped, because it means it's still oscillating a lot. It doesn't decrease enough. If c squared is equal to 0, yeah, characteristic equation moment, I guess, yeah. Then a just equals negative c over 2, right? Because then this whole thing goes away. And I believe that's critically damped. So this is underdamped. This is critically damped. And then if c squared is, if c squared minus 256 is equal to 0. If c squared minus 256 is greater than 0, then A has 2 solutions. And I believe this is overdamped. You forgot the I for imaginary numbers in the square roots? I mean, that's what I did here, right? I said if this is less than 0, then this is imaginary, right? So that means A has like something with an I in it, right? Right, the bean? I think that's how that works. Yeah, you're good. Cool. All right. Okay. So that's that answer. But yes. Okay, suppose no, it's okay if it's Hungarian. I can always translate it. Or ChatGPT can translate it. Relatively easy, he says, though. Well, we don't know. We'll see how relatively. Can you do D? I'm gonna do this part real quick. You can use your math minor. You can help out like I do. Just like help people with their math and science questions. The Rankine cycle? Ugh. Is that like engineering thermo? Okay. Suppose it's critically damped, blah, blah, blah. Wait. Is there like a question here? Or I think maybe they want us to solve for y. Right? Yes, Java stock. I agree. If it's critically damped, A was equal to negative C over 2. So A is equal to negative 8. So then Y is equal to like some constant, and then it's e to the negative 8t, right? And then if you want to solve for this, this is kind of cool. So if y of 0 is meant to be 1, that tells me that c0 is 1, right? So y of 0 would be equal to c0 e to the negative 8 times 0. So c0 equals 1. Doesn't h repeat it? It's x e to the negative 8t. Add an x? Okay. Sorry, why am I adding an x though? You mean a t. Because if it's critically damped... Oh, I see. If it's critically damped, it means technically there's 2 repeated solutions. Is that what you're saying? Yes. Thank you, Java stock. Yeah. Yep. Okay, I remember. Sorry. It's this plus C1t e to the minus 8t. Got you. Okay, okay. Yeah. Yeah, okay, so yes. Great. I love that. Japa saw I got TikTok and YouTube agreeing with each other, which is great. Look at this. Look at the collaboration we're having across platforms here. But yeah, you guys are right. Because when I solve this differential equation and it's critically damped, so yes, this goes away, but technically this is a repeated root. And in differential equations, when you have repeated roots, you just like start slapping more t's in front of it. So I think if this was like a triply repeated root, I would then have like t squared on it as well. Yeah. You have Russian education? Nice. Russian school math is pretty intense. Okay, so let's do this. So sorry, let me fix this. So y of 0, which is equal to 1, that's equal to c0 e to the 0 plus c1 times 0 e to the 0. Oh, okay. So that still tells me that c0 is equal to 1. But then y prime of 0. Okay, so that's going to be equal to negative 8 c0 e to the negative 8t. All right, because I still got to pull this down. And then this is a chain rule. So it's plus c1 e to the negative 8t plus, or then minus 8 c1t e to the negative 8t. Cool. And then at 0, right, this goes away, this is 1. This totally goes away, this is 0. This goes away, this is 1. So I get negative 8, and then c0 is just 1. This is different. It's physics, but it is also differential equations. And then what did we say this was equal to? It's equal to negative 20? Okay, cool. So that means c1's equal to negative 12 then, right? Yeah. Okay, cool. It's actually, you know what's funny? RLC circuits also represent, like, springs. Like, physical things like springs being damped and moving back and forth also have the same behavior as, right, an RLC circuit. Pretty cool, actually, how that works. All right, so then this is just going to be, C0 is 1, so we have e to the negative 8t minus 12t e to the negative 8t. Okay. We did it. Good job, guys. I appreciate that. It was a kind of cool question. It was a RIP some PDEs. That's not a PDE, right? That's a regular differential. That's an ODE. You're welcome, boss. Cowboy. All right, Cowboy. I'm gonna post your question, the solution to it in our Discord, if you want to see it. So again, make sure, yeah, go join our Discord if you want to go see the solutions I'm posting for this. So, that was number 3. That solution looks scary. It was a little scary. Well, so it's funny. This is like the next evolution of springs. So I was working on a spring question with another student earlier. And then, yeah, Cowboy here was like, oh, okay, let's do mine. Mine's also springs. Not quite. It's differential equations springs. But anyways, there's the solution there. I posted it there for you so you can go see it. But it was fun. I appreciate, this was a great review for me on how to solve a homogeneous ODE. I forgot about the double solution. I definitely do physics questions. T says minus spring. Dude, what's with all the springs today? It's okay. Don't be scared. Newton's laws isn't that bad. Okay. Oh, this question, IJ. You did ask this one yesterday, dude. I didn't know how to solve this one. Did we figure out a solution for this? Need help with systems and signals? I may be able to. If I can't, submit it anyways, because I have a lot of other really smart people in my Discord, and they solve problems all the time. Like, some of them are engineers. Okay. And yeah, if you want to see any of the questions being asked, you can just click on anybody. If you click on anybody's username here, if you click on their username, their question comes up. Oh, wow. Well, that's fun. Escape stuff. And then, yeah. Oh, this is in Hungarian. I see. Cool. That shouldn't be too bad. Do you have any biomed engineers or comp engineers? I might. I mean, you asked a question. There's like 2,000 people in my Discord, so there's a high chance that there is someone. Okay. First 2 hours down, yes. Well, first hour and 20 minutes. Just 22 and a half to go. Yo, what's up, lads? Haven't seen you forever, dude. What's cracking? Having applied test optional last year, I just looked at the current DSAT at Blue Book, and damn, it actually is a lot easier compared to the paper SAT. Yeah. I don't know if I agree with them allowing Desmos on the SAT. It's just like everything becomes easy mode when you can use a graphing calculator to just brute force things. Some magic and you have a solution. Yeah, Joppa stock. Yeah, the kth derivative. But then what happens when it's not homogeneous? See, that's when things get weird. That's the particular solution versus the general. This is where I was tempted to just like plug in the values, just plug and chug. Like, I know it's not this, right? There's no way that like if x equals c, because that's divided by 0. And we don't like that. Right? Something divided by 0 is equal to 0 over 0 plus 39. I don't think that's going to happen. Yeah, I don't think it's this one. If it was negative c squared minus 39. Move the chunk from right to left and then factorize, Anch says. Okay, let's try that. Sure. Whatever. So you're saying I should say x squared over square root x squared minus c squared. And then if I move this over, that's minus c squared. Is equal to 39. And then yes, Anch, I do agree. This is a difference of squares. So this is x plus c, x minus c. Oh, wait a minute. Oh, duh. Over the square root of x plus c, x minus c. I attempted this one, Jeff, yesterday, and I failed miserably. Is equal to 39. Okay. First cancel. What do I want to cancel? I don't think I want to cancel anything yet. I mean, it's just this then, right? Isn't it just square root of x plus c, x minus c is equal to 39? Oh, wait a minute. Wait a minute. So then I just square both sides? Wait, I think I can just leave this. No? X equals not c. I think I can just leave it like this, right? I don't even think we needed to do this yet. Yeah, then you can just square it. Square. X squared minus c squared equals 39 squared. Oh, this is a lot simpler. X squared is equal to 39 squared plus c squared. Wait, what? Wait, whoa. Oh, and then I need x is equal to. Now consider the factors of 39 squared. Wait, can I just wait. Wait, isn't just x equal to the square root of 39 squared plus c squared? But that's none of my solutions. Well, I guess maybe it was this one. Plus minus, right? So, does this one work? Because it's technically equal to plus or minus this, right? Yep. Okay, but why is it not the plus solution? Oh, I see. Well, actually, I don't see. Sorry, what? Why does the plus solution not work? Wouldn't the plus one work? Because it's all just x squareds. Okay. I think D works as well. But I think also plus minus would work. Cool. Nice. Whose question was this? IJ? Desmond. Oh wait, this is an SAT question? Wait, sorry. Was this an SAT question? That's hilarious. Oh, no way. Okay, let me post that in then. That was IJ's was number 3. Yo, what's up, Ramton? Wait, why can't you come up on the stage? You have like mod perms. What? I need to figure out why that is.
I don't know why. I think I've lost privileges.
What? One sec. Let me give you just. No, you have associate professor, dude. That's like the highest fucking thing in my server. What? Okay, whatever. Hey, what's up? What, you got nerfed? You got nerfed somehow.
It's good. I've been working non-stop with tutoring.
Oh, dude, I know. End of the year is fucking nightmare, dude. Absolute nightmare.
Yeah. Anyone's looking for extra tutoring, I'm available.
Yes, dude. Anytime I have someone asking me for one-on-one tutoring, I just tag you. I'm just like, just go hit him up. Go hit that guy up.
Yeah, I've been looking into like some of the stuff for like YouTube, and like I've been playing around with CapCut. So
Nice.
I can figure out like some editing stuff. So that hopefully like after 20th, where the exam ends, I start to like make some videos and then.
Oh, good.
Hopefully I can maybe hop on and maybe like do some streaming on Twitch also.
Yeah, I would love for you to do that for sure.
Are you? I saw you're doing a 24-hour stream today.
I am doing 24 hours. Yeah, we're at an hour and a half into the 24 hours today.
Yeah, okay, well, yeah, I got it.
So I'll be around all fucking day, all night, all tomorrow.
Yeah, I'll try to hop on.
Okay. Nice. What's up, Justin? Wait, why is your mic super low, Justin? I can barely fucking hear you, dude.
Okay, I fixed it.
There you
Is
go.
this a 24-hour stream that never happened? Is that the makeup?
So we did a 10-hour stream for 10K subs,
Okay.
and then today's like Giving Tuesday or something. It's a big charity. You know, like Cyber Monday and Black Fridays for buying shit.
Okay.
So Giving Tuesday is apparently like the charity one. So I'm like, okay, cool. I'll do a 24-hour stream. I already got $50. Someone gave us $50. Thank you. So we're doing like kind of like a little charity fundraiser thing today,
yes.
and I said I'd do it 24 hours. Like, I don't think it's been done before. I don't think anyone's done a 24-hour tutoring stream.
That would be rough.
It is gonna be rough.
Yeah. I'll definitely. I have like. But let's see. I have another session at like coming up in half an hour.
Okay.
But then tomorrow morning, especially because like I don't think I have anything until your 9 a.m.
Yeah. That's when I'm ending. That's when I'm ending the 24-hour stream is at 9 a.m.
But
Yeah.
then I will be waking up at 8 a.m. my time, so it would be like your 5.
Oh, perfect.
Then,
yeah, come on by. I'll be up.
Probably, yeah. That's those end hours. Is gonna
That's when I'll need the most help, Ramton, dude, because my brain's gonna be fucking fried, dude.
Surprise, motherfucker.
I feel like doing math or physics for like 24 hours.
Yeah, I have some people helping. Like Zach's gonna take over for like 3 hours in this afternoon. Shout out to Zach. Love you, Zach. I think Penn Center might come by too. So
Yeah.
the stream will be up for
Penn
24 hours. I won't necessarily be doing math for 24 hours because other people are gonna like hop in at some point.
Yeah. Okay. Yeah.
I will be awake for 24 hours. I have lots of Red Bull.
Oh no.
Red Bull's
Oh,
weak
nice.
as fuck.
Red Bull's weak as fuck. Let me see. T says, "Bro, I have a physics exam tomorrow and I haven't started studying. I'm actually cooked." No, you're not. You still got time, and we'll help you out, T. I'm gonna get to more questions. Someone else was asking, "What's my thesis about?" So, if you go to the website, actualofficehours.com, same website, you go to submit your questions and things. If you click here on bio, that has a link to my thesis. There's my PhD thesis. If you really want to go read it. It was about like plasma. I did like plasma physics. Oh, go add me on LinkedIn too if you want. I need all the connections I can get on LinkedIn.
Bro wants another job.
I actually just signed a contract for a new job yesterday, actually.
W.
Thanks, man. Yeah, so I might be streaming less, honestly, because it's a full-time position. But
Oh, damn.
I said to whatever job I got hired from, like, I'm not giving up the nonprofit. I just might have to take some time away from it, because I have real adult stuff I gotta do. Work sucks. It's okay, but it's in the education space anyways. So it's not like I picked up a job at like fucking like Exxon or something, or like Goldman
Bro
Sachs.
got a job at SpaceX.
No, I got a job at like an education AI startup, which I'm cool with. It's education.
Oh, I know what you're talking. Like, kind of like with like, not Gemini. It's like those educational AIs that have been rising.
Yeah,
recently.
but those ones suck. But yeah, it's similar. It's similar. I'll let you guys know when I can talk about it. I had to like sign some
Yo, I just
NDAs.
noticed Ramton is nerfed, bruh. He doesn't have the shield next to his name.
Oh, what the fuck? Why is
Yeah,
that?
he's nerfed.
How do I make? How do I unnerf him?
What's
Just
the shield
give him
thing?
the role that I have. The whatever the one I got.
Dude, you have
The associate class rep.
associate class rep. All right, fine. One sec.
Just
Maybe-
trust.
All right, let me see. Oh, there you go.
Oh, look at that. Look at that.
Oh, okay. I had to give you a lower roll, Ramton, apparently for you to have that
Wow.
permission. I don't know why that was.
Wow.
Whatever.
Wait,
There's something wrong with our Discord.
What's the shield for? Is it like to be able to?
You're a moderator on the stage.
Oh, okay.
Aiden says, "What subjects do I cover? Anything math or science?" Here, Jay. I'm gonna do one of Jay's real quick, just because I know Jay's been waiting around.
Wait, so if I
Alright.
ask a question every hour, I should earn 22.
No,
bond
you can
points.
only get one per day, which technically two.
Bruh.
If you ask now and you ask after midnight, you could get two.
Yeah, like I'm gonna be up after that time.
Oh, you could be.
Even
Alright,
though
let's
I
see.
usually am.
An astronaut with a mass of 74 kilograms goes up to the ISS on a mission. During his stay, the gravitational field strength is 8.6 newtons per kilogram. So that's a little bit less than gravity. Gravity's 9.8, right? What is the mass of the astronaut on the station? So this is a trick question. Mass never changes. Mass is independent of acceleration. So this is still 74. Does not change. Weight does, though. Yes. So weight is a little bit different. Or here, I'll just do it on here. So B. So weight is technically equal to m times g. That's weight. So on Earth, weight is equal to, what is that, 74 times 9.8. And then you can say on the space station, on the ISS, which ISS for me, growing up, meant in-school suspension. Like, ISS was a bad thing. Like, man, you like fucked up. This is 8.6. Because this is a different gravity, this is a different G. Alright, so how do they compare? Well, we can get two numbers for those, I guess, right? 74 times 9.8 equals that. So 725.2 newtons. And then on the International Space Station, 636. Ooh, cool. 0.4 newtons. So less. What's the difference? Oh, the difference is just subtracting the two, right? So I just do this minus this. Great. Okay, so you can say 88 you can say delta weight is equal to 88.8 newtons. Why does the weight of the astronaut change but not his mass when moving from Earth to the station? I mean, I guess because like weight, some mass is independent of gravity. And why does the astronaut appear weightless? Well, he doesn't appear weightless. He has less weight. Weightless would mean that the acceleration is 0. Right? Yeah, I don't think he can be weightless.
Another answer I think to this could be that so when you're spinning around, you're effectively like escaping gravity by moving in an orbit.
Okay.
So that's why he appears weightless, because he's like escaping. Because essentially a circular orbit, you can think of it as you're still falling, but you're falling at such a way that you're always falling around the planet. You never touch. You would appear.
Okay. I see what you're saying.
Yeah.
So, but even though it says the gravitational field strength is still this, though, right?
Yeah. He's not weightless. That's why I think that's why they say he appears weightless.
He appears weightless. Okay.
Yeah. So what you're saying is correct. Like weightlessness would only have there's no gravity.
Right.
But then he appears weightless because he's in an orbit. He's escaping gravity.
He's in orbit, escaping gravity. Yeah, because you see that thing on the International Space Station, right? They look like they're floating around and stuff, but I guess there still is a gravitational force on them.
Yeah, but they're only floating because they're spinning around the Earth. So like if the satellite was to like kind of like stop, then they would like be just standing up.
Oh.
Yeah.
Is this also because there has to be some sort of centripetal acceleration pulling them inwards because they're moving around in a circle?
Yeah. I mean, that's what keeps them in the circle.
Well,
into like by having it like your velocity is just enough that you're escaping gravity without its effect ever diminishing or getting stronger. Because if you're spinning like slower, then you fall eventually.
Yeah.
And if you spin faster, then you would
you would get shot out. Oh, fascinating. Yeah. Oh, okay. That's actually really cool. I didn't think about that. Yeah, if they stopped, right? Yeah, you would. There's gravitational force. You have to be getting pulled in.
Yeah.
It's almost like it's like a fictitious force, kind of, I guess.
Mm-hmm.
Yeah.
Exactly. Yeah.
Wow. Does that make sense to you, Jay? Yeah. That's actually pretty cool. All right, nice. That one was Jay's. Yes, thank you. Awesome. Awesome, Jay. All right, let's mark that one as done. And then looks like I got Safar. Safar is next. And then Jay, I'll do another one of yours later. Queue's not too long right now. This is a new chapter. So it's all new to me? Yeah. Yeah, weight and mass is a thing they like to definitely distinguish about in physics. Because, I mean, we all say, like, oh, I weigh, like, 30 kilograms, but, like, technically you don't weigh 30 kilograms. You have a mass of 30 kilograms. But if you say I weigh, like, 100 pounds, that is a weight. I think slugs is the unit for mass in, like, whatever freedom units. All right. Yes, correct. Mass is the stuff in me. Yeah, you can think of it that way. And then weight is what gravity does to the stuff. Yeah, like which way is it pulling? Okay, go on.
Think about mass. Sorry, if you don't mind.
No, go for it, please.
Yeah, another way you can think about mass, which is like Newton's way and like Einstein's way of thinking about it is like there's a thing called an inertial mass, which is how hard it is to push something. So you can think about like mass of something is like if something is 2 kilograms, something is like 4 kilograms. If you were to push it so that they move with the same exact like pattern of movement, aka the same acceleration, the thing that is 4 kilograms versus 2 kilograms is twice as hard to push. So then mass is like the resistance of an object to like change its.
Oh, okay. That's how I always kind of describe like moment of inertia as well, right? Like how resistant something is to being rotated.
Rotated, yeah, exactly. That's what it's called, moment of inertia. It's like literally the same exact thing as the rotational version of mass.
I never thought of that, but yeah, I've always thought about the rotational inertia, but yeah, mass is kind of like, or yeah, is linear moment of inertia. Oh, exactly. That's super cool. Wow. See, I learn something every day too. Even with my PhD in physics, I still learn more physics every day. Oh, Poison, what are you guys doing in my chat? Also, Safar, what question? Sorry, which one did you want me to do here? Safar, I see one about escape velocity, and then I see one about a space probe or something. And then I don't know what the fuck is the semi-parameter for the orbit. What? I've never seen that before. Yeah, you can make me talk. You do it, Poison. Do it. You won't. Not now. Maybe before I go to bed. Okay, Poison. This kind of looks like almost like an astrophysics class, I guess, because I've never seen semi-parameter. What is semi-parameter? P? I guess that's some sort of like radius here, I guess. And wait, why is this? Oh, 100 NMI means nautical miles. Oh, I think. Oh, semi-perimeter is the perimeter divided by 2. Oh, okay. Oh, then E is the eccentricity? Is that right? And
yeah,
so if
sure.
and if something has circular orbit, Ramton, is eccentricity equal to 1?
It is 0.
Eccentricity 0? Huh?
Yeah, because like 1 plus E would be its apogee and perigee. Is it the closest and the highest point? It would be like.
Let's just Google eccentricity and shapes.
Yeah,
you're right. A circle is 0. Yeah, a circle is 0.
Because 1 plus E is like your apogee. No, your perigee. Is that I think those are the names for it.
Which is the major, semi-major axis and the major axis or something, right? Minor axis,
exactly. The semi-major axis would be considered your like the 1 plus E, and then it would be the other one minus.
Oh, I see. So I think on where was this question that came up? Where was it? Yeah, on this one. Okay. So when they say for an orbit, they're saying an eccentricity of 1, because they're getting like P over 2. So I'm guessing that like.
No, the eccentricity is still E.
Right.
Like,
but I'm seeing in this
case?
I think E is 1 in this case.
Okay.
When we talk about circular parking orbit. This is beyond me. This is something with like satellites and shit. But I'm assuming that E is equal to 1 because it's a parabola. Yeah, maybe it's a parabolic orbit.
Yeah, that would make sense because then you would never have like it would be.
It's like slingshotted.
Yeah, it would reach infinity. when E is 1.
Oh, okay. Because when E is less than 1, it loops back on itself?
Yeah.
Hmm. Okay, that's actually really
which
cool
would
now.
make sense. E equals to 1, it would be your just enough your escape velocity.
Right,
Anything
E's less than
bigger
1
than
isn't...
2, you would...
I see. Okay, this is making more sense to me. Right. Yeah, so as your orbit gets stretched out further and further and further, eventually when the ellipse, like, breaks, is when E is equal to 1. Very cool. Wow. Okay, cool. All right, so we learned something today. This question was, like, kind of already done so far, which is cool. But I learned something from it. Escape velocity, and then I guess semi-parameter, you choose E equal to 1 because that's the minimum eccentricity you need to escape the circular or elliptical orbit around the planet. Wow, very cool. Nice. All right, let's mark that one as done. That was Safar. Is that a book? I don't know if it's a book. Someone submitted it. Safar submitted it. I was waiting Safar to maybe chime in on like what this was. Okay. Next one is T. Yeah, only 4 questions in the queue. Well, this is the morning. We do have some fun ones in this. Looks like this is let me get rid of all this. All right, we got a lot of stuff I want to get rid of. What's up, Slayer? How's it going, dude? Sorry, I need to translate this. You know Python, right? I know a little bit of Python, Jeff. I vibe coded in Python. Does that count? All right, let me translate this for you, T. Oh, it's already solved, but I need more explanation, and that's what you guys did. Oh, thanks, SFR. Oh, sorry, you're in my Discord, Safar. Yeah, dude, that's literally your username. Oh, very cool, Safar. Yeah, did you have any other questions about that one? Sorry, before I already marked it as done, but it was cool though. What class was that for, Safar, by the way? It's Celestial Mechanics. Oh, fucking dope, dude.
That's dope.
Oh, okay, very cool. Yeah, the escape velocity one is cool. Yeah, that comes from I think it's just like kinetic energy is equal to like gravitational potential energy. Yeah, you're welcome so far. Yeah.
Yeah, the escape velocity comes from the fact that you assume an object at infinity would have no potential.
Exactly.
And then at the closest point, it would have no kinetic.
Right. Yes. You need like enough kinetic energy to escape having... Yeah, got it. To escape having gravitational potential. Yeah. Very cool so far. I'll give you a point for that one. Your exam's tomorrow? Trying to learn more? Cool. Well, we'll be here for the next 24 hours, dude. Or, sorry, next... How many hours? 22 hours and 11 minutes. So if you have any other, like, questions specifically about that, or you want me to just, like, run through another one of your examples, just submit it to the queue. I'll do it. It's pretty short right now, the queue.
That was my favorite class when I took it in
Celestial Mechanics was?
Yeah, it wasn't called Celestial Mechanics. It was called Introductory Classical Mechanics.
Okay.
And so about like 2/3 of the class it was that, and then the other 1/3 was like some like complicated like momentum stuff, like collision stuff. Then it ended with special relativity.
Dude, special relativity still fucks me up, dude. No. Like, I can never figure out when to, like, contract or dilate something.
Oh yeah, I had to do that so much, but I feel like I love relativity. I feel like quantum is like what I always have to review over and over again. But like, the relativity actually makes so much more sense to me, but quantum never makes sense.
Yeah, quantum just like confusing. All the boxes, the particles, energy levels. T, you got a question about springs. Let's see. We place a spring with a spring constant of 250 on a horizontal frictionless surface, fixing one end of the wall. We then compress it by 20 centimeters and place... Oh, thank you, Slayer Darth. Yeah. Yeah, another thing. Yeah, so if you want to... So we have a new math boot camp that we opened up for free, because I know a lot of people come on the stream and they're like, wait, how do I get better at math? Or like, I'm thinking about going back to school, or I didn't learn shit during COVID. We made a cool little math boot camp. If you click here on the link, you can access it, and it's a fun little mini course that I used when I taught physics at UCLA to like get the physics majors up to speed in the first week with enough math to do physics. So go check it out. If you're feeling like a little shaky on like certain math concepts, it's good to just like it's a good refresher.
Is it paid or is it free?
It's free, totally free.
It's free. I gotta get a bunch of the people I'm working with to just come back.
Oh yeah, please. And there's like a survey form at the end, because I want people to like tell me like whether it sucks or something.
Wait, what's
so
it called again? Actual office hours?
If you actualofficehours.com, and then if you click here on Math Bootcamp, that has like the instructions on how to sign up.
Okay,
and
because
it's totally free.
I'm tired of having to teach fraction addition to people who are
There
like,
you go. Yes.
second year university. I'm like,
yes.
yeah.
That's exactly why I created this. I created this because I was like, bro, how do you not know how to fucking divide fractions?
This might actually be I'm gonna flood your
Please do.
thing.
It's
I
completely
would
free.
Definitely suggest this. And the fact that it's free.
Yeah. Because I was thinking about like, yeah, a lot of times I have, students are just missing like foundational knowledge in math, and I'm like, okay, rather than me like go through again like, how do I solve for x? What are my exponent rules? I'm like, just go through this course, please. Let's see, what was this? This is more of the stuff. Oh, okay, cool. What university is this? I see Arabic. SFR. I'm trying to like...
Wait, where is...
He posted it in the chat. I saw some Arabic here. This is Arabic,
I
right?
see KAU. It might be Kingdom of Saudi Arabia.
Oh, sick. Saudis.
That would
I used to teach some Saudi Arabian kids. King Abdulaziz.
King.
Abdulaziz. Sounds Saudi. Dude, one of the kids I used to teach was like a Saudi prince or something. He would show me all the pictures of his falcons. He's like, this falcon's worth like $100,000. I'm like, what the? It's a fucking bird.
There was one I have seen, like when I lived in the high school when I was in UAE in Dubai.
Yeah.
There was a kid that brought a falcon to school one time. And we were like,
What? He brought a falcon to school?
Yeah. One time I was invited to someone's house and they actually had a cheetah, and I was like, this is like insane.
Dude, that's fucking
I wanted to
wild.
go pet it, but I was like, I don't know if the cheetah is gonna...
I don't know if the cheetah likes me or if it wants me for lunch.
Apparently they're actually very friendly with humans. That would make sense why people would actually have it. Yeah, cheetahs apparently are like... They're like a cat that has a dog person.
That's fascinating. I think I saw something, because I was going down a rabbit hole because this Nuremberg film came out, and I was reading up on like Hermann Goering, and Goering, I think had like a fucking pet cheetah or something. I was like, what? Nuts. Falcons are insane. I'm from a small city in Serbia, but I'm Hungarian, and a guy breeds falcon. It's insane how much money he has. Yeah, they apparently, they charge a lot for the falcons. That and the camels too. The camels are a lot of money. But okay, T. So we have the spring. It's compressed by 20 centimeters, which is 0.20 meters. And then this is 15 grams, which, again, needs to be in kilograms. So I'm going to say 0.015 kilograms. Teacher gave you, like, most unfortunate units here, unfortunately. Okay. And then it says, with what will the maximum speed of the object be? Okay, cool. So maximum speed, you have to kind of look at like total energy. So E tot. So total energy here is equal to 0, right? Because there's no compression and we assume there's like no speed or something. But if it's compressed, and let's say you're holding it and it hasn't moved yet, this means you have spring potential energy. So we say like, this is like US, and that's going to be equal to 1/2 K, and then delta X squared, which in this case is going to be 1/2 times 250, and then delta X is 0.20 squared. All right, so that's the energy total here. Then what happens is you let go of the thing, and it starts rushing away with some velocity. Okay? The maximum velocity this thing will have is when all the energy from it being compressed as a spring goes away, and it's uncompressed. So here, E tot is equal to just kinetic energy, because the spring is no longer compressed, delta X equals 0. So here you can say delta X is equal to that. Here, delta X is equal to 0, and now it's moving. So actually, we don't even need this top one. And so that's equal to 1/2 times m. The mass we said was 0.015. What's up, G? 0.05 v squared. And then here's the key thing about conservation of energy. Total energy here has to equal total energy here. So this, which is only kinetic energy, has to equal this, which was only spring energy. So I just set these equal to each other. So we end up getting this equals this. So nice thing is the 1/2 will cancel. And then you can just solve for V. So what's that going to be? That's going to be... I love how my math teacher has 3 post lectures, a 22-page problem set, and a quiz this week. That's unfortunate, dude. It's like winter break, dude. Chill out on your students. Well, certain teachers have wild expectations at work, for sure.
Yo, hello?
Yo, what's up, Shaq, dude?
Yo,
welcome to the
24-hour stream.
We're doing 24 hours, dude.
God damn.
We're doing it, dude.
This is the craziest thing I've ever seen, bro.
The craziest.
No, this is actually the coolest thing ever. I've never seen you do this before.
Oh my god, love it, dude, Shaq.
Yo, this is awesome, bro. How many people you've teach so far?
How many people have I taught? Apparently not enough.
Not me. Hold up, let me get on Twitch. Yo, I haven't been on Twitch in forever. I gotta support the stream,
dude.
bro.
Go support the stream, dude. Go support it, dude.
How many people have you taught so far though today?
I should have put a counter on. Let me see. Wait, 1, 2, 3, 4, 5, 6, 7, 8.
7! I'm sorry.
Oh, 6, 7. God damn it. God damn it. Fuck. Nice. Imran says, one day you will be a big YouTuber, inshallah. Carry on. Thank you, Habibi.
Aren't we family friendly?
I say we're kid friendly. Like, we're not really like family friendly. We're kid friendly. Like, I know a lot of parents would like disagree with things that I say on the stream, but the kids don't give a fuck. So like, whatever.
Okay.
Yeah.
Okay. Wait, this is actually so cool though. I feel like I'm witnessing history right here.
You're witnessing history,
guys.
dude. I don't think anyone else has done. I don't think anyone has done like a 24-hour stream before.
This is everyone does that.
I've never submitted my questions, but I love listening. Begania says he loves listening in. I'm studying physics and chemistry and adult education. Thank you so much. You're very welcome, Begonia. Fuck yeah, dude. Thanks for lurking, and thanks for coming out to say hi to us. Yeah.
Alright, I'm gonna hop out now. I gotta go teach, but I'm gonna try to
Good luck with
hop back
teaching.
on
Please.
Back and forth, and also I will try to keep the Twitch on so that if you have any, if any questions come up, you can tag me in the office. So
Yeah, I'll tag you. I'll tag you for
look
sure.
at it when
Yeah,
Okay.
I'll post them in there, and I'll tag you in the thread. You'll see it.
sounds good. Okay, best of
peace.
luck. I'll see you around.
Thank you, dude. Best luck with your teaching. Yeah. Jeff says, I predict he'll fail at 3 hours, bro. What? Dude, light work, dude. My stream yesterday was 3.5 hours. What do you mean I'm gonna fail at 3? We did a 10-hour stream 2 weeks ago. Yeah. Yeah. Bum, 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 bum. Okay, let me help out T real quick here. All right, so if this is moving with a velocity of 25.8 meters per second, and then it goes up the incline, right? Eventually, it's going to reach some maximum height. So eventually up here, it's going to reach some maximum height. And the maximum height it reaches will be when its velocity is now equal to 0. Right? Because now it can't go up anymore. It doesn't have any more speed. So, same thing here. If we look at E total here, there's no spring anymore. So this is strictly just gravitational potential energy, which is mgh. Okay, and then this energy still has to equal the total energy here, which was 1/2 mv squared. So we do. Is it rare to have my awful chemistry course with 100% of the class being tests? Because I can't tell with that. Bree? I don't know what Bree means, but yeah, your teacher should at least put like some homework, like question credit or something. All tests that's like rude. Unless they just know you can just cheat on everything. So that's why they do it. But then I think that's like bad, because then kids like just don't do the homework. Wow, Brom Shack, thanks for the cheers, dude. 1,000 bits. Wow, you big,
bro.
you big baller, dude.
Stream, bro.
Thank you,
24
dog.
hour, bro. Nah, this is actually cool, bro. Whoever's tapped in the stream on like everything, I know I'm about to dip right now, right?
Nice.
But bro, this man, he is very influential. He's very giving, bro. So whatever time, and this is the most time you're gonna get out of him in one session, bro.
The most.
But the most time you can get out of him, bro, don't take it for granted, bro. This is gold, bro. This dude
Thank
is
you, Shep.
amazing. I was like 15. He helped me jumpstart my career on streaming. He gave me a microphone. He got me a keyboard. He got me all that stuff, bro. So I still use it today. You're literally listening to me through the same microphone, bro.
Wow.
So, yeah,
Fuck
have
yeah.
a good one, guys. Yeah, enjoy your stream, bro. Like,
Thank you, Shaq, dude.
Yeah, you the GOAT, man.
You the GOAT, dude. You the
Have a
GOAT, bro.
good one, bro.
Thanks, dude. Shaq's a homie. How much can you curl, Gold? Look at these biceps. Yeah, look at these biceps. I don't know. I should measure them sometime. I think I'm up to like 19 or 20 now. I'm trying to bench 315 eventually. I'm missing the gym today and tomorrow for this stream. My gym partner is very upset with me. I'm up to 290. I can bench 290. I want to get to 315. I want 3 plates. The height. All right. Yeah, let's solve for it. JC is a streamer. Yeah, let me shout out JC, by the way.
Thank you, Shaq, by the way. Yeah, JC streams chemistry help. Oh yeah, let's solve for each real quick. Let's finish this question out. Thank you. I do need to hydrate. Yeah. Streaming is it's a long game for sure. Okay, this goes away, this goes away. And so you get H is equal to whatever, I'm just gonna do this in the calculator.
Sorry, Slayer. I'll check your question in a second. Let me do this one. Raw facts 0.5. Follow Brody. Yeah. Follow the homie. And then we're going to divide that by 9.8. So, height is about 34 meters. Let's just say 34 meters. Last time I was in the stream was 2023? Damn, bro, what? That's Unk status, dog. What? 2023, dude. When was that? There is a cooldown. Yes, there's a 5-minute cooldown. Okay. All right, T. Okay, let me see. Sorry, what was Slayer Darth saying? He says, I need some help with understanding the wording of a coin toss problem. For instance, if they ask for the probability of getting heads on a single fair coin toss, a coin is tossed twice at random, and so what is the probability of getting at least one head? Of getting the same face when tossing a coin twice when having to write out all the possibilities. Oh, wow. Thanks, dude. $5 as well. Shaq did well. Look at that. We got big donations coming in, too. Thank you, Shaq, dude. Yeah, I think, what's the probability of getting the same face when tossing a coin twice? I think it's just a quarter plus a quarter, right? Because it's like heads then heads, which is a half times a half, plus tails and tails, which is then a half times a half. Oh, you do? Oh, SFR. Oh, send it. Send it. Or is it in this big PDF you sent? Is it in this? Okay. Cool. This was T's. Let me. Well, T. I think you had a second part of yours. Thank you, Shaq. You have an awesome day too. You're dope, dude. Here, let me translate this real quick for him as well. I don't speak Hungarian, unfortunately. Or not yet. Here, translate this. Probability is 1/8 of getting Wait, did I fuck that up, Panda? Sorry, wait, what? No, isn't it a half? Isn't it? Yeah. It's just a half. Or you don't know how to start? Okay, T, let's help you out, dude. Let's help you out. We got you. Yes, that is it. Yes, combination permutations is different. Yes. But, I like to think of it like event 1, then event 2. So if event 1 is like heads, that's a half. And then event 2 is also heads, that's another half. So that's equal to a quarter. That's one situation. You could have also rolled a tails, which was a half on the first event. And then doing another tails would be another 1/2, so that's a quarter. So that means together, there's a 1 out of 2 chance of getting the same thing twice in a row. Assuming it's a fair coin. It's okay, Panda. The 1/8 to me sounded like a quarter times a half or something. Or 1/2 to the third, maybe. Okay. What tangential accelerating force acts on a 10 kilogram? Okay. If starting from rest, it completes. Okay. So, 100 revolutions in 20 seconds. I think you want to use this equation. Theta equals theta naught plus omega naught t plus 1/2 alpha t squared. This is like the kinematics equation, but in like rotational motion. 100 revolutions, that's 200 pi, right? Because 2 pi is 1 revolution. We're going to start at 0. Starting from rest also means that omega naught's equal to 0. And then so we have plus 1/2 alpha t squared. And then they say t is equal to 20 seconds, right? So we can just replace this. Okay, so we're going to solve for alpha. So, oh, this is actually pretty easy, right? Because watch, I multiply this by 2, I get 400. Divided by 20 squared is divided by 400. So alpha just equals pi. And that's radians per second squared. Okay. And then it says tangential accelerating force. This has to do with torque. So torque, which is equal to, you can say like R perp F or RF perp, where this is kind of like the tangential force. It's the force perpendicular to the radius. So let me like kind of show how that is. So for instance, this is like F perp. And then this is R. Well, I'm not drawing that correctly. Whatever, something like this. There we go. Yeah. So this is R. And then F perp is like the force perpendicular to the radius. This is equal to torque, which is also equal to I times alpha. In the same way that in linear motion, F is equal to ma. Do you see how torque is equal to I alpha? Alpha is angular acceleration, A is linear acceleration. I is like angular momentum, which is what Ramton was kind of talking about. Mass is kind of like linear momentum. Moment of inertia, sorry. I is moment of inertia. M is like linear moment of inertia. And then F is the same as like a torque. Yeah. So, now we have the numbers, right? So this is equal to 1/2 mr squared, right? Because that's what I was. That's the moment of inertia right here. This is I. And then alpha is equal to pi. And then that has to be equal to what tangential accelerating force? So then that's R and then times F perp, and this is what you're solving for. So cool thing here, one of the R's cancels, right? So you get 1/2 mr times pi is equal to F perp. Mass is 10 kilograms. Radius is 1, because the diameter is 2. So the radius is actually 1. And this is pi is equal to F perp. So 5 pi is equal to F perp. So there you go. I think that's the answer for that one, T. Does that make sense? Hope it does. I agree the wording for it fucking sucked. Yes, it does. Nice. Great job. Thanks for hanging around, T. I mean, feel free to, like, keep hanging around. You can keep asking more questions. I'll go through them eventually. But, like always, we're going to go post this question on the Discord. So, let's mark 2's is done. So you'll see it. It's right here. And then we'll pull it in. There's a solution. Where can you find the Discord? Good question. So the same website you went to go submit your screenshot. Here. There's a button here that says join our Discord. Also, yeah, if I have people, I think, who's in my chat earlier? Oh, Bianca was saying that you're like an adult, like getting back into math stuff. If you want a great refresher, just to make sure like you understand the fundamentals, like again, like fractions, exponent rules, some algebra. I even have some trig in there. I created this math boot camp that you can join. It's free, totally free. And it'll show you like how it works. Wait, I don't know. Wait. Oh, that's the wrong link. Oh fuck. Ooh, I need to fix that. Anyways, go down to here. And then this is the course. Actually, let me fix that. That is wrong. I need to fix that real quick. Now I understand why some people weren't it wasn't working for them. Because they were getting sent to the AP Physics 1. One sec, let me fix that. But anyways, so in here under this is like the course. There's like converting units, scientific notation, simplifying algebraic expressions, working with fractions, exponents, and like a lot of stuff I wrote. Like I wrote a lot of this, a lot of the stuff here. But one sec, let me fix the website there. That makes perfect sense why some people weren't getting to it. Sorry, let me go edit it. It's because the button for access goes to a different access button. I swear to God. Thank you. Well, y'all help out with it. You guys are good. Sorry, where was it? Actual boot camp. There we go. I need this to change. Done. Okay, now it should be fixed. Are you also a programmer? Yeah, I program stuff. I had to do a lot of programming for my PhD. Okay, now it should work. Okay, so now I'm glad I figured that out. So now if we refresh and we hit access now, well, I want it to go back down. Why does it not go to the anchor? Where's the anchor? Should go to here. That doesn't move it down very much, does it? Man. Ugh. So dumb. Oh, there we go. 1 sec. Okay, I think I got it now. All right, 1 sec. All right, let's see if it works. No? Come on. Bingo! There we go.
Good job.
I got it to work. Anyways, yeah, so go there. Here's how you sign up for it. And once you join the course, you can go through and learn about, again, like exponent rules, why this stuff works. I wrote a lot of this myself. And then there's some cool practice questions you can go through just to make sure you understand stuff. So go check it out. It's cool. Glad I fixed that. All right, let's see. What was the next question I had in the list? Here, Jay. I'll do yours, and then we got Hafe, then FF. Is it just math and physics? Yes, Jay. Right now, yeah. It's just it's mainly just a math course, but it's You post it on the Discord? Ooh. Can you post it in the queue so I know? Because that's the best way for me to see it. Just because otherwise, I don't know. Like, there's so much stuff going on in the Discord. At least during the stream. Which one was yours? Which one was yours? BB. He. Did you use the same username? Yeah. Check it on your desktop. Yeah. Go check it on your desktop. It'll probably be easier for you to be able to sign up for it. But yeah, let me know. I mean, I can. It's hosted on this online textbook company called Kudu that I consult with, and they're always looking for ways to improve their platform. So maybe their mobile version sucks. No, my user on Discord is Stacy. Stacy. Oh, you posted this yesterday. Oh yeah, okay. I see. Yes, I can do these. Here, I'll do these next. Let me do this physics question, and then Stacy. Yeah, you did ask these yesterday. That's okay. That's okay. I'll do it. I'll do that one. And this isn't too bad. Yeah, you're welcome. You're welcome. I got you. Just hang around. I'll do these ones next. Let me do this one real quick. Okay, last one from Jay. Cargo box on a rocket has a mass of that. He's like chem now, dude. Bring the chemistry. Just keep saying chemistry. If we say chemistry enough times, like TikTok will start giving. Dude, yesterday all I got were Calc 3 problems. I swear, dude. It was just like question after question after question of Calc 3. I'm happy I haven't gotten any Calc 3 really yet today. Alright, the rocket will travel Earth and the Moon. What will happen to the mass of the cargo box? It will not change. Chem. Yeah. You know, if you submit a chem problem, it seeds the pot. Like, if there's a chem problem that I work through, TikTok, like, notices it on the algorithm, and it'll start sending our stream to more chem people. I can do Calc 2 problems for sure. So, will not change. Mass is... I don't know. Forever. Mass is independent of gravity. The weight of the box on the surface of the Earth, that's easy. That's 32 times 9.8. So what? It's around like 320 newtons. Okay. The weight of the box is 52.06 newtons. The gravitational field strength. Okay, cool. So now we know 32 times x is equal to 52.06. Right? Because this is just mg is equal to weight. So then you just divide this over. So 52 over 32. What's that? 1.625.
Good job.
Yeah, which makes sense. I think the gravity on Moon is like a sixth of what it is on Earth. But cool. Cool question, Jay.
Good job.
Okay, nice. Mark that one is done. All right, Stacy, let me help you out with some implicit differentiation. I did so many Calc 3 problems yesterday. Look at all this fucking Calc 3 I was doing. Where is it? Yeah, all this, dude. So much Calc 3. This was Calc 3. This was... Well, this wasn't Calc 3. This was Calc 1. But this was also Calc 3. Look at all this Calc 3. All these triple integrals and stuff, dude. What was that? This was also Calc 3. Yeah, this was Calc 3. We did this. This was Calc 3. Yeah. So I was happy to, like, get a break from it. But now that I mentioned Calc 3, look, literally someone in my chat said, do you do Calc 3? Let's just keep saying chem. Chem, 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 chem. Bro, you make it so easy. Thank you. Yeah, no, you're welcome, dude. Okay. Find dy dx by implicit. Okay. So my trick for this is to always treat everything as a very... I know, people get mad at me. Like, the math gods that be will get mad at me if I just start dividing, but like, I don't care. You'll see. Awesome. Yeah, there you go. Thank you, Bianca. Yeah. JC's gonna be very happy if we get more chemistry people in here. JC streams chemistry. Anyways, what I do here, Stacy, is I treat every variable as something that needs to be like derived, but anytime I do a derivative with respect to that variable, I write either like dx or dy, depending what variable it was. So ln of xy. So this is going to be this is annoying. This is a chain rule and a product rule. So I know the derivative of ln of something is equal to 1 over that something times the derivative of what was there. Okay. So in this case, when we do this derivative here, this is going to get me 1 over xy, but then I have to do the derivative of xy. And the derivative of xy, this is a product rule. So I do the derivative of the first. So the derivative of the first thing is just 1 times the second y. And then because I did the derivative of x, I'm going to write dx. And then that's plus the derivative of the second thing, which is just 1, times the first, which is x. And then because I did the derivative of y, I'm going to write dy. Does that make sense so far, Stacy? I'm gonna like pause because that's a lot of shit I just did. Okay, does make sense? Cool. Sick. All right. Then I'm going to do the derivative of this. The derivative of e to the something is always just e to the something times the derivative of what was up top there. So this is another product rule because this is going to be times 3 times the derivative of xy, which is the same thing this was, right? It's going to be y dx plus x dy. Okay. My next step is to try to group everything by dx's and dy's. So, let's see what I want to do here. I'm going to expand everything out real quick. And they said y does not equal 0. That's great. Because that means I can cancel this. If y did equal 0, I couldn't do that. So I'm going to get dx over x, right? If I multiply this in, y's cancel. And then we're going to say plus dy over y. is equal to 3e to the 3xy. And then we can say... Or sorry, this is not over dx. Sorry, this is over y over x. What am I doing, dude? Gold, you were my third most watched streamer this year. Nice. Oh, they had the review thing? That's sick. Yeah, the streaming. It's like the Spotify Wrapped, but for streaming. Sorry, this is this. This is this. Sorry, I made mistakes. I made ouchies, multiplying that in. I don't know why I wrote DX. Twitch recap. Cool. Okay, and then this is gonna be y dx. I'm gonna make green all the dx stuff, and then we're gonna say plus. And then this is going to be x dy. Yes. So yeah, watch what I do. I'm gonna. All right, we're gonna move this down. Now what I'm gonna do? Yeah, I'm gonna move this stuff over. I'm gonna move all the dx stuff on one side, all the dy stuff on the other side. Okay. So we're gonna move this over here. We're gonna move this over here. So that's a minus sign now. I don't know if watch time works. Yeah, I'm going to do that. We're going to put a minus sign. And then here's the cool thing, is that I can now group out dx, and I can also group out dy. Okay? So I'm going to say, okay, this is the same thing as dx. And then this is going to be 1 over x minus 3e to the 3xy times y. And then this is equal to... this is... I think it's just calculus. I don't think it's differential equations. Yeah, no. Yeah, this... You're on the right track, T. And then this is going to be 3e to the 3xy times x minus 1 over y. Alright? And then the final step here is... I'm going to, like, move this under here. So let's take this. Let's divide it under. Well, actually, no, sorry. Let's take this side, divide this one under. That's what I want to do. And then I'm going to take this and put it under here. There you go. And then this is dy dx. Very messy, but that's how that works. So then let's see this one. Yeah, you're welcome, BB. Here, I'll do this one as well. I feel like I want to do some chain rule stuff here. So this is the same derivative of something squared is going to be 2 times that something. So 1 plus e to the 4x. Then times the derivative of what's inside. Which is, derivative of this is 0. But the derivative of this is e to the 4x times the derivative of 4x, which is 4. And then because I did the derivative of x, it's 4dx. Okay, cool. And then this is equal to 7 plus, this is going to be 1 over 2x plus y. Is it almost the same as like limit of x is approaching infinity, for example, and you write limit until there's no x left? Yeah. That's L'Hopital's rule is what that's called technically. I know what you're talking about. You just keep taking derivatives. Okay, then the derivative of this is going to be 2 dx plus dy, right? Because derivative of x is just 1. So 2 times 1. But then we did a derivative of x, that's dx. And then derivative of y is just 1. But derivative of y is dy. So that yeah. Okay, great. Okay. Oh, sorry. And the derivative of 7 is 0. Sorry. Yeah, there's no 7 here anymore. This is gone. Okay. So I feel like I'm gonna multiply this over just to like make things nice, right? as nice as we can make it. This is ugly as sin, dude. Two x plus y, and then this is e to the 4x, and then there's another 4, so let's make that an 8. And actually here, let me I don't like this on this side. Let me put this over here. 8 e to the 4x blah 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 dx is equal to 2dx plus dy. The ability to do such impressive maths yet always be right on time with incredible perfect sound effects is incredible. Thank you, Paul. Appreciate that. I know the younger generation loves the stimulation. They love the stimmies. So I'm just like, yep, here it is. Here are the sounds. I had someone on my stream yesterday who was making, I think it was like GMAT prep videos. And I was like, bro, your videos are cool, but in order to keep people from like swiping away, you need sounds. You need lots of sounds and graphics. Yeah. Okay, so what I did is I moved this over, this minus 2dx, and then I pulled a dx out of everything. Okay, so then our final step here is just to divide by dx, and then we're done. And there you have it. dy over dx is this ugly, ugly thing, but it is it. Good job, Stacy. You're very welcome. Very welcome, Stacy. I'll post the solution in the thread for you, Stacy. Okay, there we go. Staxy. And then also you get a point. You get a point in our server for asking questions. And points can be used to buy gaming gift cards. All sorts of fun stuff. All right, let's see what else we got. Oh, thank you. Appreciate that. 20 diamonds. Nice. All right, this one was Jay's question. Yeah, it's kind of mean what your teacher did to you there for those for these. I don't know. This is kind of like an ugly thing to try to like implicitly derive. Like, why would this would never come up in real life? Maybe this would, but that's kind of weird too, honestly. I don't know, I feel like teachers should try to at least use like realistic equations in relationships, because there are a lot of fun things in life that are non-linear, and taking implicit differentiation like makes sense too. It's one of my review questions for my exam. Ew. That's not fun at all, dude. Okay. Let's see, what's next on the queue? Oh, this is our kudu course. Hafe. Find the flux of the field. Do I have the field though? Ave? I feel like I need the field. It's supposed to be business math? That's not business math. That's like some pretty heavy econ math. I could see if you had to be like a quant. I could see that being a type of thing to do. Oh, Jeff, you put your name backwards. It's so cute. Yeah, that's not really a business math question, BB. That's a little bit more. That's tougher. Okay. Let's see. I caught your trick. Yeah, that's just mean for a business class. If you were doing modeling and like yes, then I agree that you do need to be able to do that, but not just like basic business. Okay, Hafe, I need the field. I need the field for this, because I know what you want. You want what I think it's this. Yes, Eric, we're doing a 24-hour stream today. I think this is like F dot N hat like D sigma. I want to say this is flux. It's for first year accounting? No, get out of here. That's terrible. That's a teacher just being mean. Let's see. Maybe we can find this one. Maybe I can find exercise 35. Let me ask about the image. Let's go find it. Oh. No, I swore like Chegg had it at some point. Wait, where was it? This probably has it. There we go. Yeah, okay, but where is... Oh my god, dude, look at all these pop-ups. Jesus Christ, how do you learn? Oh, this is hilarious. The answer is just 0? Oh. Oh, that's too funny. Yeah, Netflix is 0. Okay, this is just equal to 0. Oh, man. Yeah. Because I guess there's no source, right? You can say the flux through a surface. But the flux through the whole shape is 0. Again, unless the field is that divergence is equal to 0? Yeah, you can use the flux across a closed surface, right? Semicircle. Wait, how are they turning a triangle into a semicircle and a line segment? What the hell? What in the fucking what? What the hell is this? There we go. Wait, whoa. Oh, we found it. We found it. Found it. There's the path. When did the stream start? Started almost 3 hours ago. 2.5. Yeah. And I think the reason this comes from here, so let's show this. Like, why is Netflix? There's probably a good, like... Yeah, here's kind of a good one. For any, like, closed shape, the amount of, like, flux lines going in is also equal to the amount of, like, flux lines going out. You learn this in physics. I wonder if there's a way to, like, show that mathematically, though. You'd have to do it for, like, every single, Here, let me grab this. You'd have to do it for every plane, right? Because this was the original one, right? Yeah. The flow of the velocity field. Find the flow of the velocity field along each of the following paths. Yes. True Femvox, right? Yeah. Now I see what they're saying about like this circle thing. Cause let's draw this out. So oh, it's only in the XY plane. Wait. Yeah. Wait. Sorry. Oh, this is a 2D thing. This is even easier then. Okay. So it's like here. Wait. Yeah, right? Here and here. Upper half of the circle. Okay. So I think when you do flux here, right? Isn't it just f dot n for like each segment? And is that what they're calling like the flow, the velocity field, which is also like the flux, I guess? Flux is kind of like flow. One sec. That.
How's the streaming going?
What's up, Ethan? It's good. It's good. I'm trying to figure out this question. A little tricky.
Because I've never heard of that before. What the heck is a flux?
What help is
Like a
flux? Flux is kind of like... It's like the amount of field moving through a surface. I like to think about it.
Okay. You know, it's like not to go. I don't know. I don't know if you like. I don't know if you've noticed throughout the past years I've been with you, but like, did I ever? Do you know that I like compare myself to people sometimes?
Oh,
I mean,
dude,
like anything.
I compare myself to people all the time, dude. What? That's a very natural thing in life to compare yourself to other people. People do it. You shouldn't, but people do it.
I mean, it's just a natural thing. That's human nature. I don't think we can avoid it, right?
For sure.
Well, like, listen to this. Like, like, since I'm in college right now, and it's like, but when I was in high school, they offered this major where you could either do a lot of programming or you could do programming and mathematics. Essentially, like that's just the thing that's like the broad surface. I wanted to do the programming and mathematics thing. Like, I do definitely have the requirements for it, so it wasn't any trouble. But my dad suggested I do the programming only thing. And to be honest, it's like I'm asking like what, like, since I'm already done with school for the year, The others had just done their programming and mathematics. It's like I was wondering what they just did. One of them sent me like a little cheat sheet of like what they did for their trigonometry test, and I'm just like, not flabbergasted because I've seen most of this, but it's like this thing apparently barely helped in their exam. It's like if I were to switch over to the programming and mathematics, I feel like it'd be held a year back, and I don't even know if I want to do that.
Okay.
Like, see, I love mathematics a lot, but the thing is, they're taking calculus 1. I can't.
You already took calculus. Didn't you already do calculus?
No. What do you think is calculus level? There's integrals and the derivatives.
Yeah, integrals and derivatives. Yeah, I think you could do calculus. It's not very hard. Calculus is actually pretty great. I love calculus.
I love I don't like the thought of calculus just sparks my mind up for a challenge, but I can't even do that. They won't offer it, and I don't think I can even vote to. I can't volunteer to do that. Otherwise, I have to have like what's called a prerequisite, which is those same mathematics courses that they just took.
Which they took calculus or what?
Like they have to take what like over where I'm in, you have prerequisites where you have to take those first before you get onto another level, right? You know what that is, right?
Yeah, I know what prereqs are. Yeah.
The thing is that there were 3 courses. It was like Math 115, Math 115R, which is basically a lab, and Math 119. Okay. Like those are the prerequisites before you can actually start getting into like a broad physics category and a bit of calculus 1. Like that, you have to take those 3 first before you can even move on to those 2.
And
I can't even do those.
Well, you should try taking them then. No.
I would want to take them, but I don't think I can.
Okay. Why can't you?
Because it's not a part of my degree requirements. Then I don't have to do those.
But sometimes you need just like extra. They call it like GE credits, where you need credits just doing other things, and that I think would count as like a GE credit.
Like I will want that at least because I mean, hey, I'm looking at this thing right now. I almost know nothing about it. I mean, I only know like 1/3 of it, but like let me at least get into the thing to see how challenging it is. I really am looking for a challenge so that at least my brain has some adrenaline rush into it, if you know what I mean. But
I think you can figure it out. You can figure it out, dude.
All right. But yeah, I also posted a question in there, so I don't mind talking during that time. I'll let you figure out this.
Yeah, let me figure this out real quick, and then yeah, I'll do it. I got you, dude. All right, let's figure out flux. Let me see. Okay. I think we need Green's theorem for this one. What's Green's theorem again? Yes. This is what I want. Yeah, here we go. There we go. This is what I wanted. Yeah, okay. Okay. And we did need this. We needed this velocity field in order to do this. Okay. There we go. This is green. This is flux. Okay. I was right. It is f dot n. Right? That's what I thought it was. Oh, I didn't write it up here. Okay. Which is the same as div f dA or df dx plus dg dy dA, where f is, okay, this is the x function. Okay, oh, this is cool, actually. Okay. I think they also write this as like dq dx, or I think, let's just write this as, I think this is usually written as dm dx or something. Yeah, they use dq and dp. This is the other way to write it. The other way I've seen it written. Yeah. Because this just makes more sense to me. Because in this case, Q is equal to x plus y. P is equal to negative x squared. Negative x plus y squared. Because f is of the form q comma p. Okay, cool. So let's calculate what dq dx is. So dq dx, that's just equal to 1. And then dp dy, that's equal to negative 2y, right? And this is, yeah, this is called the divergence. Yeah, div f. Ah, okay. Right, div f. Very cool. Yes. Okay. So now we have that flux, which is equal to div.f dA is now equal to 1 minus 2y dA. And then this is a triangle. Oh, I see. So wait, we can just break this up into dx and dy. Yeah, because it's just a triangle. Okay, cool. So in this case, right, dx is going to go from negative 1 to 1. And then dy is going to like, yeah. Or, you know what I think I want to do? I think I want to integrate dy. I want to integrate dx. But I have to do 2 integrals. Right? Because this is y is equal to x plus 1. This is y equals negative x plus 1. This is y is equal to negative x plus 1. I got it. All right. So we're going to do the integral. Let's break this into 2 integrals. Because dA needs to span the entire area of this triangle. Which we're going to go from negative 1 to 0, from this to this in terms of y. And then we're going to go from 0 to 1 with this to this in terms of y. So, all right, we're going to break that from negative 1 to 0, and that's going to be dx, plus integral from 0 to 1 dx. And then in terms of y, well, on the left side here, that goes from 0 to x plus 1. And that's dy. And then this is 1 minus 2y. And here it's 1 minus 2y. Oh, wait. Let's get this integral. This is from 0 to negative x plus 1. And then this is 1 minus 2y. dy dx. Very cool. Okay. All that's left to do is to do these integrals. So in terms of dy, this is y minus y squared, evaluated from 0 to x plus 1. And then we still have negative 1 to 0 dx that we're going to eventually do. And then this is plus negative 1 to 0. And then this is going to be also y minus y squared. And that's from 0 to negative x plus 1. And And then we still have a dx, so we're gonna eventually do. Okay. Oh, this is messy. All right, x plus 1 minus x plus 1 squared. All right, this is from 0 to 1, not negative 1 to 0. Dx, and then this is going to be 0 to 1, negative x plus 1, minus negative x plus 1 squared dx. Okay. Doing this, let's simplify this first. So that's x plus 1 minus x squared minus 1 minus 2x. So x minus 2x, 1 minus 1, that at least goes away. So I have negative x squared minus x dx. And then this is plus negative x plus 1 minus x squared minus 1 plus 2x, right? Because that'll get me a minus 2x, but then we have another minus, so that's a plus 2x. Okay, cool. So then this is integral from 0 to 1 of negative x squared plus 1 minus 1 cancels. And then this is plus x dx. Okay, very cool. All right, almost done, guys. Negative x to the third over 3 minus x squared over 2 from negative 1 to 0 plus negative x to the 3 over 3 plus x squared over 2 from 0 to 1. Plug in 0, that just goes away. I don't care about that. Plug in negative 1, so we got to be really careful with the minus signs here. Because negative 1 cubed is negative, but then there's another negative, so that's positive 1/3. And also, it's this minus this. Oh, man. So there's enough. Dude, there's so many fucking negatives. Damn it. There's so many negatives. What's up, Teacup? 24 hours is wild, yeah. We're 3 hours in almost. We're almost an eighth of the way there. It's a test for sure. Okay, so this is minus 1/3. And then this is plus 1/2. Plus, this is great because this is on the other end. This is minus 1/3 plus 1/2. Okay. So what? That's negative 2/3 plus 1. So I think it's just equal to 1/3. I think it's cool. I think it's correct. Yeah. Wow, look at that. That was a lot. There's a lot of questions for Flux. Nice, Hafe. Alright, that was Hafe's. Wolfram Mathematica is nice, dude. Yeah. That's the OG, like, ChatGPT for math. Was Wolfram. Because you always just send anything to Wolfram. Like, calculate this analytically for me, please. Alright, what do we got next? Jeff, you're always funny, dude. Given 2 points on the sphere. I don't know how to do this, Jeff. I'm guessing it's drgoldsucks.txt. Oh my god, I didn't even see that, dude. Dude, dude, god damn it, Jeff. Oh, Jeff. Jeff, I love this. Is this an Emacs? What'd you write this in, by the way? Yeah, it is Emacs. I prefer Vim. I'm a Vim guy. Emacs is pretty sick, though. Okay. I wonder if AI could solve this. Let's just see. I'm just curious. You just solved this? It's ugly? Here. We'll see how ugly it is for... Convert the 2 points to Cartesian. Yeah, it really is a 24-hour stream. We're doing it. Zach's gonna hop on and teach a little bit. From like 1 to 4 o'clock. Dude, Jesus, what's all this stuff? Oh, you do it with Senpai. Oh, okay. Jeff has such an obsession with spheres. I'm gonna call you Jeff Spheres. Ew, dude, what is this? Dude, what? Brother, dude, what? Oh no, dude. You broke ChatGPT.
Surprise, motherfucker.
Okay. Cool question, Jeff. I appreciate it. It was fun. It was fun watching you break ChatGPT. This is giving me war flashbacks. Yeah. Moving the second part's the hard part? Okay. Oh, this is SFR again. What's up, SFR? The N-body problem? Oh, just ignore it? Oh, I kind of wanted to look at it, though. What's going on? You didn't get the sigmas? Is that what you're saying? This stuff was kind of confusing? Bum, bum. But it is kind of fun, though. So you're finding, like, what the gravitational force is on one object based on, like, all these other objects, right? And you don't look at the ith one, and then this is looking at, yeah, this is a fancy way of writing MJ over RJI, like, squared in the RJI hat direction. They write it as like vector over r to the third. Yeah. Summation just means you're adding them all up. So you're adding up all the pairs of... So, because it's always GMM over r squared, really. Where this is the ith body you're looking at. So that will always be the same whenever you look at the force of each, between each thing, right? MI will always just be MI. So that's why they pull MI out here. And now what you're doing is you're summing this times this, all the different J ones. But you're saying that J cannot equal I. Oh, what happened with my TikTok chat? TikTok did some weird stuff. Yeah. And then, yeah. And then this is just a way of writing r squared. But, like, putting a vector on it as well. Because what you learn, right, is that, like, r hat is equal to r vector over, like, the magnitude of r. So if you want to write, like, 1 over r squared, r hat, you can just write this as r vector over r squared magnitude of r. But then this is the same thing as r hat r to the third. Where this is a scalar now. She's not a vector. Okay. Okay, and then... Sorry, where was this other one? Yeah. What's up, Machka?
Good job.
How's it going? Yeah, and then okay. So then, yes, force total is equal to mv. Right. This is actually kind of cool how this works. So F technically is equal to like ma, right? Which is equal to m dv dt. But if you want like the full, I mean, this assumes that mass is not changing. So in reality, I think F is equal to d dt of mv, which then is a chain rule, right? So then you have like m dot v plus mv dot, and so this is m dot dr dt plus m d squared r dt squared, right? Which is what they have here. And then, oh, that's cool. So you can solve for the acceleration in terms of the total force divided by the mass of your object minus the velocity times the change in the mass. That's so cool. So wait, is mass changing as a function of time? Right, okay, and so they say assuming m dot is 0. Assuming your mass is not changing. It's not like a rocket just burning through fuel. And assuming that F other is equal to 0. So then F total just equals F gravity. You divide by mi. Okay, so then you just get to this. Oh, okay, cool. So that's the acceleration. Oh, wow. Yeah, so it's interesting. We only have an analytic solution for the two-body problem, right? The second you add a third thing, you can't really do it. I think maybe that's kind of what they're getting at here, right? J equals 2 to n. J does not equal 2. J equals 110. And any other attractive bodies. Okay, very cool. Fascinating. Oh, so this is the acceleration of R1 and R2. So, sorry, of two masses, M1 and M2. Kind of based on each other. But also, yeah, see here, they're saying like R1, and so mass 1 and mass 2. But also under the presence of other masses fucking with it. Wow, very cool. And then the issue here, though, the reason why this isn't solvable so far, by the way, analytically, is then these R's change as these accelerations are, like, you have non-zero acceleration. So mass 1 and mass 2 are now moving. So now it's their relative position to all the other masses involved, like Mn and Mi, is also changing. And I think this becomes very difficult to solve, like, analytically. Or, like, it's basically impossible. Yeah. Very cool so far. That's cool. Okay, let's see. Next up, Ethan. Simplify. Oh, this is great. Oh, I like this. Ethan, you wanna talk through this one with us? I feel like in this one you want to have common denominators, Ethan, yeah?
Yes, sir. I was just busy with stuff. Sorry about that. Never
You're
really
okay.
saw that joke. Alright, yeah, listen, this actually like this was on my math exam. Not the exact question, okay? Not the exact question, but like at the time I was kind of like I was focused on our exam, so it's like I wasn't really focused, but if you can really show me how to do it, then that would
Yeah, you want common denominators whenever you see stuff like this. That's like your first goal.
Well,
Which,
yeah, I mean, I could just...
how do you usually get common denominators? I'll show you like the hard way and the easy way to do this. Let's say, for instance, you had like 1/4 plus 1/3. What would you do?
Wouldn't you find? I think it's the LCM, right? The lowest common multiple, right?
Correct. Yeah. Let's go multiple. Right. Yeah. I'm gonna get some coffee.
It's just 12.
It's 12.
It's 12, right?
Yeah. Do you see what you did? Is you multiplied this one by like 3/3.
Mm-hmm.
And you multiply this one by 4/4.
Mm-hmm.
So then you have like 3/12 plus 4/12, and you could get 7/12. Tired already? Yeah. Uh-oh.
We are still a long ways from even completing our 24-hour
We'll get there. We'll get there. Yo, what's up, Don?
Good job.
Yeah, 24. We're going for it. We're going for 24, dude. Shout out Don. Don's another awesome math streamer in grad school, working on his master's degree. He's a cool dude.
A master's degree? Oh my gosh, like
graduate work.
Why people have? I'm trying to get my degree right now. Okay.
It's okay, dude. It took me 9 years to get my PhD. Nothing wrong with it.
Are you kidding me? How long does a PhD even take?
It should take only 5 or 6, honestly, but it took me 9.
5 or 6 years for a simple PhD? My goodness gracious.
Yeah, depends what you want to do. Okay, so one way to do this, right, would be to just multiply the denominator of one by the denominator of the other, right? See how, for instance, here, like, yeah. Well, you see what we did here, right? I took the 1/4 and I multiplied it by this, right?
That's going to be a lot. Isn't that going to be a little too long?
Right. Yeah. Wouldn't that suck? Yeah. That would suck if I were to take this thing, right, and like multiply it here and here, and then take this thing and then multiply it here and here, right?
That would be way too ugly, right?
It's very ugly. We don't want that. I mean, that's one way to get common denominators. It's like the brute force way. Like, it will work. But we can be smarter about it. So let's be smart about it. Yeah, let's be smart.
Factor it? You have to factor it, right?
We're gonna factor this, exactly. Yeah. So how do I factor x squared plus 3x plus 2?
See, this happened in my exam, but I think you find the which two numbers can add up to the middle one, but multiply to the third one, right? The third term?
Good. No. So it multiplies to this, but it adds up to this.
Yeah,
Yes, Bianca. Yes. I'm almost 40 and just starting. Nice. Yeah, exactly. Dude, learning happens at all ages. All ages.
Listen, man. Sometimes I forget even the most basic. Sometimes I even forget the most basic things, you know.
It's okay. I do too. Okay, so what multiplies to 2 but adds up to 3?
+1 and +2, right?
Good job.
Right, yeah. So I can write this as like x plus 1, x plus 2, yeah?
Yeah.
Plus, or sorry, this is minus, and then we have x minus 1. How do I factor,
It'll be
how do I
x
factor
plus
this one?
2 and x plus 3, right?
Good. So this is x plus 2, x plus 3.
Now what do I do after that?
Okay, well, we need them to have the same common denominator, right? So both of them already have an x plus 2, right?
Good job.
So that's already
What can you do
common.
with that?
That's
What can you do
common.
with that? Take them out?
No, we're not going to take them out. Well, I mean, we could, but let's leave them for now. We're going to notice, Ethan, right, that if I wanted this one to have the same denominator as this, it would also need to have an x plus 1 on it. So
Okay,
I'm going to
x
multiply it by the missing factor. And then I'm going to do the same thing here. I'm going to multiply this one.
X plus 3, right?
X plus 3 over... Yeah, exactly. Okay. Because you see now, I have an x plus 3, x plus 1, x plus 2, x plus 3, x plus 1, x plus 2. Yeah?
Alright. So you after you do that, do you have to match them together?
Well, this is also a very cool thing here. Do you know what x plus 3 times x minus 3 is? It's a special rule.
Difference of 2 squares, or x squared minus 9, right?
Good. Difference of 2 squareds. This is x squared minus 9 over x plus 3.
All of that.
X plus 2. Yeah, right? It's a lot nicer. Minus, and then what's this?
X squared minus 1? I don't know.
It is, yeah, no. It's x squared minus 1.
Alright. all over that same exact garbage.
All over that same garbage. Yeah, whatever. This is why I have copy paste.
Yeah, thank goodness.
Okay.
What now?
So now,
What can you
now
do?
now I can combine these because they have the same denominators.
My man.
Right? How do I combine them because they have the same denominators?
Let's just smash them together. Like you have the
Yeah.
denominator as 1, then bash the two numerators together, right?
You do, yeah. So, but this is where you have to be kind of careful, because a lot of times people will only put the negative on this. The negative goes to both things. So it's x squared minus 9 minus x squared plus 1. Well, yeah. So here when we had, I mean, this is kind of like poor form here, but this minus sign here is technically minus minus.
Okay. Now.
And that's why I started writing parentheses around these things. You really should write parentheses around this just to start with, so you don't fuck up. Because then when you get to here, this minus sign is hitting the whole thing. So that's why this becomes minus x squared plus 1.
All right. So,
You're okay,
so
Pen.
then
All good, Pen. I appreciate you, dude. Pen's also another great person. Shout out to Pen.
All right, but yeah. So you have to now that you got that down, you have to simplify it, right?
Yes. So it's x squared minus x squared. What's that?
Flat out 0.
I know, Pen. Pen, are you still department head of your thing, or dean, or whatever you call it, department chair? It's a thankless job. All right, so -9 plus 1 is then -8, right? And then that's all over this. And there you go. I think that's it.
That's it.
Yeah.
My man.
It was
You did it.
It was as simple as that. I don't even think I had that simple thing. In
It's
there,
simple as that, dude.
I think I had a trinomial, but it couldn't even be factored because not only was I running out of time, but I looked and I couldn't find any two numbers that could multiply.
Yeah.
Like that's what I hate. Why couldn't they just make my life simple with that?
Math is about seeing the simple tricks. But the only way to see the simple tricks is to have done the simple tricks. So I say it's okay, if you didn't get it on the test. Now you know for next time. And you'll get it on the test, right?
Yeah, but to be honest, I don't even think they'll really. No, wait. If I do decide to join a specific math course, I might just come back and see it again. So you know what?
Yeah,
I'll
you
take
should.
it into my head.
Yeah, take it in, dude.
But is that a common thing? Is that a common thing after, like, when it comes exam time, you forget the whole basics and even a recent one?
It does happen for sure. Yeah, a lot of times people get what's called like testing anxiety. So they whatever, they just like kind of like lock up and freeze on a test and then freak out and then all their knowledge goes away or something. But I say the best way to deal with that is to put yourself in the same testing environment when you're practicing doing questions. I have some students that will like do their homework in their bed, or they'll have their phone out, or they'll be chilling on the couch, or they'll be watching TV. And the problem about that is, yes, you are learning, but you're learning in an environment that you're not going to get tested in. So when you get put in a test where like it's quiet. Oh, thank you, Pen. Wow, I got a $20 donation. Fuck yeah, Pen. Appreciate you, Pen.
Pen Center just donated $20 to Actual
Love you, Pen.
Education.
So yeah, when you put yourself at least in the same situation that you're going to be testing in, you're less likely to get that testing anxiety, blank out, freak out thing, because you're not going to be anxious because you've been there before. It's familiar.
Okay. Well, that helps, but just have to go. So, talking about my current situation here, it's like, you would know it, but I've been working hard to try and see if I could actually get that 4.0 GPA.
Yeah. I think you can. I think you can totally do it. Oh, beta blockers, dude. I've heard about these beta blocker things, dude.
Have you heard of like how do I say it? Have you done programming? Are you good in programming? Like,
yeah, I program all the time, dude. Yeah, I vibe code too.
Which programming languages do you have experience in?
C++, Python, Java,
Oh gosh, Java.
Basic, easy.
Wait, basic, the beginner's all-purpose symbolic instruction code.
Oh, is that what basic stands for? I didn't know that.
Yes, beginner's all-purpose symbolic instruction code. That's basic. But
Oh,
that's
very
a
cool. I didn't
legacy
know
though. That's a bit.
Yeah.
Isn't that a legacy programming language?
Yeah.
Well, yes. I'm currently doing C++. You know, that's my programming language.
C++ is a great language. I love C++. It's one of the best ones to learn.
It's just that it's like, ever since I got into what's called functions, it's like I feel like I've been locked out, like completely zoned out of the whole class. Even though
I know.
was paying attention.
Yeah,
It's like,
dude, this whole I feel like I was locked out this whole year, honestly, dude. What?
No, to be honest, it's like when
Bit dissociated.
when it came down to that exam, I literally just used memorization for the whole thing. And to be honest, I am not proud of what I did. To this day, I'm not proud.
It's okay.
Okay.
It's okay. I've definitely used memorization to like not fail tests before. It's fine. As long as you understand it later.
Yeah, I will try to understand it later for this year, and hopefully by next year. But like, but yes, I have an 85 for that in that class right now. Last time I checked, I can't even see my grade anymore. They've locked it out, and exams apparently are due today. So, and it's like I'm always getting this thought that I did so terrible on the exam. Like I would at least get a 50%, and that's what I'm most anxious about. That's what I hate the most. You know, like I'm always getting these negative thoughts into my mind. I just can't get them out. That's what's been happening to me recently.
Meditating helps, dude, for sure. Try meditating.
Listen, man, it's like this 4.0 would mean a lot to me, especially since it's just my first time in college. So that's why I'm kind of freaking out over the whole thing.
You'll figure it out, dude.
But like at this point, I can't do anything. Like literally, I can't. I've done all the work I could. There is only like a project that I would hope I get 100 on, and that exam, and that's it. The teacher will give bonus points to everyone who's done practices, so there's that. But even with all that said, I'm unsure as to where I stand right now.
That's okay.
I was in the computer science department.
Just know you did your best, dude, and you're getting better.
All right, and to be honest, in my computer science department, it's like barely anyone has kept consistently a 4.0 GPA. I don't even know if there's a valedictorian in computer science in my region.
I guarantee there is. I guarantee there is.
Well, if there was, then that might have been a long time ago. But I'm trying to see if I could be that. If I could at least be one of the shining hopes for that department, because oh my gosh, people are completely struggling in classes.
Struggle makes magic sometimes, dude. Yo, do you help with English? I can kind of help with English, Zion. All right, nice. Let me run through more of these questions, Ethan. But yes, just trust you did your best. You did as much as you can, and you're gonna do even better next year.
Yeah, I'll
you do see physics and CS. Yes.
Okay, I'll see you then.
Cool, dude. All right. This question's from Joe. Is this a floor function, by the way? Sorry. What was your best advice for someone who started coding? Oh, get a project. I would say that you're not really going to learn. You're not really the same with like a spoken language. You learn a language much better when there's a reason to learn the language. If you're just learning it and there's no like need to learn it, your brain doesn't really prioritize it as much. For instance, like I took like 4 years of Spanish in high school. I didn't remember any of it, right? Because there was no real need for me to learn Spanish in high school, right? I got a girlfriend in Colombia like 10 years later. She didn't speak any English, but I really wanted to talk to her. So guess what? Like I learned Spanish. And my brain actually wanted to learn Spanish, and so I do speak pretty decent Spanish now. So yes, interest drives learning, exactly. So if you want to get good at coding, try to come up with like little projects that you want to code, and the struggle of you figuring out how to write the code to do that thing will teach you how to code much more than I know. There are these coding classes and these courses, cool, but it doesn't really stick until you need to use it. Sebastian, what are you doing for the stream? We're doing homework questions for 24 hours. We're almost 4 hours in. Bianca, what beta blockers did you get prescribed? I saw an Atlantic article about this. Apparently, like, it's very popular amongst like public speakers because it just gives them like confidence stuff. I already have like pretty good public speaking confidence stuff, so I don't really need beta blockers. But I think it's called oh man, alprazolam or something. I'm curious what the name of it is. Felicidades. Yeah, there we go. Yeah, there's some Spanish. Yeah, same way I learned English. Same way. Awesome advice. Yes, Joshi. Yeah.
Yeah.
Go get a girlfriend, boyfriend, whatever in that language, and then you'll want to learn that language. The floor function, yeah, it's sometimes seen in homework. What a floor function means is just like whatever it is as a decimal, it gets put down to the lowest thing. So for instance, what's up? I had a fluid dynamics and a complex potential question. It ruined my sanity. I'm sorry, dude. No. Ooh, Narosky says this is his specialty. Okay, Narosky, maybe you want to help out with this one? Because I know, for instance, like the floor of 1.79, right? That's equal to just 1. Right? And then like the floor of like 2.3 is equal to 2. So this is... That's it. Propranolol. Propranolol. That's the one I know. Okay. That's the one I saw in the article. Cool. Cool to know, Bianca. And you said it helps you out? That's pretty great. I mean, I think beta blockers are better than some of these people getting prescribed like Xanax, dude. Like what? Like just heavy fucking barbiturates. Like stop. I think beta blocker sounds nicer to me than Xanax. Or what's the other one that people get prescribed? Klonopin. My roommate was on Klonopin. Yeah, I think that stuff like just fucks you up. Okay, but let's see this. X, f of x, f of x. Yes, of course, Shin. Yeah, talk to your doctor. I agree. Yeah. Well, I mean, hopefully you can only get those things after talking to a doctor. Yeah, don't go, dude. Who is it? Some physics streamer. I'm not gonna name him. I remember was talking openly about how he was like microdosing antidepressants to see if he could get rid of his depression. Without a doctor, he was just doing it, and like apparently didn't have a great time. And I was like, yeah, that's gonna happen, dude. Okay, so then this is the floor of. Okay, nice. Narosky's already got it. Yeah, Jeff's like, I think, yeah, Jeff, I think you were on that stream with me. I think you remember it. I remember hearing it. I was just like, what? You what? Okay, so then this is the floor. Oh man, this hurts my brain. Of f of x over 10. So that's the floor of 379. Microdose textbooks. Yeah, that's a better thing to do. Okay, cool. Let's see. Narosky wrote something up, which I think is pretty close to what I have. Thank you, Narosky, for writing this up, by the way. Mm-hmm. Yeah, there we go. Right. X. Floor. And sorry, you're calling this floor then, right? Yeah. And then, can you do that? Sorry, is that how, can I do that with floor functions? Can I bring the 10 inside? Is that real? And then it's just like a double floor? I believe in this case. Okay. And then this is funny that it's just 5 times G times 267. Okay. So what is that? So that's 379. This is the floor of 37.9, which is just 37. Let's see if that works. So that's 379 times 37. And then that's 37 which is then 3.7, and then the floor of 3.7 is 3. This is actually a really cool function, actually, Narosky. Do you see this? So it does the full thing, and then it takes a digit off, and it takes another digit off. Oh, fuck. That's pretty cool, actually. Oh, this is super dope. This just takes any 3-digit number and then composes it into, like, kind of like a reverse factorial type thing. That's really cool. Okay. So whatever. That's g of x. Well, that's g of 379. And so then 5g of 267, well, we already know this, right? That would be equal to 5 times... Can't be standing anymore because I got floored 3 times. Oh, he's got jokes. He's got jokes. That's a good one. 267, 26, 2. Nice. I think that's it, Narosky, yeah? I think we did it. Actually, it wasn't too bad. And that does make sense, Narosky, what you're saying about this being basically like the floor of x over 100. Because you're looking at like the 3rd digit at that point. Yeah, the text box gets kind of weird. You have to use double... I think you have to use double dollar signs, Narosky. Or maybe not? Yeah, you have to use double dollar signs, I'm pretty sure. Alright, cool question, Joe. I like this. There we go. Beautiful. Yeah. We'll just ignore this dollar sign. We don't see it. It's gone. I forget how the text bot works. Yeah, no, I understand it. Very cool, Narosky. Thank you. Let me see. What'd you say, Bianca? I have some issues that let my body go into overdrive too easily. My heart rate and my breathing rate increase. Oh dear. That sounds like a panic attack, no? I've had those like twice in my life. And they're always involved at the doctor's office. I don't know, just like the first time I ever had a panic attack is when I was seeing like a ENT doctor and they said I had a deviated septum, and then they talked about how they were gonna have to like fuck my nose up, and just them talking about surgery, I don't know, the world started going black, and like I started feeling really cold, and I was like, this is weird. And like I've been under the influence of many different things, and this was very unique to me. I was like, excuse me, what's happening to me? And then my heart was racing, I was sweating, and then I ended up puking. I was like, what the fuck? So yeah, I totally understand the panic attack thing. This total levels the playing field. I still feel stressed, but a useful way. Awesome. Great. Sounds like you found a chemical balance to your brain molecules, which is great. That, I think, is a responsible use of pharmaceuticals. I think too often, because I just see it myself with some of the students I teach. Doctors and parents going fucking ham on the ADHD meds. Just for whatever reason. They're just like, oh, my kid has ADHD. I'm like, no, he's just a fucking kid. Like, he needs to just sit down in his chair. You don't need to narc him out with Ritalin. But it sounds like, yeah, what you found is like something that is a total game changer. Because it's, yeah. That's like no way to function, just constantly having panic attacks. That would suck.
Disqualified.
Narosky, what do you got for me, dude? Oh, Jesus Christ. Stick, slip, motion. Yeah, what the fuck is this, dude? Narosky, what'd you bring us, dude? What is this? I don't feel so good, Mr. Stark. Yeah, I think, yeah, I have ADHD and had existence since preschool. Yeah, I agree. There are people that legitimately need it. I just think it's overprescribed sometimes. This is from my contest in 4 days. It's a prep question. Is this for physics, by the way? Sorry. This is physics math Olympiad. Ah, very cool. It's what we call nightmare fuel. Okay. It's like SHM. All right, let's see. Let's see if we can try to do it. Time to make my Focusin. Wait, is that really the name of the pill? Focusin? Sounds legit. Focusin. Coefficients of static kinetic friction or mu naught. Yeah, blah, blah, blah. On one end of the spring is attached. Initially, on the other end of the spring is pulled horizontally. Oh, okay. Oh, it's a Simpson. Oh, okay. That I was about to say, it sounds cartoonish. Do I help with Python coding? I can try to help, yeah. Honestly, AI is super good at figuring out issues in code. The other end is pulled horizontally. Okay, so this is pulled horizontally with a constant speed v naught. As a consequence, the box will move intermittently with periods of acceleration. Oh, this is cool. Yeah, it's gonna like jerk. It's gonna like burp, 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 burp. Oh, okay. Determine the extension of the spring when the box is just about to start moving. Okay, so a force diagram, right? So we got mg pointing down. Well, like Fn pointing up, which is probably just equal to mg, right? Because nothing's at an angle yet. And then we're going to have friction like fighting it, right? So that's going to be mu static if it's like right about to start moving, yeah? So, and then if this is pulled with a certain extension x, that's going to exert a force kx on the box to the right. So I think you just say like kx is equal to mu s fn, or so they call it s. Sorry. So s is equal to mu s mg over k. Good. I think we did part 1, right? I think this one's good. That's the easy part. We take the initial position of the box as x equals 0 and the instant t. Okay. Express the acceleration of the box as a function of x, t, v naught, and the other specified parameters while the box is in motion. Gold is getting rid. Yes. Yeah. Zach is going to come in and help out with some of the math stuff here in about 20 minutes. Give me a break to go make some coffee and like some lunch. Yeah, I need to make myself some coffee. So, I mean, the acceleration is equal to 0 until x is greater than s, right? Wait. While the box is in motion. That's the best part of living with your mom. Yeah, she probably makes great coffee. Wait, no. It's stuck. Yes. Okay, so this is part A. We got part A. Oh, acceleration is equal to sum of forces, right? Sum of forces over the mass. Okay, cool. So that's equal to... You're going to have kinetic friction pointing back. So you're going to have minus mu k mg over m. And then the only other force must be the force of the spring, which... Interesting. Okay, Google, stop. I don't know why Google was like doing things. And a function of V naught. Okay. And then the force towards it, I think, is going to be... It's like how far this position has moved versus like where the box is. That's delta x, right? So delta x is equal to V naught t minus x. Aha. So this is equal to k V naught t minus x. Right? I think that's correct. Okay. Because this is the force of friction pulling you back. And then this is the...
Nice.
Thanks for the follow, Weird Champ. And then this is the force of the spring. Okay. Now for part C, which is apparently the hardest part. We would have gotten 2.5 points so far. Okay. An R is mu over mu naught. Static is mu naught, and then kinetic is mu. This looks cool. Yeah, it's a physics Olympiad question. Determine the time t equals at which the box comes to rest for the first time. Okay, cool. So if x of t is equal to v naught over omega t minus sine omega t. Who's calling me? South Carolina, no. What? Plus 1 minus r. I assume that's times s. And then 1 minus cosine omega t. So, it comes to rest when dx dt is equal to 0. So you have to take the derivative of this? Ew. It just sucks. Fine. Okay, so that pulls out just an omega over the omega, so you just get v naught. Minus derivative of sine omega t is cosine omega t times omega. So this is another v naught. Cool. Plus 1 minus r times s. Derivative of 1 is 0. And then derivative of negative cosine is negative. Well, derivative of cosine is negative sine. Negative is positive. So then you have sine omega t times omega. Yeah? Okay, cool. And I want this whole thing to equal to 0. Well then. Determine the time t naught at which it comes to 0. Oh, so I just got to solve for t is equal to 0? Oh, okay. So I only care about... No. I need this to be... Oh, okay. I gotcha. Here's what we're gonna do. Well, fuck. This actually fucks with things. Damn. I want to get these two things together, like sine over cosine, so I can get tangent, and then I can arctan it. That's what I want to do. Right, Narowski? Otherwise, this becomes kind of a bitch to deal with. 1 minus cosine omega t is an identity, is it? One minus cosine squared omega t is an identity. Ooh. Oh, it is? Okay, one sec. Didn't know that. Sorry, you said it's something... it's a half-angle identity? Huh. Yeah, I see it. I think it's a half-angle. So then I want the double angle. Well, no. This is what I want. This is what I want. Yes. Here we go. Very cool. Yeah, because I was like, I either need to get sine and cosine over each other, which I can't because this V naught screwing it up, or I need them both to be the same trig function. But what's curious here is now the argument's going to change. I don't really want the argument to change, but okay, sure. So this is the same thing as V naught. And then this is 2 sine squared of omega t over 2. Yeah, I agree. Cool. And then plus all this. Okay. But then how do I resolve this and this? Is there another, like... is there another identity somewhere? Oh, wait. No. I think I want to use this one. Dude. Look at this. 1 minus cosine of x over sine of x. Look at this. I got the same thing. Yeah. This is fucking tricky shit. Look at that. Yeah, it's I knew it was tangent. I knew it was tangent somehow. Look at that. Okay, so V naught. 1 minus cosine omega t. So I like move this over and then I divide by it, right? So we're gonna have negative, and then we're gonna say divide by. So actually, let me just like reverse the sign of this one then, right? So that's r minus 1 SW, and then that's sine omega t is all equal to 1, right? This identity right here is tangent of x over 2. So V naught over r minus 1 SW tangent of omega t over 2 is all equal to 1. My brain would be fried already. This is fun. This is a puzzle. You know, I don't hate this as much as I hate the math Olympiad stuff, because I feel like this is more of a puzzle. The math stuff just like blows my mind. Okay, so tangent omega t over 2 is equal to r minus 1 SW over V naught. So then arctan both sides, right? Cool. And then multiply by 2 over omega. Yeah? Do we know the answer to this one, by the way, Naroski? I think that's it. Is that the correct answer, though? It matches. Okay. Yeah, so I guess you need to know this one. Which, yeah, where the fuck does that come from? What's up, Zach? Zach's coming in hot soon. Zach, what do we got? Let me see what we got for like questions. We have a ton that have been uploaded so far. Yeah, look at that. There's some stuff. This is maybe physics or something. Naroski had a ooh, there we go. I like that. That's some stats. We got some good stuff coming up. This is a math Olympiad question. We were doing stats. Yeah, Zach likes stats. For which values of R will the length of the spring always be greater than or equal to its undeformed length? So the length of the spring is V naught T minus X. Wait, they actually write T naught as two pi minus so that's what this is. So they say it's 2 pi minus this? Huh. Okay. I think that's because it's because of the restriction on arctangent. So arctangent will only give you things here and here, right? So if you get this angle, right? You technically have to do also, what the fuck was R? Oh, R is just a variable? It didn't even tell us what R is. Oh, okay. Instead of omega t over 2. Got it. Cool. Oh, yeah. Okay. Nice music. Thank you, Potato Porridge. It's all like lo-fi music generated on Suno. What is this one though? Its undeformed length was what? Was that S? No. What year of college do we see that so I've dropped out before? No. Don't worry about this. This is a math Olympiad, physics Olympiad question. This is a very difficult physics question. You would not see this in a regular college. No, I don't think so. Oh, sorry. That is what R is. Yeah. Okay. The length of the spring always be equal to. Sorry. The length of the spring is V naught T, right? So length of spring. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . That's V naught T minus X of T, right? And its undeformed length is... Oh, this has to be just greater than 0. Greater than or equal to 0, yeah? Because at t equals 0, that's 0. X of t is also equal to 0. Undeformed length is S plus V naught T. S plus... Wait. No. It's undeformed here. Oh, you're right. Because it does get a head start. The deformed length. I think it's just V naught. Wait. No. Oh, and t equals 0 is the moment the box starts to move. Okay. Sorry, t equals 0 is not the time at which it gets pulled. You're right. Okay, this is S plus this. You're correct. I had a misgiving on what... Yes, very soon. Yeah. Oh, man. For what value of R, though? Okay, so what's that? That's S plus V naught T minus all this. And then what value of R? I'm thinking for just like R equals 1, maybe. Because I want this to just go away. Go away. Greater than or equal to 0. And then what's the next expression we came up with? S? S was equal to mu SMG over K. Which doesn't really have anything here. What do you think, Narowski? I can think maybe like, no, small t.
The baby voice is in. Yeah. What do they get? They gave this hint. Let's see, what's the hint? Curious. Yeah, okay. RS. Why is it RS?
Is it because S... Oh, wait. S is equal to mu naught mg over K? And then mu naught is equal to mu over R? I see this. Well, actually, wait. All of our signs are wrong here, though, by the way. Sorry. Oh, fascinating. And then this is, like, somehow coming out. Oh, I'm super dumb. Look at this. Wait. V naught over omega t. This cancels. V naught t. Yes. I don't know where the R is coming from here, though. I think we just had S. Oh, from the 1 minus RS. Oh, okay. Yes, and then there's a S minus RS. 1 minus R, yes. I see, it's coming from this. Oh, okay. But the sign is wrong. Okay. For what values of R? Let's assume we got all that right from this. What values of R? I don't know particularly. But here, I want to have Zach take over now. But I think we got very close on this one. Just the last two parts. So maybe, I don't know. Zach, do you want to like do this? Let me invite you to the stage so you can speak. Do you want to figure out the math here? Or is there too much physics in this? That's always a question. Is it a little bit too much physics?
We okay?
Yes, I can hear you. You're good, Zach.
All right, let's do this. Let's jump over. Sorry. There we go. You can see me now.
I can. Yeah, it should be loading. We'll give it a second. Oh, the camera still says no.
Okay. There we go. Where did I light off to? Because why not?
Wait, let me like try stop streaming.
You don't have to. I'm having my camera here in case it works out nicely, but if it doesn't work out nicely, no worries.
Okay.
Hi everybody, by the way.
yes, welcome everyone. Zach's in the house. Zach's another awesome. Let me give you a little intro. Zach's another awesome math streamer here on Twitch. He runs by the channel E to the 2I Pi, and he's volunteered to help out with our 24-hour stream here, also answering the math questions that I just can't do some of these, by the way, just because I don't have the math PhD knowledge that you do.
Yeah, well, I don't have the physics PhD knowledge you do, so
we complement each other.
We complement each other. You can help me do all the physics I can't do. It's surprising, as an applied mathematician, I should know more about physics, but I just feel like I don't. As far as when it comes to these problems, at least I know a little bit. But I know enough to.
It was always funny watching things. Dawn do E&M, or like I think Penn Center was trying to do an E&M course at one point, and he picked like the most ridiculously difficult textbook to start with, and I was like, no, Penn, dude, this is not the way to learn E&M. This is nightmare fuel.
Right, I know. Okay, so I have no context for what's going on. I'm just looking. I was trying to just compare what you were doing against.
Sure.
Yeah.
Because there's like a little physics in this. I didn't know. I think they want this delta L to be greater than or equal to 0.
Sure.
I don't know if there's like any math intuition on like things with sines and cosines, such that this expression is always greater than or equal to 0.
Well, do we know anything about R and S?
Good point.
Again, I don't have context.
Right.
We do. And in the event that we do, we know R is mu over mu naught. We know that. Gosh, I have to catch up.
No, you're good. We know, R is related to, but there's no mu's in here anymore, right? And then I don't think anything. I think it is just pure math at this point. In the same way that once we got here, right? And I was having to like try to figure out how do I solve this. This cute little half angle thing came up, and then I was like, oh, cool, it's arctangent, beautiful. I just don't know if there's some relationship here, because these are at least both omega. I'm tempted to do it the Zach way and just make everything with Euler's form.
You could. That is Zach way. But you had some nice cancellation with this. Well, I'm not seeing anything off the top of my head.
Right? Yeah. I mean,
I'm not seeing. Yeah, just because there's different parameters here.
Yes, and also because we have 3 terms, which is unfortunate, right? Because this is screwing everything up too.
Yeah.
Like if that wasn't there, I could like figure something out. Because then I always just love making things into tangent. I'm just like everything's tangent.
Yeah, or cotangent in this case, right?
Or
you can make
cotangent.
cotangent if you could really do that.
Yeah. The interesting thing is they're asking what values of R. So again, I'm tempted to say R is equal to 1 because that at least knocks this out.
Okay,
And then I
have a crazy idea.
Yeah.
Maybe what they want is to say combine the first and third term.
Yeah.
Because it has a common factor of S.
Okay.
And you might be able to solve in terms of R now.
Okay, let's see. So delta. So we're gonna like move this over here.
Again, I don't have much context for what you're trying to accomplish, but if you're trying to just solve equations for the sake of solving equations,
we're just trying to. I just hit it with the math hammer.
That's all you're doing, right? So just factor the S out of those two terms.
So that's
and then,
what is that? That's 1 minus R. Wait. If I can factor today. I pull. Let me just do this. One second. S cosine omega t minus RS cosine omega t, and then I have an RS here, so we're gonna put that over there. So then I have plus S cosine omega t, and then that's gonna be R 1 minus S.
Yeah. R1 minus. Let's see here.
No, it's RS. Sorry, RS.
Yeah.
1 minus cosine omega t.
Cosine. Well, no.
Did I do that right? Did I fuck that up?
Okay, yeah, no, you're good. You're good. I had to think that through, but I think we're okay.
Okay.
And then S is a common factor between the last two terms.
Good. Okay, so we could do S cosine omega t.
Yeah, cosine omega t
plus R 1 minus cosine omega t.
Yeah.
Wait. Oh man, dude, I want that. Now I really just want R to be equal to 0.
The good news here is that we could solve for R. So at least if you let delta L be 0 or bigger than 0, we could solve it, find a value of R that's connected to these other things, right?
Oh, I see what you're saying.
Idea.
Because now R's been factored out of everything.
That's right. Yes. So you could subtract things over and then solve for R.
Beautiful.
Assuming that's your goal. Again, I'm guessing. I'm just guessing here.
It is my goal. That's all I want. That's all I want, Zach. Wait, what is the minimum?
Just solve for R, and I think you're okay.
Right? Yeah, because we just need this to be greater than or equal to 0. That's what they wanted. They said.
Okay. Cool.
Yeah. What is the minimum for this? No, so I think we just move that over. So it's negative V naught over omega sine omega t.
Yeah.
And then you divide by S, greater than or equal to, and then this is cosine omega t plus R 1 minus cos. This is just a mess, dude. What?
Yeah, I'm not sure who gave what. I'm trying to figure out what the point is.
It's a physics Olympiad question.
Oh my gosh! Please, no, no. Don't do this to me on my first question on the stream today. That's not.
No, that's why.
Tell the physics guy not to.
Just don't worry about it. Don't worry about it. Don't worry about it, dude. Don't worry about it. Okay, there we go.
No, it's fine. It's fine.
That's what I think it is. Yeah.
There you go. Yeah, I think that must be the way.
Norosky, is that the right answer? Or you? Norosky has the answer key. Show us, Norosky. And then I'm gonna move to another question. I'm not gonna torch you, Zach, with this stuff because, like, yeah, this is kind of weird. Because that's like after the box stops, how long will it remain at rest before moving again? Yeah, it's a cool question. So here was like kind of the overall context. They had like a block and it was attached to a spring, and you're pulling on the spring, and there's friction between the block and the ground. And so what happens is as you pull this thing, it starts to like it jerks, like it'll move then it stops, it'll move then it stops, it'll move then it stops.
I can picture it.
Yeah. And so there's a way to like show how that works. Oh, okay. So here's the actual answer. All right. So let's see. I mean,
yeah, R is bigger than or equal to the half. Right. Were we supposed to?
Do we make a small angle approximation?
Maybe. That's probably what this is. Like, honestly, because if this whole but Now you're making me like question everything. The v squared v naught over s omega. I'm wondering.
Yeah.
If somehow we need to figure out. Okay, so we need this whole thing to be positive, but is it?
And it has to be for all t.
So, yeah.
It has to be for all t though.
Right, and that's what I'm worried about.
Because this is going to oscillate, right? Between 0 and
1.
0 and
negative
2
and 1, or negative 1 and. Sorry, you're talking about the total. So the
sorry.
total
The whole.
Between, I guess see. So you could get a divide by 2. So this would go between, as you say, 0 and 2, right?
Okay.
And the numerator will go all over the place. It could.
Yeah.
You have a sine plus cosine. So that's probably where the 2 comes from. I bet you that the 2 comes from the because the lower bound that the denominator would be.
I see.
So I bet you that's where the half comes from. Then the numerator would probably be because. Let me think about that. Why would V naught
That's very cool.
over S? Yeah, so because if you had a 0 there, you'd be guaranteed to be much bigger, right? You'd have like this thing that tends to infinity. So the worst case scenario is the denominator being 2. I could get behind that.
Yeah, okay.
I was trying to figure out like what context, like why would this even make sense? It does make sense. It's just that the denominator, the worst case scenario is that denominator is 2.
Right.
So that's what that's trying to express. Now the other part, worst case scenario would be 1. Why would that other? Because you have a negative sign that could be factored out. So I suppose we could just take care of that right now. But even so.
Oh, I see. Are you saying I can just get rid of the negative sign right here?
Don't get rid of it. Just factor it out. Or what we could do is take the cosine omega t.
Can I switch the order of this?
You could. Yes, but that wouldn't be a good idea.
Yeah, let's not do that.
More likely, you would want to change the denominator. You could swap the denominator order.
Okay.
Would that be useful? I don't think so.
Because then it oscillates between 0 and negative 2.
That's right. I don't think that's helpful for us. But the numerator must have a reason why that negative sign is there. So what's going on with sine omega t? What's the worst case scenario that this numerator could be? It could be, I mean, we know the answer, but why is it that answer? Go ahead.
I feel like it's small angle or something, no?
Must be.
Let me think. What if I divided everything by like sine?
Yeah.
Then I got cosine omega t. I got cosine omega t over cosine omega t. No.
This seems like a graphing question. This is like begging to be graphed. I feel like like what plot can we make that would, like, if we pick some parameters, is there a reason why this 1 plus v naught over sine omega squared? Is there something about a graph of this that would give us insight? Because what this tells me is that numerator is bounded below by -1.
Yes.
It has to. And more, and it's actually gonna be a little bigger than that. But I'm trying to figure out why. It looks like Narowski has an idea.
Yeah, he has an idea. He says to not even like break it up like that. He's thinking that for whatever reason this oscillates with this amplitude. Okay. Is that true? If you have sine t cosine t and you have like sine t plus b sine t.
So that's just using the Pythagorean theorem.
Oh, okay.
I think it's like a riff on that we might be. Well, he's taking the coefficients and saying, let's just square those.
Right.
And then
take the square root of them.
Right. That would be like taking. What am I trying to say? This looks a lot like like when you take the modulus of a complex number type thing. You're taking the two coefficients and squaring them, and then taking the square root of this.
Yep.
I could get behind that. And then the lower bound for this is definitely bigger than or equal to 1 plus the v naught over omega squared. So that right term must be at least 1, I bet. Which,
I see. Well, because you want if you want this whole thing to be greater than or equal to 0, right? Then you need this to be greater than negative RS, right? This whole part?
Right.
Yes. So this has to be greater than or equal to negative RS. And then could you maybe like ooh, wait a minute. Now I'm wondering if there's like a Taylor expansion or something. Wait, square both sides.
Okay.
And then right, this is r squared s squared. And then maybe there's something nice that comes out of this, right? So this is wait, change the sign. Wait, if I square, do I have to change the sign there? Wait, what?
If you square, ooh.
Yeah, what are these rules?
That gets tricky, right? Because if you want to, yeah,
what are the rules here?
You have to. So if you multiply by a negative sign, that's going to change that changes for sure.
Correct.
But your function is, since your function is, well, I don't want to say that because your function that you're applying on both sides is an increasing function. It's monotonically increasing. Well, no, only from 0 to infinity. So we have to know the thing you have to do is if you apply a function that's monotonically increasing on both sides, you're going to get, you can keep the things the way they are.
Yes.
That's the way it works. But you have to limit yourself to 0 to infinity, right? So as long as we're on the, you'd have to guarantee. I don't know that we can do this. I don't know that we can square both sides.
Okay.
I'm expressing my doubt.
I know what you're saying. I know what you're saying because if you do like 1 plus x is greater than 3 and then you square both sides, you actually get 2 regions, right? And then you have to determine like which region is.
Exactly.
Oh.
Right. Can't really do that. So I'm not. However, it would be convenient if we could do that because then we get rid of the r squared s squared term.
Yes, I know because then it's gone.
That would be very nice.
Yes, I wonder where the 1/2's gonna come from though.
I like the reasoning that Narosky's given though.
Yeah.
I mean that might be good enough. I'm not convinced that that's true, but it seems like a plausible argument. So I'd be willing to go with it, to be honest.
Okay. Yeah. He says we take the minimum value for L and wait for L. What is this L? What are you saying for L here, dude? What? 1 sec.
Take the minimum value of L, and we get that as the smallest at RS minus E.
Sorry. What was? Oh, L min. Okay.
Yeah. So I think I think there's some derivatives going on or something like that. Like there's going to be.
Well. Oh, okay. L is the length of the thing, I guess. Is
well, we're
RS
given
minus...
delta L. We're not. I guess we'd have to have like a. Yeah.
Oh, sorry. This is RS minus E. Is what he's saying. E. L minimum is RS minus E for. Yeah. L has to be greater than or equal to. No. Wait. Yes. L has to be greater than or equal to 0.
Yeah.
RS has to be greater than or equal to A. Yes. Well, that's what we said here, right? Right. So R is greater than or equal to E. Wait, but why did I have a negative here, though? Sorry, what?
Because you subtracted RS from both sides above. Oh. You did the delta thing with 0, and then you subtract.
And then I moved it over. Oh, I see.
Yeah.
I see.
Yeah.
Okay. So can we just assume it's there and just see what happens? Let's just
Sure,
assume,
do it. Just go ahead and do it. Like
just fucking do it. See what happens.
I'm gonna put faith in it for now.
Yeah, we're gonna put faith in it. Okay. Because then this is plus s squared, right? Plus s squared r squared, right? And then minus 2sr. Did I have that right? No.
Yeah.
Minus.
Plus 2s. No.
Wait,
no.
because it's s minus rs.
That's right. Right
minus
now,
minus 2s squared r.
Do this. Do s squared times 1 minus r squared.
Thank you. I like that much better. Yes. That's what I want. That's what I want.
Yeah. That should be fine.
Minus 2r.
And then you. Yeah.
Good. Okay.
That's fine.
I see a 2. I see a 2 coming out somewhere, right?
Yeah. So the r squared s squared gets divided. It gets subtracted out.
Mm-hmm. So we have plus.
That's nice. And then we get plus s squared minus 2rs squared.
Okay, that goes. Okay, cool. So then r is less than or equal to 1/2.
Don't forget that 2rs squared.
2rs squared. Yes, thank you. Yeah, got it. Okay. Oh, okay. Wait. So it's 1/2s squared. V naught squared over omega squared plus s squared.
They did that really fast.
I did that really fast. One sec.
You did that really fast. That looks close. It's awful close. That's it. That's exactly it.
Oh, that is. Oh, okay. Oh, I had my sign wrong. Whatever. Just move the sign the other way.
You're good.
And now we have
our as we go along, right?
Yeah.
Like this, here's a PhD in math making it up as we go along. This is horrible.
Dude, I think it works. It works. We did success.
Oh my gosh.
Dude, this is the most physics thing ever, dude. We do this all the time with minus signs. I know math gets like very particular about watch the minus, and physics we're like, no, just wave the hand. Just switch it later if you need it.
Okay, so later on, I don't know if you can put me on screen at some point, because there may be some problems I need to put out on the chalkboard. I have it so I can share my chalkboard. You can see this here.
Yeah.
I can do that later. You don't have to do it now, but I'm just saying if there's a question later on, we can. I've got it set up so I have virtual cam on.
Perfect. We want to.
Boys and Mouse wants to see me, so.
Yeah. It says fail to start camera. I don't know why that is. Maybe I have to restart the stage here or something. Let me think. Here, let me move you off the stage and back on the stage, Zach, and then I'll see if it allows you. Let me see if I can get that real quick. Let me move you.
Sounds great. Good job, Neuroski.
Yeah, good job, Neuroski. That was good. All right, then let's invite him back up. And then here, let me stop streaming. Why is it? It tries so hard.
But in the end, did it even matter?
Dude, look, because I get this spinning wheel of death in the end.
I'll stop my pop culture.
No, we love the pop culture stuff. It's great.
Neuroski, I'm so sorry for you.
Where's 212? Discord. I want to know what this error is now. I do have hardware acceleration. What's wrong with you? Reinstalling Discord. We're not going to reinstall Discord, unfortunately.
Yeah, don't do that.
Yeah. Can you share
Discord? Just didn't.
Can you share your screen or something? Can you share your screen?
I can do that. I can
and
try.
will that show you? Yeah, maybe. Let me stop streaming.
I don't have permission. I don't have permission to do that. No, I do.
Oh, let me give you perms.
Okay. I can do it this way, if you like.
Yeah, there we go. Okay.
That work?
I'm still waiting for something to load.
Here. Let's do this.
Discord.
Discord is not supposed to be this difficult. Oh, Discord's supposed to just work.
Okay. here's what I'm gonna do. Because I can close Discord. It's totally cool for me to close Discord because the stream keeps running. Let me restart Discord, and then I'll start this stage thing here again, and then have you all join, and then we'll see it.
That sounds great. Great.
All right.
Yeah.
1 sec. Come on, Discord. Today, let's load. Oh, they just didn't up. That's probably why. 1 sec. I need my like task manager. Task manager. Good. We figure out why Discord's being a pain in the ass today. Discord. There you are. Let's end the Discord tasks. There we go. Okay, now it's restarting. At least got something close. Good. Okay. Where'd you go? Where'd you go? I miss you so. Okay. Discord's up. Okay, now let's go here. Okay, now we're up. Now I got Discord up at least. There we go. Let me invite you to the stage. Okay, great. And does the camera want to start?
Yes?
No, it's still timing out. Try to do the share screen. And maybe also, I'm trying to think. Yes, see, it says live. Can you see a preview on your page, Zach? By the way, can you see your screen share?
I don't think I can. That might be my problem.
Yeah, I think it's maybe because I just see a blank screen. Is what I see for your screen share.
Okay, that could be because I'm.
Zach likes Linux. Zach is a Linux man.
Yeah, I do it that way. Okay, so I have a thought. What if it's so you can't see this my camera right now?
No, it just hangs.
Okay, don't worry about it then. What I can do is I can share when it's appropriate to do.
Like a screenshot or something.
Yeah, I'll just do a screenshot.
Okay,
can't even see
that works too.
can you?
We lost gold. I'm still here. Poison. Chill out, dude. You had to do some digging. You know, Zach, I need to get you on the stylus game at some point. Do you not have like a Wacom tablet stylus? Do you have something like this to do some things digitally?
You will not convert me.
Oh shit, not good.
Dude, because then I could literally just give you access to this whiteboard. Wait, how did you do it with Pen Center when you guys had like the group things?
I did it with my mouse.
Ew.
Ew, gross. I know.
Ew.
I know.
Ew. What?
It wasn't great, but we do it. I use the chalkboard whenever I can, but sometimes that's not.
We need
questions. We have
let's go through some questions. All right, let's go some questions. Pen Center's like no. Pen's like, why can't we get it? Yeah. Well, you know what we're gonna do? We're gonna find some device or something that like scans your chalkboard and then like moves a mouse somewhere like on the thing.
Yeah.
Okay.
We'll make it work. It's fine. Right. I think what we're doing here is fine. Let's just continue.
Let's keep running. Let's keep running. I'm so good with that. All right. Awesome, Neuroski. That was a cool question, by the way. What's my password for this? What? Excuse me. Sorry, 1 sec. Do I have caps locks on? 1 sec. Oh, I did have caps locks on. That's why. Okay.
Okay.
There we go. Okay. We're going to mark Naroski's as done. Because we just started moving some minus signs around. Whatever. Don't worry about it. It works. I like. Okay, I feel like I like the physics Olympiad better than the math Olympiad stuff because the physics stuff seemed at least doable-ish.
I don't. Now, to be honest with you, I don't like the physics or the math Olympiad stuff.
I don't like them either, dude.
At it badly. Yeah, like it's not my favorite. I don't do it. Like I'll do it on occasion depending on the problem, but if you give me like a Putnam problem, I will not be very happy.
I hate that stuff, dude. Anytime I see JEE, like get out of here, dude. I don't want to do this. Let's see. Do you like this molecule arsenic? I don't know what that means. Thank you. Okay. We do have some funny submissions. Okay, whatever.
It looked like ash. It looked like you have some double bonded carbons I saw.
Yeah. So. This is... Ooh, this is you. This is all you, dude.
This is me. Oh, this is me. This is a basis question. Okay.
Yes. Okay.
This would actually be a Penn Center question because Penn Center
Penn Center, this is you, dude. Penn Center's fighting the Hydras, apparently.
Yeah, well, let's figure this out. So we've got 3 vectors. Identify whether UV forms a basis. So what you want to check is that these are linearly independent.
Okay.
Right? So I want to check, is this a linear independent set? Is there a linearly independent set among these 3? Now, one thing you can know for sure is that the size of this basis, since there are two independent vectors, right? So E, X, and E, Y are your standard basis, I'm assuming.
Yep.
So you want to check, all you want to do is verify that these are there's a pair of this.
You put them in like do you put these as like column matrices and you see if the rank is equal to 2 or something?
Yeah, basically. Like you can determine. So you just pick any pair.
Okay, let me pick.
And actually, no, never mind. We want to just check U and V. So just use the U and V vectors. We can just check to make sure that those are independent by checking whether the matrix reduces to the identity. So
gotcha.
So the matrix here, 1, 2. Well,
is that how it works? Is that the matrix?
Let me check. You've got 1. Your first column vector will be 1, 2 because you have EX plus 2 EY. So your first.
Oh, they're column vectors. Gotcha.
That's right. Yep. And then V would be negative. There you go. So as long as I can reduce this down to the identity matrix in row reduced echelon form, we're good.
Okay.
That is equivalent to saying this is a basis. And
I feel like I'd want to switch these maybe. Make this like 2, 1, 1, negative 2.
Yeah. And Jeff's right here.
They form a basis if you can 1, 0 and 0, 1.
Basically. Yeah,
okay.
That's equivalent to what I was just saying. You make the identity. If you can reduce this to the identity, you're Gucci.
Got you. Okay. And then the way to do this, I would just like add this one to this one. So, or subtract that, sorry. So that would become 1.
What is EX? What are they saying in what is EX? Oh, it's the EX vector. Got you. Okay. Chat is hard.
My X was definitely more V than less U.
Oh my gosh.
What's up, Kato, dude? Good to see you, dude. I don't even know what that means, Jeff. Jeff, what does it mean if your X was more V than U, dude? Like, what? Wait, okay. I want to... Sorry, no. This is fine. I wanted to add -2 times row 1 plus row 2 implies row 2. That's what I wanted to do. Okay, gotcha.
Right. Or store it in row 2. That's what we're...
Is this like the correct way to write that? That's how
you can write it that way. That's great. That works.
Okay, it works. Okay. So that's 0, and then that's 4 plus 1 is 5.
But this is going to work out because you've got a 0, 1 in the lower row.
Yes.
So I can divide by 5, and then I
divide
can
by 5.
Multiply by 2, and we're done.
Got it.
So
implies row 2. So then you have 1, -2, 0, 1, and then yes, and then I can add to row 2 plus row 1 implies row 1, and then we get 1, 0, 0, 1. Okay, and this means they're linearly independent then, right?
That is equivalent. Yeah, that's an equivalent statement. So there's a theorem. You don't have to prove it for this problem, I don't think, but you can prove that what we just did is equivalent to checking linear independence.
Okay, very cool. All right, but then what's this part B? It says express W in this basis.
Okay, so this next part is, now that we have a basis, how do I write W in terms of U and V? Right? So what this amounts to is, now that I have my standard basis vectors of 1, 2, -2, 1, I need to find a solution that is 3, -2. So let's write out W. W would be 3, -2, right?
So W equals as a column matrix like this?
Yeah, as a column vector, right? There you go.
Gotcha.
So just take that, and I need to find a set of coefficients where if I take some multiple of 1, 2, and some multiple of -2, 1, we get -2. There you go. Yeah, you want your A and B.
I want like this? Is this what it is?
Yes, that's exactly. Yeah. That's what you want.
Okay, cool. See, I'm getting more and more comfortable with matrices. This stuff used to like freak me out.
But this amounts to just solving again, right? Following the same row operations.
Yeah.
That's all you're gonna do.
So you mean like, I could just like turn this into another 1, 0, 0, 1 and then get this maybe?
So we follow this. So follow the same procedure, and so like, what was the procedure?
I see.
You take 2 of the first row, add it to the second row, or -2 of the first row.
And I'm gonna have to do that with this as well, though, right?
Yeah, but do it on the right-hand side now. So just apply that procedure to the right-hand side.
Oh, okay.
It's the same thing.
It's the same thing here. Okay. So -2 of the first. Let's just copy what this procedure was, and then we're just gonna do it just to this right-hand matrix.
That's right.
Oh, I see. The other way would be to what is it? Like find the inverse of this, I guess, or something, right?
That would be the inverse. Yeah. Well. Yeah. You could swap. You just have to swap some entries.
Yeah.
Actually. So bad.
Oh yeah, that's not bad at all, actually.
Because the determinant's 5. You just divide everything by 5 in the end anyway, and then you swap.
You swap these, and then you make these negative. So this is 1, 1, -2, 2.
Yeah.
And then I just multiply this by 3, -2.
Yeah, that should do it.
Right? Yeah, because I'm operating this. I operate this on this, and that makes it just 1.
Yep.
Okay.
That's the identity. Well, it's the identity matrix, but yeah.
Yes, yeah. It's the identity.
It's your 1 in that vector space, but that's fine.
Super 1.
Super 1.
Okay, so 3 minus 4 is -1, and so this -1/5. I guess
this is fun for me. This is like.
Oh, I love it.
To hear you talk about Super 1.
Super 1. It's Super 1, dude. It's like it's the one that's bigger than all the other ones because it has infinitely bigness of ones.
Love it. Okay, so 1/5 identity, and then so you do what is it? -3/5 or 3/5 and -2/5. I think is what it'd be.
Well, let's see. So
no, sorry.
3 minus 4 is -1, right? So -1/5.
Yeah.
And then this is -6. -2, so -8, so -8/5.
-8. Yep. This is the way.
This is the way. And wait, so is this just my answer? I just give them this.
Those are your coefficients. Yeah, that's the combination. So you can take -1/5 of the first vector and -8/5 of the second vector. We should check this. We should actually verify
let's check this. Let's check this. Okay. So we say -1/5 of U minus 8/5 of V. Should be equal to 3EX minus 2EY.
That's right. So 3 -2 should be the end result.
So let's see that. So what was U again? U was I just need to copy this
1,
down.
2. Yeah. It's 1, 2.
1, 2. Yes. Oh no. Go back.
Rotate.
Come here. There you go. Okay. So it's -1/5 of 1 and 2.
2, good. Yep.
And then we have to say -8/5 fifths of -2, 1, and that needs to equal 3, -2. Does that? Well, let's see. So
you get -1/5, and then 16 fifths added to it.
Plus
in the
16
top,
fifths. Oh, that is.
which is 3.
15.
That's good news.
15 fifths. Love
That's
it.
15 fifths. Yeah, and then -2 fifths and -8 fifths together is -10 fifths. We got it.
Gentlemen, we got him. Let's go. Do you study often, or is this purely by memory? This is Zach's memory right now I'm working off of. This is not my memory at all.
I'm sort of okay at this. Like, I'm sort of okay.
No, you're great at this stuff,
I might be able to do a linear algebra class in my sleep, maybe. But, like, it depends on the level of linear algebra, though.
I think I just get scared anytime I see like basis and like space and stuff. Like I'm cool working with vectors and matrices, but then we start like putting words to these things.
Well, so one other thing I didn't do and I should have done, because a basis technically has to span the space, because you have two linearly independent.
Span.
Right?
Yeah, that word. That word span. What does span mean?
The words all span means is, can you reach every vector? So I suppose we should do this since for the completeness. You can. The short answer is you can. But can you reach every single vector? The answer is yes, because our matrix reduces down to the identity. It's equivalent, right? There's a way to do it. Like I don't want to go through the proof right now, but basically you want to verify that every single possible vector in R2 can be reached, and the answer is yes. Yes, you can.
Because you have 1, 0, 0, 1 times anything. And yes, got it.
And Jeff has it right here. If EX and UI reaches every vector, then so do these.
I've heard that before. Yes, yeah. If like the components reach all the spaces, then the superposition reaches all the spaces.
Yeah.
Or spans the space.
And here's a way you could think of this. This linear transformation, because the determinant is non-zero. What it'll do is it'll do you actually showed this earlier. It's going to be some kind of rotation or reflection or some kind of thing that just transforms the space. So if I just took the space and transformed it by rotation, that's the same space. Or if I transform it by reflection, no big deal. We can handle that.
I see. Yeah. I think this is just a rotation is what this is. When these are... We had this earlier at some point, right?
It's similar to a rotation matrix. I think there might be a little bit of stretching it out, but
it's a sheared sheep.
Yeah,
it's a sheared sheep.
It's a sheared sheep.
Was that today or yesterday, dude? I can't tell what day that was.
I shared that with you. That was yes.
Oh man. Malek says, "I suck at math. What's your advice to be proficient like you?" I'm nowhere close to being proficient, Malek, dude. Don't worry. My advice is just to practice things. Zach, what's your advice? When you probably get this a lot, right? Students say I suck at math. How do I get good at math?
You suck at math by doing math that's harder than what you're currently doing. That's honestly how I did it. But like you have to continue to practice it. I got good at matrices because there were problems that required me to be proficient at matrices that were much more difficult than what I was doing. I tend to do better when I'm given something harder than what I'm capable of, because that pushes me to learn the thing. But I think it requires a level of effort, right? Like that's not an easy answer.
Yeah,
I can't.
You got to struggle.
You got to struggle a bit.
Yeah.
But I think the persistence will pay off if you continue to do it.
Yeah, I agree. Yeah, I like the struggle analogy. I always like referencing everything back to the gym, but if you want to like build muscles, for instance, you don't lift things that are light. You have to lift things that are heavier than you, because that's how you.
Yeah.
You have to like break yourself to build yourself, and I think I break myself constantly with math.
Yep. That's what grad school taught me. That's what you just have to do the hard thing.
You just have to break yourself, and eventually you'll get the piece of paper. They'll call you Dr. Zach.
I can say that, but it was a nightmare to get through. 5 years of lots of study.
I told him it was
Monkey Man.
9 for me.
How are you doing?
Malek says, you didn't introduce us to your friend. Oh, yes, I did. Well, you're coming here late on the stream, but this is Zach, E2I Pi. Yeah,
you can't see me. I'm on Discord, but you can.
You can hear him. He's God. He's just like floating up there in
don't do that. Don't do that to me. I'm serious.
This-
We're gonna get it this time.
Yeah.
So
So
I don't
this
have
is.
any math stuff on there right now, but because all the VODs were
You're almost at 1,000 followers. Oh, we gotta get you to 1,000, dude. What? Okay. Go.
988. I mean, it's close.
All right, go follow Zach on Twitch, please. Let's get him to 1,000. Let's at least make that.
So close.
We're
But
so close. There you go.
you're very kind. I appreciate you.
Are you consulting with the ghost of mathematics past? Dude, we could do a Christmas Carol. It's a Christmas Carol stream.
So what does that make you, Dr. Gold?
Oh man, I'm Scrooge for sure, dude. I'm just going around looking at all my regrets, dude. The math Scrooge. Nice. All right, good question, SFR. I like
We're
that.
trying to get you. We're trying to make you a little bit more rigorous. That's what we should do. Is that's you're being called by the ghost of Christmas past because you know what's
Because
your crimes against
I've
mathematics,
committed
right?
a lot of crimes against mathematics. There's a lot of hand waving in physics. There's a lot. You saw it in that last question where I was like, yeah, just switch it. Just switch the less than sign. Who cares, dude? It's great.
Right. Anyway, Christmas mouse is in the house apparently.
Yeah. What subject destroyed you the most? Like broke me? Oh man, that's a good question actually. What question? What?
I can
Probably
tell you for
quantum.
me,
What was it for you?
Yeah,
What was it for you? What?
quantum, mine was functional analysis and
Functional
like,
analysis.
It was like the deep theory of real analysis for those who need more abstraction in their lives is the best. If I'm being snarky about it.
Those who just seek pain in their life.
No, that's being ungenerous. I should say it was a hard class just because it was so abstract. That's really what it is. You hit it. Everybody has their ceiling where they hit their head against the abstraction ceiling.
Yeah.
Right.
Yeah. Okay.
And that was for me one of the classes that did it to me.
It sounds like for me, like complex analysis was already like kind of messing with me, and that's why I didn't go into real analysis. I was like, oh no, complex already like broke me.
Hold on, TikTok. I got a Dream of Dawn says, Your Honor, they pulled a sum out of an integral without justification. Death.
It's punishable by death, Dream of Dawn, dude. I'm sorry. I'm a bad person sometimes.
What if we need more money in our lives, Zach? You know what? I wish I could help with that. To be honest.
Yeah. Yeah, we haven't figured that game out yet.
Yeah.
Have you ever felt envious to the one valedictorian kid in your class? No. I think I used to like compare myself to these people, but now I don't because I know like I don't know. They all like burn out anyways in life.
People have gifts and their ability to do things is like there are people I met in grad school that were amazing at mathematics and just could pull things out of thin air. It just is crazy, and I was not that person. I tended to be very slow and methodical, and needing much more help from my peers, to the point of like, there's a joke from Dan Pink who gave a TED talk, and I'll paraphrase by saying he's like, I made the top 90% of my law school possible, and I feel like I'm in that part. I feel the same way. I made the top 90% of my graduating class possible. So it's a little self-deprecating, but it's still I feel that way.
You have to take it in jest. Yeah, you have everything. For me, humor is the way I deal with everything too. I'm just like, yes, self-deprecating humor. Let's see. I have a question here, Zach, for you. Maybe you can help me with this one.
Okay.
Something with a Cauchy sequence.
Oh, Cauchy sequence. Yeah. Yes, I do.
Justified by using the definition why the sequence 1 minus -1 to the n is not a what is a Cauchy sequence?
Okay, Cauchy sequence. So let's write it down. You're gonna love this.
I'm gonna love this.
You're gonna love it. Okay, for all epsilon bigger than 0.
Oh, dude, epsilon. Damn it.
You gotta love it. Okay.
No, I need that shirt from Penn Center, dude. Okay.
Yeah, well, Jeff gave the punchline away. I was gonna build to that, but
Jeff,
punchline.
no spoilers.
No spoilers.
Okay, so
for all epsilon bigger than 0.
Greater than or equal to 0, or equal to 0, or just greater than 0.
Just 0, bigger than 0. There exists an n.
Okay. There exists. Which I think is. Do you guys write it like this? There exists. Is that how you write it?
Backwards, capital E.
Like that? Oh, this.
Backwards, capital E. There you go.
Got it. Okay. There exists.
And then by the way, for all is an upside down A. So just like flip it upside down.
Okay, like this. See, now we're speaking a different language now. This is a different language I don't understand yet. All right.
That's the for all. So if you want to replace for all, you may.
Okay. Wait. I see. Yeah. Okay.
Yeah.
Here, let's put the translation so people can, because I think
Jeff is going so fast here. I was getting there.
Jeff,
Come
dude,
on.
Jeff, have you heard of foreplay, or is that why your ex-wife was you, dude? What?
Bro.
All right, for all. This is for all. This, whatever, we know that. Okay, and then this is there exists. Okay, there exists. And then what's the other part of it?
Okay, there exists. Jeff gave it away, such that
okay. I'm not reading Jeff.
Such that n and m bigger than n. So lowercase n, lowercase m, bigger than n.
N times m, or is it n comma m?
Just they're separate. Yeah, they're separate.
Okay, separate.
Bigger than n.
Yes. Oh, bigger than m. N and m bigger than m. Oh, okay.
N, capital N.
Capital N. Okay, capital N. Sorry. There you
go. So here, okay, I'm gonna give you.
So what does this all mean? Yeah, give me a little bit of the spiel.
Let me finish the formal definition, and then we'll, that implies.
Okay.
So go ahead and write like a little arrow.
Like this.
We'll finish the definition, and then I'll tell you what it means. Implies an, the absolute value of an minus am with a subscript.
Yep.
So an minus am, just the absolute value, is less than epsilon.
Oh, this seems like some epsilon delta like tomfoolery.
That's a norm you did, but that's it's okay.
Yes, I did magnitude. Sorry, absolute value. There you go.
Okay. So basically what this means is if I go far enough in my sequence, I can always find a point past which all the terms are as close as I want them to be.
Oh, okay.
Okay, so I should be able to pick a point. There's always a point given. I can pick any 2 points past that point. That all possible pairs are with. There's going to be a possible pair that is within epsilon or as close as I want to be. Okay.
I see. Okay.
So here's the thing. Let's just plot out this sequence. If you start plotting the points in the sequence, the first term is going to be
just one.
Let's see here. Just one, right?
Oh, well, no, it would be 0, right? Because negative 1 to the 0 is 1,
right, yes.
1 minus 1 is 0?
Yeah. Yep. So 0, and then n equals 1, then we get up to 2.
Got it.
And then we go back to 1. Sorry, 2. Back to 0. Go back to 0.
Got it.
So square, right? And then we do n equals 3 as 2.
And it's 0.
There you go.
Or sorry, no, 2. Yes,
2,
yes. Got it. Okay, so it just keeps bouncing. It's bouncing.
Right?
Okay.
So can I get as close as I want to any particular number? The answer is no. Between any pair. The answer is no. So therefore, this is not a Cauchy sequence.
Because I could say, for instance, for epsilon equal to 1, this fails, right? There's no way for me to pick 2 numbers.
That's correct.
Wait, do N and M have to be sequential? Do they have to be consecutive?
They don't have to be. Well, they could be for any N and M, right? So that there needs to be there exists an N. So I didn't quite finish this definition. I just realized there exists an N such that so in between. I'm putting this my cursor on here. You can't see, but on your little video. But right after there exists an N.
There exists an N. Okay, one second. Let's move this over.
Put a little caret there. That's fine.
That's it.
This is hard to navigate. By the way, Chad.
Dude,
if you think this is easy, you get on here and you try to do it. It is hard. Okay?
You go get Zach a stylus. Get Zach a stylus.
Y'all want to buy me a stylus? You can.
I will buy you a stylus, dude. I have multiple. I'll send you one. All right. There exists a big N. Sorry, what is it?
A big N. Such
Yes.
that.
Such. Wait, which one is such that again?
That's the backwards lowercase e. Like it's
no.
It's that one you were trying to draw earlier, right?
This one. This one.
Yeah.
Okay.
There it is. Yes, such that for all m bigger than n. So for all.
So we got to put another for all, dude. I feel like I'm speaking a new language here.
Yep.
This is really fun. Okay, this is for all.
For all. Yep. This is true, and that's the key thing is that it has to be for all of them. So if I can find one counterexample, which you did, you said I found a pair that isn't as close as I want.
Yeah.
Then yeah.
I see. And then this is the counterexample, like proof by counterexample.
Yeah. Right. So I can say, oh well, epsilon does. So let's just pick. Yeah. For epsilon equals 1, pick any 2 consecutive entries. They're going to be 2 apart.
They're always going to be 2. Or 0. Right? Because technically this one and this one is 0.
For all possible pairs. So if I pick some n, right? If I pick an n, past that n, there's a possibility I could get 0, but there's a possibility I can get 2 as my difference. And so it's not uniform, right? Like I don't have this like uniform bound for all possible pairs. I only have the one. I can only have like half my pairs can be less than this epsilon equal 1.
Then less than this. I got you. Oh, I see. Okay. I got you. You needed. Yes. Got you. Very cool. Oh wow. JC learned something new too. He didn't know that this meant such that.
Yeah, it's such that. Yeah, that's it. Different books. The abbreviation ST is fine.
Is there like a math proof dictionary or something, dude? What are we looking for? Like
there is. Let me get one out for you.
Yeah. I'm wondering if there's like just like a translation thing for this. You know, like
so
I would never know all these things.
Yeah, this is probably way more than you need. But let's go over here to.
What's up, Millie?
You can check out.
Millie, is this your question, by the way, Millie? I think this is yours. Which one is this?
You have the sets. That's usually so. Mouse. That's for the. That's for sets. The little slash when you write a set.
Oh, it is yours, Millie. Okay, very cool.
Go down to. Down to the logic section.
This one?
Basic logic, yeah.
Okay. Basic logic.
What I just sent you.
Oh, what you sent me. Oh, sorry. This is what Poison sent me.
That works too. Poison sent that as well. Go down to the logic section. The basic logic. Look on the side. You're almost there.
Oh, okay.
You have a not sign, a wedge.
Yes.
Turned A. There's the one I showed you.
Turned A, universal quantification, logical. Dude, this is a problem with. Dude, stop.
Look between there. It says where it says for all. In between.
This is the information. This is like I'm going to WebMD. I'm like I have a headache, and it's like you could have cancer. You could be dying of lupus, and then it's like you just need to take some Tylenol. Like I needed the thing in the middle.
Yeah. I mean, Wikipedia is not the best, but you'll see the exclamation point after the backwards E sometimes for unique.
Oh, there exists exactly one. Oh, very cool.
So some of these can be useful.
Millie says they study analysis. That's really cool, Millie.
Good job. Analysis. This is definitely an analysis question. The question you about Cauchy sequences.
Yeah. Okay. Did this one make sense to you, Millie? Did we explain it to you pretty well here? I'm just wondering. Yeah, she's in the, or she or he, I don't know, is in the our Discord chat.
Poisoned. We're not gonna go into that right now. Not now.
Teach Gold what the negation for all is. Yeah, it makes sense. Sweet.
Not now.
Jeff, happy birthday, dude. Happy birthday, Jeff. Another Jeff. Okay, cool, nice. All right, so this was Millie's. Let's do the other one from Millie. Millie had another analysis question. I think it'd be fun.
We'll see.
I'm enjoying. I'm learning about this. I'm learning alongside Professor Zach here. Let's see. This one was. Let me make sure I got the right one. That was 8. Let's move.
Is it Millie Vanilli? Oh no.
Is it Millie Vanilli? Where's Millie Vanilli from?
That's a. I want to say isn't that a musical artist? I think
Liza Minnelli. Liza Minnelli's a musical artist, right? Or is she an actress or something? blame it on the rain, dude. What?
Blame it on the snow. It's snow around here.
Oh, blame it. Yeah. Do you guys have a lot of snow up there? Probably, yeah.
We do. We're up. Let's see. We got snow on Sunday.
My sister's in Tahoe, and she says they still haven't opened the ski slopes because they're just not getting any snow up there.
I don't think we've opened ours, to be honest.
Oh yeah, which is crazy. It's December.
It's crazy.
Like,
I was
what?
gonna say December 2nd. We're still not open. We need snow. We need like White Christmas. We need the movie, the ending, the big snowfall that comes.
Maybe
right?
maybe the ghost of math past with Scrooge here will like bring the snow tomorrow for you guys.
Well, may the Navier-Stokes equation be ever in your favor.
Yes, may the Navier. Oh my God.
I'm an applied mathematician. I gotta show some love to the Navier-Stokes.
You do, yeah. There is the Navier-Stokes is our thing. We claim Navier-Stokes. You guys can claim Epsilon Delta. Fluids are scary. Just like me, what?
Let's go ahead and continue. AN plus BN I is a complex sequence converging to A plus BI. Cool. Then the real sequence, AN plus BN converges to A plus B. I mean, are we supposed to prove this?
Are we supposed to prove this, Millie?
I assume so. I mean, literally just divide, like, I feel, I'm not sure what they want us to do. I feel like this is sort of like a, what do they want me to say? Do they want me to say that limits are... Okay. I assume it's a prove.
Eveneon says, wasn't the Navier-Stokes equation pretty much disproved to work under certain conditions with high viscosity? Probably.
I mean, it's not been solved explicitly.
Yeah, isn't it one of the Millennium Prizes?
It's
a Millennium Prize.
It's one of the Millennium Prizes.
You get a ton of money if you solve it.
Yeah, if you can solve it in all cases. People have solved it, but like solved it in specific cases, not like in the general case. I think the prize is for the general solution.
The unifying theory. Okay, Millie just says it needs to be proved. Okay.
Okay, prove it. So, great.
Fucking prove it.
Well, guess what? I'm going to do it my way.
Yes, let's do it your way.
Since AN plus BNI converges to A plus BI, that means... I feel... See, it's hard because I don't know what I can assume. But that would mean that because of the way convergence works, you can split up the two parts. You can say AN converges to A, and BN converges, or BNI converges to BI.
Gotcha, okay.
You can say that because of linearity of limits, essentially. Because you have a convergent sequence, the fact that this is a convergent sequence tells you that you can split these up, right?
Yeah, it is.
Your limit's finite, basically.
I think you need to subtract and take the absolute value, Zach. No fair linearity, use norms. Anch says A plus IB is less than epsilon? Wait, what's this going on? Sorry, Anch, let me see in your chat.
A plus IB is less... See, okay. Navigating this... see, I have to use my chalkboard. This is where I would use the
or a stylus.
Take over. Don't. I'm using linearity because I can, Jeff. I'm also trying to get through as many questions as possible.
Yeah.
There exists an... You could do it that... Okay, so Ansha, you're not wrong. You're not wrong, and you could use the triangle inequality to show it that way. I see what you're trying to do, and you basically would use what's called the triangle inequality to do it, if you wanted to do it from definition. But I'm using linearity, and then I just divide by I. Like, that would be the cheater, too bad.
cheater, pumpkin eater.
Distance become because you have the sum of two convergent sequences still converges, right? So the idea here is because I know that this is a limit law. We know this from limit laws. The limit of a sequence approaching M and another sequence approaching L, then the sum of those two sequences becomes M plus L. That's just how limits work, as long as you have convergent sequences. If you have divergent sequences, this is completely off, and no, you can't do that.
Are you dividing by I or just multiplying by negative I? We'll never know.
I know the hold on. So Jeff's arguing. You know that it converges to A plus BI. I guess that's true. Like you're right. Let's do it the long way.
Okay, let's do it the long way.
Fine.
I'm down.
Let's
Someone
do it
said
the long way.
triangle inequality. That's what Millie said.
Yeah, I know, and I can do it by the triangle inequality, but let's do it that way. It's fine.
Okay. All right. How do we do it?
So what you know so by definition of convergence, you know that an, this is what was suggested, an plus bni.
So an plus bni. Yep.
Right. Minus the quantity a plus bi.
Yeah.
So that quantity. Take the absolute value of all of that is less than epsilon. Right? Epsilon. For all epsilon bigger than 0.
Ooh, let's see if I remember for all. Let me see. Okay.
For all, yeah,
for all epsilon is bigger than 0. Is that right?
Yep.
Oh, I did it.
And there exists an n, right? There's gonna exist some n, so we should write that down as well.
There exists
a capital
some
N.
Capital N.
No, that's
oh, we should put it at the beginning. Yeah, okay. There exists some n. Wait, no. Fuck.
Capital. You gotta do. This is hard.
Is this it?
This is hard to get right. I one of the things I learned. No, you have. Oh, gosh. This is pretty funny from my perspective. So you do by definition of convergence for all epsilon bigger. Let's just write it in this order. For all epsilon bigger than 0, there exists an n.
Okay, for all epsilon bigger. Okay, gotcha. Okay, gotcha.
So if you have it like almost there, it's just backwards.
I got you. It's for all fuck. Let's move this. For all epsilon greater than 0, there exists an n such that yes.
That's where this. There you go. That's that.
And then does all this come over here?
Statement. Yep.
Got it. Wow, dude, I did it, dude.
Before
yes.
the absolute value thing. There you go.
There we go.
Okay.
Dude,
now,
this is like Chinese, dude. Just like what am I writing here?
Okay.
I get it though.
So,
okay.
What you're gonna do is now we're just gonna strategically use the commutative law. We're gonna say, all right, I can say break this up to an minus a, and then plus bni minus bi.
Okay. I see.
Okay?
So we're gonna
just rearrange. That's what the chat wants me to do it that way. So
bni minus bi is that what we want. Look how they massacred my set notation. Look how they massacred my boy.
Yeah, I know the n bigger than n. I'm not gonna make a big deal out of it. We got this far, Jeff. I'm actually pretty happy. we should put an n bigger than n, yes, but just let's go with this. Okay. So this now, do you know the triangle inequality?
I know that the sum of two sides has to be bigger than the third side.
That's exactly what we're gonna write down. So over to the side, maybe in a different color, write the following.
Okay.
Right? The magnitude of a plus b. So just like have a little thought.
Has to be greater than a or b, right?
Other way. The is less than the sum of the two separately.
Got you. Do I put magnitudes around these as well?
Magnitudes around them, yes.
Got you. Okay.
Okay. Now here's the thing. I'm going to use this property to my advantage. I'm going to say, it's less than or equal to. I can now take that first half, and I can take the second half, and split it into those. I can break it up the thing using the triangle inequality into two absolute values. Can you see it?
Oh, I think you. So you're saying an minus a plus bni minus bi, and this has to be greater than equal to this now.
Correct. Yes.
Okay.
Now,
move it over.
Because. Okay, so you can do that now.
Good.
Cool.
Good. Okay. Cool.
We know that's true. Now I know that for some n, since I know that n is bigger than n, like there's going to be this, there's this point at which an, how do I want to say this? I got to transfer what I'm thinking to you. So this is pretty hard. So what you want to do is you make the an minus a. That's ultimately what it means for an to converge to a, right?
Okay.
In order for that to be true, I have to be able to find an epsilon such that that is true. And similarly, I need the same for bni minus bi, right? So I know that there's going to be some point, since I know the whole sequence converges to what it should, there's going to be some point past that n that we chose, where an minus a is less than some epsilon, maybe a different epsilon, right?
Okay.
And
that's just greater than zero. Epsilon just has to be greater than zero somewhere.
Right. But here's what I'm going to do. I'm going to pull a little trick. Because it has to be bigger than any epsilon, I can always find a smaller epsilon than any given epsilon, right?
Okay.
So if I have an epsilon, I can always find a number between 0 and epsilon that exists.
That's smaller than epsilon.
That's smaller than epsilon, but bigger than 0.
Okay.
Okay. So what I'm going to do is I'm going to say there's going to be some point. I know this exists because of convergence. There's going to be some number that if I go from that point on in the sequence, it's less than epsilon times a half.
Oh,
right?
Okay. Yeah.
I could do this with a third. I could do this with a fourth.
You can do it, yeah.
I'm just going to pick, I can pick
multiple.
anything I want. But I'm going to pick a half just because of convenience.
Okay.
Okay? So pick a half.
I think are we gonna pick a half because we're gonna like square some shit and it's gonna like turn into like 2 whatever?
This is fun.
Jeff says, yeah, dude. Jeff says you're more funny than Penn and Zach. What does that even mean, dude?
This is. I mean,
he's shaming Penn, dude. Penn's gonna come out of hiding now. Penn's gonna join the fun. Penn doesn't want to be left out.
I hope you're having fun with this, Jeff. Just for my, I hope you're having fun at my expense, which is totally fine.
Yes.
So epsilon over 2. So this thing, there's going to be some n out there, and we're just going to call it n1, right? Capital N1. So there's some capital N1 out there that exists that's bigger than n, where I can find convergence to epsilon over 2.
Okay.
Right?
There
Capital
exists
N, bigger than n.
Bigger than capital N.
Yep.
Oh, N1 bigger than capital N. Capital N1 bigger than capital N.
Yeah.
Okay, and then I say such that epsilon is epsilon 1.
An minus a is less than epsilon over 2.
Got you. Okay. We'll just say
magnitude is less than epsilon over 2, and it needs to be. Yeah, there's a magnitude. Good. Same thing with bn, but it could be a different number, right? It could be past at a different point.
Okay.
But we know it exists somewhere.
So some n2 greater than n?
Yeah, that's right.
Such that bn minus b is less than...
Or
bni. Okay.
We need the I in there.
Got it. Is less than epsilon over 2.
Yep. So, here's what I'm going to do. The n I'm going to choose is going to be the bigger of the 2. The reason for this is because if I have if I can get with an epsilon over 2 in term 100 and on the first sequence, and I can get with an epsilon over 2 on a term 1000 in the second sequence, if I'm at term 1000, I've already met both criteria.
Gotcha.
Pick the bigger of the 2 to guarantee that I'm far enough in the sequence that both criteria are satisfied.
I see. Okay.
See what I'm saying?
I see. Yeah, because if we've already gotten all the way out to like n equals whatever 1000, then n equals 100 must have worked as. Wait, no. If it works at n equals 100, then it would have worked at n equals 1000. I think is what we're saying, right?
I think you have that back. Hold on.
I have that backwards.
If I'm at 1000, I think you have it backwards. If I'm at 1000, if I pick 1000, you might have said it right. You being at 100, every term past 100 is going to work. So if I pick 1000, that's fine.
Yes.
I think you had it right. So
Got it. You're just being extra safe. You're being super safe.
I'm being safe. So I'm going to take the maximum of N1 and N2 and choose that as my eventual N.
Max N1 and N2.
So when I write my proof, if I were writing this formally, which we're not, we're being very sketchy here, and I think Millie needs to go and be a little more formal when you do this. But the idea is we're going to choose the maximum of those two, and then that guarantees that I can meet the requirement of epsilon over 2 for both. Then when I add the 2 epsilons over 2, I get epsilon as my final thing, and then that proves what I want.
Oh, this is super fucking cool. Oh, I see what you're saying. Okay, so you say like pick some, what, like N3 or what?
Pick N3. So pick N. Ultimately, this is like all scratch work that I was doing ahead of time. So I want to pick some N that's going to be the maximum of N1 and N2.
Okay.
The maximum, and I want it to be the max because it could be bigger, I guess, but the max is good enough.
Good.
There you go. And then we just run this computation. Then we can say that AN minus A is less than epsilon over 2, and BN I minus BI is less than epsilon over 2.
But this is now capital N, right? So A capital N minus A is less than epsilon over 2. And then I'm just going to add them together?
Yep.
Oh, fuck. That's cool.
And added together, that's epsilon, which is bigger than what we wanted.
Yeah. Oh, wow. Okay. So then you add them.
Right, googly moogly. I did not do a great job of like saying all of that. I didn't write it all formally. This is not how you like. I've made some like technical blunders here, but in the interest of learning, I think you've got the basic idea.
I think I've got it. Yeah, dude, this is epsilon delta on fucking steroids, dude.
This isn't even that bad. Like this isn't even the crazy stuff yet.
Okay, equals to epsilon. Okay.
Which
and
is
so
equal to epsilon.
because this is less than epsilon, this must be less than that, and so by the definition, so what we've proved convergence then, I guess, or
yeah, you've proved convergence, yeah. So now each one individually converges.
So convergence is proved. Okay.
Yeah.
Reverse triangle.
Yeah. You've shown individual convergence, yeah, like Jeff said.
So individual convergence. Okay, cool.
Yeah. That's the basic idea. Like I said, I don't think the way you've written it right now, I would not give that 10 out of 10. But
would I pass? Would I pass a real analysis class with this?
I think I'd give you like a passing, like a 6 mark. I think you understand the idea, but there's some cleaning up you'd need to do.
Yeah.
To make it like a 10, but I think you've got the idea.
I think we got the concept. Joseph was asking if this is faulty. Let me see what Joseph's doing.
If somebody wants to go write it out formally, that would be helpful.
That would be great. Yeah, if you want to go write it out, please.
If you want to go write it out. So the Joseph, what I was doing is what I was trying to say earlier. This is like split it up into parts, but Jeff says I was cheating. So I was, and people in chat wanted me to do it the other way, so I did it the other way.
So this is this is like the cheating way to do it.
Yeah, and Jeff brings up some interesting counter examples that you might want to consider if you do it this way. Because you have convergence, you should be fine doing it this way. But I think that's not the intent. I think the intent is to use the definition. That's what Millie really needed. So
yeah,
I don't want to spend too much more time on any one question.
No, I thought it was good. It was good. I learned a lot. That was really cool. I learned so much with the lingo and stuff, and yeah, the triangle inequality.
Yeah.
This is cool.
Yeah, 1 to I are orthogonal, Jeff. Yeah, exactly. It's fine.
Yeah.
But if I were grading this for a real, like a theory-based real analysis class, I'd probably, somebody said 5 out of 10 in chat. That's pretty
5 out of 10?
5 or 6.
What?
5 out of 6. 5 or 6.
Bro,
I
would fucking quit math, dude, if that was a 5 out of 10.
Honestly, though, this is why it depends on your professor. I probably would give it a little bit better score than maybe. I know some others who would probably give it like a 3 or even a 0, depending on how you wrote it.
Wow.
I've had some hard roasts in my life, and there was a time where I even had most everything correct on a qualifying exam, and I got a 0 on the problem because the person was like, "You didn't even." But another person gave me like a 5 or something or a 3, and I was like, "What the heck?" Was partial credit so weird?
I'm super generous with partial credit. Literally, like I tell my students in my classes, if you write something down, I'll give you half. As long as it like looks semi-close to what it should be, you get half.
Anch is right. Like there are professors out there that would give it a 3. Like that probably wouldn't have been a very good score, but I know professors who would probably give it a 7 or an 8 even. Like I would probably give it a 6 if it were me, but it was pretty okay. You got the idea, but maybe just some technical details need help. That's all.
Nice. Okay, good. Cool, Millie. Thanks,
Cool.
Millie, for the question. I appreciate that. It was fun.
Thank you, Millie.
He called some students stupid in the front of class. That's terrible.
It's not. Yeah, don't.
That's not. Don't do that. Don't call kids stupid.
Don't do that to people. It's not.
Jeff. Yeah. Let's see. Someone else. Well, see, we have a bunch of stuff here. IDK, you said you had a question because you have a test tomorrow. What's your question, dog? Like you said something with viscosity. I can't speak this language. What is this?
Jeff has claimed me first.
Okay, Jeff has claimed me first. Okay, we have to do Jeff.
Jeff has claimed me first. We have to do Jeff. Did you submit your? I saw your spherical geometry question.
Jesus Christ! What the fuck is this, Jeff, dude?
Surprise, motherfucker.
Dude, you guys see this, dude? What did Jeff just submit to us, dude? What the hell, Jeff?
Oh my gosh, no.
Jeff. Oh man. Oh Jeff. Oh Jeff.
Look at the name of the file.
Dr. Gold sucks.txt. Dude, Jeff, you're too funny, dude. He does suck. Oh man. I do suck at certain things. IDK, use the website. Use the website, dude. There's a website right there. It's literally called actualofficehours.com. Yeah, you guys got it. Cool question, Jeff, by the way. But I don't even know what this even means. Who's the other guys with us? We have Zach with us. Yeah, here, let me, because a lot of people don't.
I wish you could see my face, but I can't.
Zach's great. Zach's on Linux.
You just blame Tux the Penguin. Just like, you know what? That's all you have to do.
You have gotten your webcam to work though, because you've talked with.
I stream all the time. Like I do.
What the fuck? I don't know. Something's wrong with it's my Discord then. Sorry.
I'll do one. I have one last thing I'd like to try.
Yes. What do you want to try?
Do one more.
All right, try one more thing. I keep just saying
we're gonna just put on my camera and turn off OBS.
Oh yeah, do that.
Okay. Are you getting something?
No. It still hangs. It still hangs. She's a hanging person.
Yes.
She.
Okay. No worries. Let's just keep going.
Yeah, because I think we had that before. I think I was trying to video chat you once, and like I couldn't see your face either. I don't know. It's just they don't want us to see. I mean, worst comes to worst, we could use Google Hangout or something. But then there's like latency and stuff.
Yeah, I mean we could go to a private DM, but I don't know if that'll.
Oh, but then no one here. Yeah, but I can't have multiple calls open. I think. Yeah.
Yeah.
Dr. Gold is better looking. Stop that, dude. Dude, Zach has way better tie game than me. He's got the best tie game.
I got my tie on. You can't see my Christmas tie, but it's right there.
Oh, he's got the Christmas tie. But yeah, if you want to figure out who Zach is, by the way, if you're watching us now on the stream, if you go to the website, actualofficehours.com, and then click on the streaming schedule, you will see the calendar of all the events we have. And so Zach is right here, E2iPie, and so that's his Twitch handle right there. So make sure, go give him a follow on Twitch. He does have a PhD in math. And he streams a lot too. He's awesome. What's up, Becky?
You're too kind.
Prove that prime p mod 4 equals 1 can be written as the sum of two squares. Wait, what is that, Anj? What?
Oh gosh. Is that a chat message? Prove that any prime p mod 4. Oh, you could, that's not too bad, but you got to put it in the Discord.
Yeah, put it through
the.
Put the screenshot in. Put it in the system so we have it.
Yeah. I don't think it's horrible. I probably could do it if I thought about it.
Anj says he's also going for his PhD in math. Oh wow, congrats, dude.
That's awesome. Yeah.
Yeah. Zach graduated last year, right?
Yeah, I did. I didn't do it in number theory, to be fair, but I can probably handle that one. Maybe.
Dude, Jesus, what the hell is this?
What the heck?
What the fuck is this?
Yo. Oh, this is center of mass. This is a center of mass question.
Oh, okay. You want to try this one? Do you think you can do this?
Let's see here. Let's continuous function f for an arbitrary a and b. Define the coordinates of the center of mass with the following way. This is reasonable. Find the function f of x in the case where g of x a b equals a over p plus 1.
Oh, it's like reverse integrals. Are we gonna like double derive or something?
Oh, interesting. Oh, how do we want to do that?
Is this math? I mean, I think of physics when I think center of mass.
So, like, this is a math question, legit.
It is a math question, though. This is a math question.
It is a math question. I'm trying to think of how I would do this, though. Would we do? Because this is the formula for the center of mass. Like, it is legit. Like,
this is a legit physics thing. I know about this.
Right. And like these are the right equations. It's the because you take basically the bottom one is the in this case volume, isn't it?
Wait, isn't x equal to like a over 2 in terms of dx, right? Isn't that what do you get that? Because you get x squared over 2.
No. You can't do that here because
it's not symmetric. Because f is a function of x and y. Oh, I see.
Yeah. Yeah, you're thinking of r over 2 maybe with polar. No, this is different.
Yeah, it's a little bit different.
I want. Okay.
Let's think about it. I'm going to pull this in. We're going to try to do this question. Joppa stock.
We're going to try it. Yeah, I think the strat here is maybe to multiply the denominator in because.
Well, this says p, and these are constants.
That's right.
Right, and this is also a constant.
Right. Find the function f of x, y.
It says just substitute. Just substitute.
Yeah, I think this is the way. I was thinking multiply the denominators, right? You could. So let gx be a over p plus 1, right?
Okay.
Right.
Okay.
So
equals a over p plus 1.
That's right. So
okay.
So a over p plus 1. You have your denominator integral. Your denominator integral, you could multiply that over, right? So you could take a over p plus 1, multiply it by the double integral in the denominator. We should probably call that something. Maybe like v for volume. That is the volume of your surface. So that.
Am I going to multiply? Sorry, this is. You get this. Let me grab this. Sorry.
Yeah, it's probably a probability thing, Jeff.
So it's this, right? And then over p plus 1.
Yeah. That's right.
If I can hook Zach or Golden to green beans, I'll start another hour-long digression.
Right? But I think the way here is to take. Then I can do the same with the other thing.
Okay. Do the same with the other one. So let's take this one.
Try and get some equality going.
We love equality. That. And then this is equal to b over q plus 1.
Yeah. You had to save these questions for me, didn't you?
Yeah, well, I am going through the queue, and I'm specifically finding really for those that are watching.
You got the hard ones for me.
I'm specifically going through the queue because we only have Zach for a couple hours. I'm finding the hardest math questions for Zach to help us out with. So if you have simple ones, don't worry. We will get to them later. I'm prioritizing using Zach's brain right now to hit the hard ones.
I was gonna do maybe like a double integral just for fun, right? Like I thought this was gonna be fun. Dude,
text me. We're stress testing you. Dude.
Oh, let's try and see if we can teach Golden analysis. Can we do hard multivariable? Like, come on.
Yes,
come on, bro.
All right, we'll give you an easy one after this. We'll give you an easy one. IDK, what is your name? Dom in the queue. IDK, let me know, because you said you submitted a question. All right, so let's we're gonna cross multiply, right? Okay, well, at least one of those. Okay, so then you get. Okay, so then this is equal to the. Oh, no, that's my LinkedIn. What the fuck's my LinkedIn coming up? There you
go. Quantum has an interesting thought.
X to the P? What the fuck? Quantum, what are you saying, Doc? Leco, what? Excuse me?
No, that might be a good idea.
Oh. Alright, IDK, I see it.
Before I get to that,
this is B over Q plus 1, right?
Yeah.
Okay.
So my thought here is, what if?
Oh wait, these are the same thing. Are these the same thing?
That's right. So almost. Your x and y are different. in the integrand, right? You have
okay.
xf and yf. But what we could do is multiply by the reciprocal and then set the two things equal to each other. That might be useful. I don't know. I like what Quantum's saying though. X to the p times f of y. If you take the integral with respect to x, that's your x to the p plus 1 over p plus 1. That is reasonable. Except.
I see what he's saying. He's saying
right,
that
like, so
you're guessing the solution for f of x.
Yeah, like Quantum's got this like, and then you have some function of y that we don't know. But what if we just said x to the p was our function f?
Okay.
Issue with that, I think it would have to be like x to the p minus 1.
It would have to be x to the p minus 1 because then this is
you'd have
being
to
multiplied by x to the 1. Yeah.
That's right. And then you get x to the p, which when you take the integral would give you x to the p plus 1.
Plus 1.
Over x to the p. Or p plus 1.
No, over p plus 1. Okay.
But if we were...
No, wait. No. But that has to be with respect to dy. It has to be y. The first integral is in terms of y, right?
Correct. But what Quantum's saying is if we had some function of y that was just a function of what we need to figure out what that function of y is.
Oh, in order to get rid of the x and then just pull out the a.
Yeah. The tricky thing here, though, is we need to find the same function that has some q in it too. Right?
Yeah.
We're gonna need some q in there.
But then q does something. It's q plus 1 when it has a y in it. Sorry.
Right.
Oh fuck.
So,
man.
So what I'm thinking is it's got to be.
I think I see what you're saying. It's because like if you integrate the y, you need to get a q plus 1, and you don't get the p plus 1. If you integrate the x, you need to get the p plus 1, but you don't get the q plus 1. So then the other thing, part of the integrand has to like cancel it out somehow.
Mm-hmm.
Oh, that's tough. Okay, one sec. I'm gonna go to the bathroom real quick because it's been like 5 hours.
Go ahead.
But
yeah, no,
I'll let
chat,
you guys keep stewing on this, and I'll be right back.
I'm stewing on it. I'm really sort of angry that I can't see the solution. Dagnabbit. Okay, hold on, chat. I'm gonna pull out some paper. You can't see me pulling out my little index card, but I'm gonna try to scribble something down. Because I want to cancel out. The x to the p is a good idea, like what Quantum was saying. So if we say some f of x y is x to the p minus 1, maybe it's something like y to the q minus 1 or something. I wonder. Because then when you multiply by x, oh wait, that might be it. Because if you take the integral multiplying by x, then you get a plus 1 in the end. But the y term will automatically increase, and when you divide things out, that y part cancels out. This is the way. So I think our f would be use a dagger here. I don't know. I don't think so. Here's my suggestion, chat, for when Gold comes back. Gold went to the bathroom. Here's this. That's my guess. And if you take the integral, it should work out. Multiplying by x, that would work. I think we're going to follow through with this when Gold gets back. I'm fairly confident this will work. And there would be an extra a term because of the increase in power. No, this is the way. Quantum, you're onto something. Dagger form of epsilon should be equivalent to f of y. Completely clutch to him not. Yeah, he's still. Yeah. You're so. I think this is it. I'm gonna try to write out the solution before Gold gets. We had a common whiteboard, but alas, we do not. Let's see. So you're gonna get b to the p over p, a to the q, b plus 1 rather, a to the q over q, and then the denominator you'd get b to the p over p, and a to the q over q. That's so close. These divide out, and then we have an extra factor of p. So we just divide by b? We divide by p or something like that? Maybe we have to divide by p. 1 over p, maybe? Is this complicated? I don't think it's rational. This is definitely real analysis for sure. You sent another one, IDK. Thank you. Okay, my updated thing. It's going to be 1 over p times x to the p minus 1 times y to the p minus 1. Sorry, it's q. That's q. I'm going to fix it. Oh, crap. Q minus 1. There you go. I think that's what we need. No, that was a really good idea, Quantum. I think this will work. Let's see what Gold thinks when it gets back. How are you all doing? Anyone have any? I don't know. What have you all been up to? You're hearing this ethereal voice. This is Zach, by the way. I am helping out Dr. Gold during this 24-hour marathon, keeping the thing going, and I'm literally nothing to show. Sorry, I was reading Discord. Yeah, how's it going? Ethereal voice. Gold's got food. I have a big test tomorrow. Gotcha.
Yeah, I haven't eaten in like 6 hours.
So I've gotten it. I typed it in the chat. I think I got it.
Wow. Nice. Okay.
Yeah, what food do you have? I want to know.
I went to like Kroger yesterday. I just bought like a bunch of like lunch meat and like chips. I was like, because I need something like quick. I can just like throw in like a tortilla and eat.
That's awesome.
All right, let's see.
Okay, so I've got a suggestion, and I think it'll work. I'm satisfied with it.
Okay.
So we need to do 3 integrals. Okay.
Okay.
So take this function f of x y, the 1 over p times x to the p minus 1 times y to the q minus 1.
Okay, so 1 over. One second, let me see your chat. 1 over p times x to the p minus 1.
That's right. Hey,
and then.
Hey, what's up?
Y to the q minus 1. What's up, 1K?
Good 1K. Job. I was gonna say 1K. I'm not sure how to abbreviate that one. So 1K it is.
There you go. Okay, cool. Right. Okay, so that's that, right?
So let's just take the double integral. Before we do anything, take the double integral from a to b, 0 to a and 0 to b. Just that denominator first. I want to show you what happens and why I'm making this choice.
Okay, and then I'm doing this dy dx, right?
Yes.
Okay, so when I take this first integral with respect to dy, that's going to become y to the q, right? So I'm going to have 1 over p, x to the p minus 1, and then I'm going to have y to the q over q, evaluated from 0 to b, yeah?
That's right.
So, well, that 0's not... Oh, 0's okay, because that just makes it 0.
Yeah, it makes it 0.
So it's 1 over p, x to the p minus 1, b to the q?
That's right.
Okay.
So then you do the same thing.
With dx? Is that what you want me to do next?
You're 0 to a.
Okay.
And then
okay,
we
so
do x to the p, right? You get basically you get a to the p over p.
Oh, okay, okay. Yes, that's x to the p over. Wait, isn't it p squared though? No?
It'll be p squared, yes. I was just taking that one part and saying that the integral with respect, you get a p squared eventually.
So you get a to the p, b to the q over q. Or
you need to make a an adjustment here, but it shouldn't be too much.
b to the q over q.
Over q.
Okay. Yeah.
That's good. And then that's going to be our denominator, right? So when you evaluate the numerators, let's now just multiply by x and multiply by y, and it's the same integral. But the difference is...
you're going to get a p plus 1.
You're going to get a p plus 1, right?
Oh, I see. Oh, that's actually really cool. You just came up with that? You just kind of like engineered it in your head?
Quantum inspired me here. But I think Quantum had a good idea.
Good job, Lecco.
And I might be off by a little bit, but let's just humor me and let's do it this way.
let's do the x one, right? So there's an x.
The same thing.
Yeah.
Yeah.
So that's just gonna give me where's that? It's gonna be the same thing except for dy, but now when I do the integral of x, it's x to the p. So that's gonna become
x to the. It'll be a to the p plus 1.
A to the p plus 1, but then still over p plus 1, right?
Yep.
And then it's b to the q over q.
Which is good, because we want those to divide out.
Yes, I got you. And then if this is with the y one, let's do it with the y. Okay. Oh, I see how there's symmetry to this. It's actually really cool.
Actually, I made I made a mistake. It should be 1 over p plus 1, not p. The constant.
Because at the end of the day, wait. Yeah. No. At the end of the day, we want a p plus 1.
Or is it? Did I forget to multiply? We may need to multiply by something else, but let's play around with the constant just a second, because the constant we need to multiply by is what I'm concerned about. But let's just.
This is a to the p, b to the q plus 1, right?
That's right.
And now this is going to be p, whatever. Let's keep the p separate. So then it's p times p, q plus 1, right?
Yep.
And then this was.
Right, so when you take the reciprocal, when you divide by the reciprocal.
Okay, so I take this, each one of these, and I divide by this, which means I multiply by the inverse.
You end up with an a. The bq over q divide out.
Yeah, here, let's do it.
The p divides out.
This divided by this. Yes, means that.
So close.
It's so close, yeah, because the p goes away, p goes away. The b to the q goes away with the b to the q. Q goes away with the q, and then we're left with
I think we need a p plus 1.
Just an a, right? We just have a because this cancels out with that.
Yeah.
Oh, okay. So now I have a over p plus 1, and then times p. Yeah, I think you just need another. You need p squared.
Yeah.
Right?
That might do it.
I think that does.
Let's verify go check the other one too. We want
to let's go check the other one. Yeah.
Because it should work out consistently.
Yeah. So this one. So let's pretend it's p squared. Yeah. And then we're gonna divide it by.
I think that's gonna be wrong, but.
Oh no! You're okay, Zach.
You're still gonna get a q over q.
P squared, p, p, b to the 1, b, a to the p, a to the p. Yeah, I have a q over q plus 1. Oh shit!
It's so close.
Because I have a. What is it? Sorry, I have b q over q plus 1.
Yeah.
Dang.
So close.
We just need to get rid of that last q.
And then we're done. I don't know, chat. Do you have any thoughts? I have no idea. What else to...
Thank you, Laz.
What else to try?
Okay.
What am I... There's got to be some, like, constant shenanigans. That's what this is. We're just not getting the...
I think we got
So
really
close.
close on this one. This is so close.
Send it to GPT. Don't do that, Jeff. Don't do that.
I'll respect Zach because he's a guest on my stream.
Zach AI isn't good enough.
I would do it myself personally, but Zach is my guest, and I will not disrespect my guests. So I will not throw it
If
to
you want to,
ChatGPT.
you know what? You can do whatever you want.
I'm not going to, dude.
I
I'm
don't,
not going to.
dude, you can do it. You do it all the time anyway. You know I roast GPT anyway.
Yeah, I know.
I end up roasting it when it's wrong. So
Yeah.
you know.
I don't know. It just feels dirty in your presence, Zach. I don't know.
You and your vibe coded apps, you know.
This whole queue is vibe coded. Yeah. Would Quen be okay? What's Quen, dude? Is that a different type of AI?
Gosh. GPT wants to. Oh dear.
Oh no. Okay.
Oh my gosh, you're so close though. I know it's like right around this neighborhood of answers. Like this is an answer that seems close.
Yeah. Because we said 1 minus p squared, x to the p minus 1, q to the p minus 1. The problem is that like if we throw another q in there, it's gonna fuck up the other one though, right? Like if we threw in an extra, I don't know, over q here, right?
I don't know.
We need we need 1 over p squared q.
Yeah.
Right?
Or like 1 over PQ or something like that, or Q over Q plus 1 or something like that. Like there's some kind of combination there, and I'm not sure what you can get.
Sorry, this is y to the sorry, it's y to the q minus 1. What am I doing here? Sorry. DeepSeek is the other one. Wait, because the p squared was great. It took care of this too, right? What happens? What happened if I just made it q squared instead of 1 over p squared? I don't think that would work though, right?
Well, see, that's the thing, is you have to make it work for both.
Yeah. I'm concerned if we fix it for one, we screwed up for the other one, right?
Break it for the other, yeah.
Yeah.
It's like you need a Q over Q plus 1 or P over P plus 1 or something like that. Maybe something that would be. I don't know. I'm gonna have to punt on this one. You can use, if you want.
What am I allowed?
You can use that which must not be named.
Okay, fine.
But if you want to. Good to see you, Quantum.
Here, we'll use John. Yeah, all good. Thanks, Quantum, for coming by, dude. Let's try Gemini. I feel less dirty using Gemini.
All right. Zach AI is not the best.
Oh, it's doing the derivatives. That's fascinating.
Yeah, sure, maybe.
Whoa.
We got an ODE here. Holy crap.
Oh god. Dude, no.
Keep going. Scroll down.
Wow. This is what it thinks.
We did we literally we're so close. It was the powers that need adjustment apparently.
X to the 1 over p minus 1.
Let's try that actually.
Okay. I'm down.
Let's just give it a try, because I think the power will really be 1 minus p over p. And then the other one will be 1 minus q over q.
Okay. 1 second. Let's clear
You
this.
can try it.
Going good, MZs. We're doing a 24-hour stream today. 24 hours. Okay, let me get rid of all this. It was beautiful. There was an attempt.
That was like a reasonably close. Too.
I'm gonna leave this as like a memorial to like what we thought was almost there.
It's a good idea.
Yeah, it was a great idea, honestly. Like the intuition you had there was awesome. Oh, Q ends over my Alibaba. I didn't know that. What's up, Charlie? Got a lot of office hours ahead of you.
Oh.
We do. We do have 18.
Today I learned. Thank you so much, Laz. I appreciate that.
Yeah. Okay. So
when you multiply by x, that... Oh, okay. So it makes 1 over p your new exponent, or 1 over q, right? When you multiply by x or y, that minus 1 goes
okay.
away.
So x to the 1 over p minus 1, y 1 over q minus 1 now becomes x to the 1 over p, right?
That's probably what we needed.
1 over q minus 1. Okay. And then when we integrate that dy. Okay, cool.
You end up with 1 over... That's where you get that p over p plus minus 1 thing. That's what I was talking about. Like, you're going to get...
You get wait. You get y to the 1 over q, right? Because you're adding 1, and then you're dividing by
1 over q. Yep. So you multiply by q. That multiplies by q. But then the denominator becomes 1.
And this becomes a b.
Yep, that becomes a b. And then the new numerator becomes 1 plus 1 over p, which is p plus 1 over p. And that's what I knew there was some kind of thing that I had to engineer that. And I didn't know how to engineer it.
And then this is 1 over q, and then this is 1 over p plus 1, right? The new thing you know?
Yep.
And then this becomes an a, right?
Yep.
Okay, so let's do the other one.
The other one's just going to swap.
Yeah, so that's going to be y to the 1 over p, right?
1 over q. 1
over q, sorry. Yeah, get my p's. Mind your p's and q's.
Bruh. I know, right? You
gotta mind all the fucking things. Okay, so I think I just swap p and q here, right? So I just say this is
That's right.
a to the 1 over p, b to the 1 over q plus 1.
Yep.
And then this is 1 over p, 1 over q plus 1, right?
That's right.
Okay, and then I want to do this one. They all need this one divided by this, right? Or no, divided by the original thing. Divided by this.
So the original one, we didn't calculate the original, but the original is just going to be a to the 1 over p, b to the 1 over p, or 1 over q, and then 1 over p times 1 over q.
Oh, fascinating. Yes. Okay.
And that's going to cause the cancellation we want.
Beautiful.
That's
actually really cool. So this double integral just becomes a to the 1 over p, b to the 1 over q, and then divided by pq, right?
Yeah, that's what we were trying to engineer, and this is.
I see. And then when you multiply that, you get.
So cancel stuff, you're gonna get the.
Right.
You'll get the right thing.
This one will just give you a over. Now here's what I'm curious. Oh yeah, thanks for the follow, Jopstock. Oh, this is Jopstock's question. Yeah. This is 1 over q, 1 over p plus 1, divided by, so then times pq. Does that work? How does that work, by the way?
Yeah, that's right, because you're dividing by the reciprocal.
Right.
So you're dividing by a fraction, which is multiplying by the reciprocal.
Right.
So, you need to, hold it. Hold the phone.
Hold the phone. Might have a problem here. 1 over qp plus 1 over q?
Yeah.
It doesn't look exactly right.
Is that... I thought we were onto something.
I mess up.
Looking at...
Right, this is on the bottom.
Yep.
So PQ comes on the top. This canceled out with this. That's why I just got the A.
That might actually not quite be right, because you have a P and a Q. I thought there was going to be cancellation that happened, but we're... Oh, it's because it's 1 over P and 1 over Q, right? It's not over PQ, it's divided by 1 over P, 1 over Q. So go back to the original, the double integral. You have
right here?
denominator above. Yes, that. So that should be a.
Oh, that's 1 over P, 1 over Q.
That's right. That's right.
Okay, that makes more sense. Yeah, I'm impressed that Gemini solved that. Yeah, pretty impressive, Gemini. I might start switching to Gemini, honestly.
That will do it.
So that's A, and then that PQ is going to go away. Okay, very cool. What's up, Chrono? And then that's 1 plus P, which is what we wanted, right? I'm going to assume the other one's right. Nice, okay.
Yeah.
I'm going to assume the other one's right.
Holy crap. Give me something easy, chat.
Give me something easy, dude. Well, this is actually fun, though. Good question, Joppa Stock. You got very close guessing it.
That was not me though. That was more what's it called? That was
An
more
assist.
quantum.
Yeah.
Or
Leckel. Yeah, Leckel had the assist. Yes, thank you, Leckel, dude.
Give me an easy. Bro's gonna pull out like Lebesgue measures or something. I don't know. I don't want to do any deep measure theory today. Don't deep measure theory.
Dude, we're stress testing Zach. We're stress testing the Zach AI, dude.
You do that every time on my streams, okay?
Yes,
like that's
I do.
Y'all get your opportunities all the time to stress test me.
Go make sure to go follow Zach so you can stress test him. Go stress test him.
This is Giving Tuesday, so I'm doing this for to
charity.
Help you all,
He's doing this for charity.
Yeah,
He's doing
I'm doing
this
for charity. It's for all
charity.
of you.
Yeah. Oh, nice. Okay. Let me see what else is on the queue. Yeah, well, let's give you a little bit of a layup. Let's give you a layup. I know Pana was like yelling, saying he had a homework or something.
Let's do this. Looks like a layup. I can even.
Yeah, let's do this. This is great. Yeah, and we're gonna teach you some physics along the way.
Great.
Actually, kind of related to what we were doing. Cute needs one to be solved by Zach. Okay, we'll send that too. All right. How many grams of iron are required to make a hollow sphere whose inner radius is 15 centimeters and outer radius is 25 centimeters, as in the opposite diagram where the density of iron is equal to that? Wow.
Okay, so we can find volume, right?
Yeah.
Volume equal. Let's see. Density is mass per volume, and we know the density, and we know that we can find the volume, so we can find mass. I can do this.
You can do this. I know you can, Zach.
You do this. So the area. Let's see here. 25. We're going to take 25 squared because that's the area of the whole outside circle.
No.
And
key thing here though. This is a 3D structure. It's a sphere.
Oh, oh crap. Never mind. I was looking at this as like a cylinder. Never mind. We're doing the 25 cubed. So much for layups.
Yeah, this was a layup, dude.
So 25 cubed. 4/3 pi. This is 25 cubed, and then we're gonna do 15 cubed because we need to know the inner sphere.
Mm-hmm.
Just gonna do 25 cubed minus 15 cubed.
I think you still need the 4/3 pi in there. Yeah.
You do. I was just gonna put that all inside the 25.
Oh,
cubed.
I see. Okay.
I'm doing that in my head, but do it that way. It's fine.
What's up, Bing Bong? 4/3 pi, 25 cubed minus 15 cubed. Yep.
Yeah, that's what I was getting at, Jeff. But you do that. Now, difference of cubes says you can make that 10 times. Let's see if I can do it in my head. 10 times.
This is the special math trick. I would just plug this in a calculator, but Zach's got some math.
I was gonna go.
Because isn't this like this is a is this a minus b squared or something?
Well, so you difference of cubes, right? You do a minus b and then a squared. Never mind. Just do it in a calculator.
No, I liked it.
Calculator. You can factor it out. It's fine. It's a difference of cubes question.
It's a difference of cubes. It's okay. It's all right. 4 divided by 3 times pi.
Yeah, I mean, that's what.
I like the difference of squares. The difference of squares was cool.
You can do it that way. It's fine.
I don't think IDK needs to do this. He's probably in like IDK. What grade are you in? You're probably like 8th grade or something. They're not asking you to do difference of cubes.
I mean, so what? 25 cubed is 5 to the 6th.
Yeah.
Right. 5
but then
to
how are you gonna get the 5 with the 3? 15. Sorry, 15.
You factor out 5 cubed out of both of them. You can do that.
Can you?
Yes,
you can factor 5
because-
cubed out of 15. Oh, because it's 5 cubed times 3 cubed.
That's right. Just do it that way. So I know what 5 cubed is. So do 4/3 pi times 5 cubed.
Yeah.
I'm gonna write this on my little index card. 5 cubed. Then you have 5 cubed minus. Laugh all you want. You can make fun of me all I want.
You guys are so funny. We're taking an acetylene torch to like light a match. Light a candle.
It's 125 times 98. And that's going to be 12,500 minus 250, which is
you got it.
12,250. Yeah. I did that
without looking. He did it without looking.
I did it with my little index card. You can see it on.
Okay.
For those of you that can see Discord, you can see my index card. It's got it there. Unfortunately, Gold can't see it, but
I can't see
it's
it.
there.
It's there. We believe it.
There's my index card.
And then you just multiply that by the density and you get the mass. Which is equal to... Mass is equal to 955.
It's gonna
triple
be
5 0.
I may as well finish the job. It's gonna be 49,000 thirds pi. That's the volume.
Yeah.
I'm such a nerd.
But if pi equals 3, it's basically 4.
I mean, you're not wrong.
Here we practice E equals pi equals 3.
Well, yeah. Well, so, you're the one who says you hate engineering.
Yeah, I do hate
come on.
engineering. Yeah.
You're the one making that joke, and you're hating on engineering.
Yeah.
What the heck is that?
All right, nice. We learned about density. It was kind of a softball. It was also fun.
That was fun.
That was Pano 11. Let me post that.
All you who like engineering, like like Dom here, please show your support in chat.
Show your support. I don't think it's a softball. Oh, okay. Yeah, what? I mean, we almost got tripped up with the square versus the sphere, honestly.
That's right. I didn't read the question. That was a read the
Well,
question.
the diagram is tricky, dude. To be honest, that's a tricky diagram. All right,
It's
Pano.
an iron ball. Oh, well played. Well played.
It's an iron ball. What was the other one, Pano? Oh, Jesus. Oh, well, this got a lot harder, dude. Excuse me. What? Pano? What?
Fluid mechanics. Oh my gosh.
Wait, what? How did we go from it, bro? This is something from like the 3rd fucking grade, and then this is like what? How is this the same class? And then we have fluid mechanics. What?
Hold on. All right.
Hold the
Let's
phone,
see
dude.
this.
Hold the phone,
Pressure
dude.
gradients. Oh my gosh. Laminar flow, huh? Annulus. Find the relation between the pressure gradient, the volume flow rate,
Right?
fluid viscosity, and let's see here.
I thought it was funny to do that assignment too.
Advanced fluid dynamics. This is what happens on my channel. Like I get questions that like vary so much.
This is wild.
This is wild. So you get all sorts on for I do these. I do like open. That's what you get for I guess open homework help. It's the price you pay. But it's okay.
Okay. I don't know if I can do this one because I don't know what. I don't know how pressure. This is what? What? Where does
This
this
should
come
probably
from?
take more time than we have.
Yeah.
Because pressure gradient, we need a volume. Like I need.
I need like an equation for like pressure as a function of radius too, right?
Yeah. Let's pass on this one.
We're gonna
I
pass
think it'd
on
be
this one.
better to not. We've also done a lot of just harder questions. Let's go a little.
Yeah.
little
Let's go to something a little easy. Let me do equities. Equity has been waiting for a while. I'm honestly tired for you too. It's a lot. Yeah, dude, that's too much.
Mouse. Just so you know, I have solved it. I have it. So I have a little book here. I was working on it yesterday. I have a solution, and I can share it with you on Discord. I can just take a picture of it. I took the liberty of like writing out a solution.
Which one was Mouse talking about? Cute
It was
poison. This one?
about- This was the. It was from yesterday. Not this one. No. This is the separation.
This looks like a
of
kinematics
variables.
question.
No, it was one from yesterday. There was
Oh,
a
okay.
Fourier series, which isn't so bad, but the I can't get an exact answer because the initial condition was just some random function. So it's the coefficients have to be an integral.
What's up, X-Man? JHNat, what was your question? What did you ask JHNat? Did you put it in the queue? You have singular value decomposition. Is that a math thing?
It is. That's linear algebra. Yep.
Oh yeah, submit it, JHNat. Just what's your username in the queue?
Yeah. The initial condition is f of x mouse, and it's you do essentially the Fourier integral f of x times, I think it's a cosine. I think in this one is it you do sine, I think. Cosine.
It's been a party,
man. Cosine n pi x over L, and then you multiply by 2 over L times the square root of k over lambda squared minus h. I'll put that in Discord for you.
Nice.
After the stream's over, or after I'm done. Not until
the stream is not over.
The stream is not anywhere near over.
JH, I was asking like, when are you guys ending the stream? I was like, yeah,
more.
18. We're ending it in 18 hours. When's the stream ending? All right, let me see this. A figure shown as a right circular cylinder with radius r and a height of h. A second right circular cylinder has a volume 392 times as large. Which of the following could represent the radius in terms of r and the height h in terms of h of the second cylinder?
Right. So.
Oh, I think they're just asking like, how does volume vary, right?
So you have pi r squared h is your area or volume of a cylinder for a right circular cylinder. The second volume is 390 times greater, 92 times greater.
Mm-hmm.
So what you want is if you took the radius, squared it, and multiplied it by the height, then you should get 392. So those coefficients, if you just square 8 squared and multiply by 7, that's
for sure.
So B is out automatically. D is out automatically because those are too big. You would not. You'd square 8.
Yeah,
8,
D is
so
totally
64.
way too big, dude. What? Yeah, 49 squared is huge.
B and D are wrong. So I can tell you that right now. And then just the other question is, where did the 7 go?
Yeah.
So if I square 7, that's 49 times 8 is 392. That's it. Let's see. Whereas 8 squared would be 64, and then multiply by 7. 64 times 7 is, well,
420 something.
640.
68.
6.
Don't say 7. Don't do it. Don't do it. Don't say 670, dude. Don't do it.
670 minus 30. There you go. And then you do 3 of those. Let's see. 192. Subtract 192. You get 400 and it's already too low. 448. So 448. That will be too much actually. 8 squared times 7 is much bigger than 7.
What's up, more or less? Right. All right. So I think we agree with this. Answer C.
C. Yep. That one was reasonable.
Nice. That one was very reasonable. Thank you, Equity. Equity. That was question number 2.
All right.
Let's see what we got next. Let me throw this in. Okay, we're done with that one. JSnat, did you tell us what your username was? Did you put it in? I have to submit it a bit. It's finding eigenvalues of non-square matrices, finding sigma, where sigma is the square root of the lambdas you get, and will be in descending order. I will be back on until 11 p.m. It's just gonna be HNAT. Okay. Maybe submit it sooner than later so that Zach can help me solve it. Because if Zach's not here, I don't know if I can solve it. But Zach can solve it.
I don't know if Penn will be able to help if he's going to be on later.
Yeah, Penn might be on. He said he was fighting the Hydras. That's what he said.
Because I know Penn might know SVD. I'm not sure, but
okay, just submit it HNAP so we can see it later.
Okay, cool.
What did Dom have? Jesus, wait, what's this?
Dom. Okay, what's this? This looks.
What does this look like? What is this?
Okay. Let's see. So
what math
okay,
is
this is actually algebra, probably.
It's due tomorrow too.
Dom,
Dom, is there a specific question you want us to help you with? Like, because there's 3 here. I don't know if we can do all 3, but.
Okay, this isn't too bad. Look at so it's just reading some notation. Go back to 1.
Okay, let's do 1.
You can. So they're trying to scare you, Gold.
I'm always scared.
Basically, these are polynomials.
He says he wants help with the second one, though. Can we do the second one?
Okay, cool. That's fine.
All right, let's go. Let's go.
So
Find
the important thing here is whenever
but
you see
I think we need.
PN
I think we need the information from the first one. No, for this one, maybe.
let's find out.
Let's find out. Okay, and then you can explain to me.
I'm just going to use my screen to look at it because your screen's.
Sorry, I'm going ADHD here. Well,
it's fine. So basically, we're defining sets of polynomials of a certain order, right? So P3 is really all the cubic polynomials. P2 is all the quadratic polynomials, and so on.
Okay.
And then you can determine whether things are functions. So this next part actually is irrelevant to the first part.
Okay.
Okay, so this should be fine. So you know intersection and union, those are definitions. In set notation. You have all the real numbers that are part of X, A and B, or A or B.
So intersection is where they have the same value in their sets, and union is just like a big superset?
Yes, so you're including everything in both sets together.
Okay.
Right? And it doesn't have to be a member of both sets, it just needs to be a member of one. It can be a member of both, but...
I get it. This is kind of like or B. It's like A or B.
Yes. And that's literally what the definition says, right? You have your X and A, or X and B.
Got it.
When you look at that, okay. So you have a function that's an A or B mapping to R.
Okay.
What does it mean to say that Y is in the image of A? Now notice I'm saying image.
Yeah, why are you saying image?
I'm saying that that's the mapping. So like, think of this as domain and range. It's the things, it's the range of A.
Oh, okay. Okay.
So when you see f of A, that's really the range of A. We sometimes call that the image.
Like A maps to f of A.
That's right. So.
Okay, so this is the image.
So if I look at this and say, what does it mean to say that Y is in the intersection of f of A and f of B?
Okay.
So I'll let you answer that one.
Well, yeah, I don't know. I'm trying to think.
What does that mean?
It means out of all of the values for A, that if I put it through a function, and all the values for B, if I put it into the same function, I'm guessing, Y is where they both hit. So, but that doesn't necessarily mean A equals B.
No,
right?
It doesn't. It's just saying that Y is an element of that set. So we don't even know that the intersection is empty or not. We just know, we're just saying, what does this mean? It means that it's in the intersection of the image of A and the image of B.
Gotcha.
Cool. Now, the second half here is different, right? What does that second one mean?
Oh. So
that's different.
If if I find the value of if I find something in set A that's also in set B, and I take the function of that, Y is
in there. Y is in that thing. So
this is A equals B.
That's right. So A, it's where A and B are the same.
I would say like A sub I equals like B sub J or something.
Well, it's more just saying that if there's an intersection, send those intersections through the function. So it's a matter of when you're applying the intersection thing. Are you intersecting your domain, or are you intersecting your range, right?
Your range. Okay. Oh, okay. So this is if we're looking at this on like a graph of like 2 graphs, I'm just gonna try to think of this in simple 2D. Like if I had like this, and let's say I don't know. Maybe like. Sorry. What do you think? This. And then let's say like this. This and this. That would. And let's say this is like. This is A, and then this is B. This would be the first statement. Because I would say that this right here is like, this is F of whatever. So here, like...
Not quite. No, yeah, A and B are sets, not points. Yeah, I was going to say.
No, they're not functions. Okay.
I was hesitant to agree with this, and A is a set of things. So think of it like...
A is a bunch of stuff.
Yeah. All right, so here's an example.
Yeah.
Can you imagine you had a function that was x squared, okay?
Okay.
And
like a blue one.
A is the set of positive numbers.
Okay.
And B is the set of all real numbers.
Oh, okay.
So there's a place where they intersect, right?
Yes.
Like the outputs would intersect.
Here.
The place that the outputs intersect is in the positive region.
Yes. Okay,
right?
okay.
Yeah, so like that would be one way to think of it is if I take the function values, actually these intersect everywhere. Because f of A is all positive real numbers.
Right.
For the x squared, and if I take the image of B, that's also all real numbers.
But it's like I see. It's like this. It's like superimposed on each other because the function's the same.
Yeah.
Yeah. Okay.
The same.
Got it.
Well, the domain, the mapping is the same. So the image.
The mapping is the same. Yes. Yes.
Right.
Yes.
The image specifically is the same here.
Gotcha.
Even though my sets are different, but if I take the intersection of these, this is probably not the best example, the x squared example. I probably could choose something more interesting.
Yeah.
But the idea is in the A intersect B, the intersection of the two sets is all positive numbers. So then I apply the function to all positive numbers, which just so happens to have the same output, same image as the intersection before.
I see. But here they're saying these could be different.
Right.
Okay.
These could be different.
Did we explain A, or do we have more to say about A?
I think we did. I think we talked about A enough. I hope that's enough for our viewer who asked this. But for B, if you have something in the intersection of two images, right? Must the pre-image, so pre-image means what did it come from?
Okay.
Right? So what is the thing that, so if I have something that's in the intersection of the images, did the thing it came from, right? That's the pre-image.
Sure.
Must the pre-image under F be a subset of AB, A intersect B? So let's think about that for a moment. Is it required that, let's see here.
The F, is pre-image like kind of like the inverse function?
Sorry, what'd you say?
Is the pre-image like taking the inverse function on like F of A?
Yes. Like you're figuring out what maps to it. So you can think of it sort of like an inverse. Mm-hmm. This is not quite an inverse because this is not necessarily a one-to-one operation,
right? That
you're applying. But the idea is that what thing or things mapped to what we're interested in. What was the pre-image? So and that pre-image could include multiple things, right? For example, negative 4 and positive 4 could map to 16.
Right,
so
and that's why. Got you.
Right?
It's not one-to-one.
Okay. So that's why the distinction here is useful. So if the pre-image of Y under F, is it a subset of A intersect B? Well, if you had two things, I'm trying to think of a good counterexample, because I feel like if we find one counterexample, we should be able to say no to part C.
Just say no. Right.
Just say no. But if it is, then we need to address that. So Well, the pre-image of y, I'm writing some things down on my little note card. That means if we apply a pre-image, see, my gut instinct says no. I'm trying to think of why that is. I have to think of something discrete.
Is this discrete? Is this a discrete class?
Yeah. It could be. It very well could. Though, no, it's linear algebra for sure.
It's linear algebra.
Logic class. It might be like a logic class could ask this question. I could see it being like some kind of intro to proof. I always hated these questions because
this is a 300 level intro to proofs class. Oh my god! What?
I was right. Okay, it was intro to proofs. It had the feeling of it being an intro to proof class. That's why. That's cool. So 3000 level. Cool. So one of the I've done this problem before too. It's just been a while. I would apply. I think you can straight up apply a inverse function, or like the pre-image to both sides of your set element of. How does that work? You do. Gosh. Why am I blanking?
It's okay. I'm like super blank.
No, like I haven't even gone 3 hours yet, and here we are.
We're already getting stumped.
Getting stuck. I shouldn't be stuck on this question. So let me just. I want to pick something that has a common intersection. So if we I'm going to make up some function. I'm going to say that 1 maps to 2, like 1 maps to 2, and 3 maps to 2, right?
Okay.
I'm just making something up. And then if my set A is the number 1, and the set B is equal to the number 3, just the number 3, then Y is going to be the thing. This might be it. Okay, this might be my set. So the pre-image of 2, because 2 is the common image point, right?
Yeah, because that's
if Y is 2, then the pre-image is 1 3, the set 1 3.
Okay, isn't that A union B, not A and B?
Yes, exactly.
Aha.
So this is a counterexample. So A intersect B is empty because my set 1 and set 3. It doesn't have to be.
I see this. So you're saying this, for instance, this is Y, and then this is like the pre-image of Y, and this is also the pre-image of Y.
That's right.
Uh-huh.
I think that's right. So these are the kinds of questions that really like bother me when I think through them.
You done messed up, Aaron!
Those of you who've seen my channel a lot know I hate like formalism. But this kind of formalism actually is like reasonable. There's some certain other kinds of formalism that
I like being able to like when you
right?
distilled it down to like 1 3 maps to 2. I'm like, I can easily see that. I'm like, oh, okay, cool, yeah, I get it.
Yeah,
it's reading this.
Injections and surjections is also fun too, but that's for another day. I'm sure that in an intro to proof class you're going to be talking about injections or surjections. This is that seems legit. So that automatically disproves C. So this statement says that it doesn't have to be a subset of A intersect B. You're done. This is the kind of example.
So this is false. C is false. Right. This is false. Wait, I feel like we used this counterexampled for B, and then must F of A and B equal F A.
Oh, sorry. Let me read that carefully. F of A, and I get what you're saying, Dom. Like the rigor here, we need to be careful on how we write it down because some professors are like super persnickety.
Yeah.
Like we were talking about earlier, the proof I gave to the proof I wrote for gold was like a 6 out of 10. If I were writing it down for myself and like doing for a class, I probably would be a little more careful. But I was trying to get a point across, and I didn't. And then when you're trying to communicate something to someone else, that's actually very hard.
Oh no.
Especially when you have no keyboard
No
to
visuals.
help you. No,
Yeah,
no
or no
visuals at all. I'm
stylus.
just sitting here, like, no stylus.
No stylus. There's no stylus. Okay, so
anyway.
we proved B was false by the counterexample, right?
Yep. And then must A intersect B. So if you have A intersect B, that's empty. No, it doesn't, because we showed that the empty set.
Yes. Oh, okay, yeah, because that's really what we showed here.
In the intersection. Yep.
Yeah, because this is FA intersects FB, but F
That's right.
of
F of
A
intersect
and
B is the empty set, and
Yes.
mapping the empty set to 2 is not a logical thing to do.
Yeah,
Can't.
got it. You can't do that. Can't get something out of nothing, dude. No. Okay, cool. Great question there, Dom. I appreciate it. Nice.
I hope that helped, Dom.
Yeah,
I
think
hope
it
that
did.
like is comprehensible. Might have helped, but more importantly, is it comprehensible?
It definitely helped me.
Yeah,
I'll tell you that.
No
I understand
problem.
a lot more.
Glad to help. We got
Nice.
35 minutes. I'm going to be pretty strict about it.
No, please do. Yeah, I'm not gonna hold you. Don't worry.
But when that clock hits 17 hours, I will probably be out because my
All good.
my kids and family need me.
Yep. We get and Mrs. Pie. We got Mrs. Pie as
And
well.
Mrs. Pie. Yep, Mrs. Pie.
Let's see. JHNet posted theirs. I think this is singular value stuff. Maybe. Let me pull it in real quick.
My gosh.
Because I don't know if I know singular value stuff. I might need some help on this. And then let me get the next one. Sorry.
What is this one? Ooh, least squares. Oh no.
Okay, here we go.
Wait,
I don't know what this
why-
is. This might take Zach the next 30 minutes.
Let's see if I can do it. I haven't done these for a while. I remember I did a stream back in like 2024 where we played with this a little bit, and I just don't. I'm trying to remember the details. I'm getting up Wikipedia real fast just because I'm making sure I remember.
Curve fitting. Is this curve fitting? Is this like is this 40 like curve fitting? Like I see 4. Is there 4 points?
I think so. Single value decomposition is useful in. I suppose it could be curve fitting. It's useful in doing image compression or image compression is what we typically use this for. But that's what I think of, at least.
Is it like you're finding like a single transformation matrix thing that you can describe more pixels with less pixels kind of type thing? Yeah,
like you're basically making a diagonal matrix, which is your sigma matrix. That's what the singular values are. They're these eigenvalues that come out, but they're sandwiched by two. This is the part I don't remember. Is the how to get the u and the v. But we might be able to do this just by finding eigenvalues.
Yeah, someone said something about eigenvalues and like square roots of eigenvalues.
Right, that sounds about right. I'm doing my searchy search here.
Searchy search. You're all good. Knowledge Guy says, can you do tensors? If you ask some tensor questions, ask some tensor questions before Zach leaves.
Y'all are gonna break me.
No, dude, we're trying to, dude. Yeah.
That's your goal, right? Like
my goal, dude.
You're doing this for charity, right?
We're
like,
stress testing Zach AI for charity. Break Zach. It's like one of those things in high school where like you're supposed to throw like I don't know the potato sack at the thing and dunk your professor. We're just trying to dunk Zach.
Yeah, that's what you get. I at one point knew how to do this. I feel like I've done it before.
It's eigenvalues of wait, how do you find eigenvalues of non-square matrices?
Right, that's what I'm trying to. And you do like transposes. That's the big idea. You want to use transposes of A. I think that's what you do. You take A transpose A. That's what it is. Try doing A transpose A because that will make the matrix square.
Okay, I need to remember how like A transpose works though.
Transpose is you flop all the rows and columns. So like the rectangular matrix that's
so
2
1
by
1
becomes
1 1
3
still
by
stays
2.
there, right? But then this used to be
The first row becomes
1
the
column.
first column. That's right.
The first row becomes the first column. Oh, okay, so it's like this.
Yeah. I think this is the way.
This is the way. Okay, so this is A transpose, and then we're gonna hit this with A.
Yep.
3 0 3 negative 3 0 3. Okay, and then that should get me a 3 by 3.
Then we
think.
we multiply that out and get a 3 by 3. I think. Yeah, you're right.
Right? Yeah, because it's a
And that
3
should
by
give
2
us-
by 2
and I
by
think
3.
It's these values that we care about. The eigenvalues of this.
Okay.
Or what we care about.
So this is 9 plus 9 is 18. Right, so 18.
18 good.
This is 0.
And then we get 0. This is good news.
This
And
is
then
this
you
is great
do-
news.
and
0.
then you get zeros along the whole next row.
That all, yeah, okay. And then I get 0 again.
0, 0, 0, 18. So our eigenvalues are going to be
Are
the square
0.
root of this because we get the square root of this because we multiplied the matrix by its transpose. It's almost like we squared the matrix.
It's almost
So
kind of
we
like
take
A
the-
squared.
Yeah, so we're going to do square root 18.
So the eigenvalues are 0 and 18, right?
Square root 18.
Oh, okay.
Or I guess in the homework system, you'd want 3 square root 2. They probably would want it written simplified. So lambda 1 and 2 are going to be, this lambda is going to be 0 and 18 for the
Yeah,
for
0
this matrix.
and square root of 18. Got it, okay.
Well, because we're the eigenvalues of A transpose
Of this matrix.
A are
Yes.
0 and 18.
Gotcha.
We're going to take the square root of those for our matrix A.
Got it, okay. But eigenvalues for matrix A is equal to 0, and once it wants greatest down to least. So do you just say, sorry, is it 3 square root of 2, 3 square root of 2, 0? Is that like the
right.
answer solutions for this?
That's what it would be.
Oh. You can check the answer there, JHNet, right?
Jeff, lossy image compression. That's what this procedure is useful for. I believe that's right. I'm going to put about. I have some hesitation, but I think that's right. This vaguely. I think that's right.
JHNet says it's correct. Wow. Look at that, Zach, dude. You got it, dude. We haven't broken Zach yet. Okay. Maybe this one will break you, though. Like, how do we do this one? Least square solution?
Let me know if we get it.
JHNet said we got it. Yeah, said it was right.
We got it. Good.
Yeah.
Very good. So just take the square root of your A transpose A.
Yeah.
I
Square
should be
root
more
of
confident here.
Atta. No, you got it, dude, Zach. You got it, dude.
Okay.
What about this one?
Least squares. What we got? Least squares?
Yep.
It's going to be similar. What we're going to do is so that's a system AX equals B, right?
Uh-huh. Am I going to take
solution? But you can multiply both the left side by A transpose again.
So wait, so what's the difference between A transpose and A inverse?
Transpose is a changing of rows and columns.
Yes.
Inverse is the thing that you multiply by A to get the identity.
To get the super one. Yeah.
Yeah.
Okay.
The super one. Yeah.
Okay, so if I multiply A transpose by both sides, right? I know if this was inverse, right? The nice thing is that this would go away, and I would just get X equals, A inverse B, and we'd be done.
Right.
But we're solving.
But we can't do that here.
We can't do that here because this is not a square matrix, right?
But what you
okay.
can do is you can what A transpose A does is it makes the matrix square. So the procedure here is to make the matrix square so that I know how to solve the problem. Because I have rectangular matrices, the way to make a rectangular matrix square is to make the rows and columns.
And then once I have this, then I can find the inverse of that.
I can solve, yeah.
Okay.
Because it just so happens when you do least squares, the solutions are the same if you do it ax equals b or a transpose ax equals a transpose b. And there's a proof. I have a book here that I have in front of me that proves it, but we don't need that for this problem. We just need the result. So
okay, so this is just annoying.
That's the idea.
To find a transpose is just annoying, right?
Yeah.
Because this is gonna be 1 1 1 1 minus 1 minus 1 1 minus 1 1 1 1 minus 1, and then we're gonna multiply that by this thing. I imagine we're just gonna get like a bunch of zeros and stuff. Wait, what is this?
We might.
I hope we do. Okay.
You're going to get a matrix, Jeff. You're going to get a vector as a solution.
Yeah. Well,
And
okay, so
you can get free variables, of course. But like, yeah, there's going to be a solution to this.
Actually,
as long as the solution's not like, well, go ahead.
I see a pattern to this, right? Because this is just 4, this is 0, because this just means everything's itself. So this is 0.
Mm-hmm.
Oh, least squares means best approximation? Oh, I don't know. Okay, this is 0.
Yeah, so like that's yes, you're doing a least squares approximation. Like that's like your best approximation. That's right. But it just so happens that this procedure gives you the same solution set as if we were solving the best approximation problem.
Oh, I think this is just gonna be 0 0 4 4. I think this is all 4s. I think.
That's nice.
It's quite nice, actually. Yes, because that's 0. That's the middle flips, which is still 0.
0 0 4 should be. Yep.
Yeah. Oh, that's super fucking cool. Wow. Okay. Cool.
I think
all right,
the
nice.
problem was designed this way. Just maybe.
It's just it's quite fun, actually, the symmetry in it. Okay. So now I got that. So I know that times x is equal to like a transpose b.
Huh?
Right?
Yep.
Oh, wait a minute. Oh,
which I can do. That's great. So
well, because this is just 4 times the unit vector.
Yep. So on the other one, you're gonna get 8, a transpose b.
Yeah. Am I gonna get 8? Wait, so this is a transpose. So I get 6 minus 4.
Or 6 plus 6 minus 4 is 8.
Good. Okay.
Right. And then you get 4. 8, 4.
Yeah, 8, 4.
And then the last one is 16.
16.
So that tells me that the vector we're looking for, just divide everything by 4.
Oh, very cool. Yeah, because then this is the identity matrix.
Yeah, identity matrix on the left, and then we get x equals 2.
1 8.
1 8. Yeah.
Is that the right answer? 2 1 8, JSNAT?
What if A transpose A has 0 determinant? Well, then it's not invertible, and then you get some problems, don't you? that breaks things, doesn't it?
Yeah, it does. I don't want that.
That's part of the thing. If you can't invert A transpose A, then you're in trouble. But thankfully, in this case, we can invert A transpose A.
All right, JSNAT, is that right? 2 1 8. I feel like 2 1 8 is what we're supposed to get.
2 and 4. 2 and 4.
2 1 4. Oh, I fucked up. Don't put an 8.
4.
Don't lose points. 2 and 4. Then calculate the least square solution. Wait. There's more? No. It's just this, is it?
Let's find the least square solution. So then we need to do. Let's see.
Sorry. Because we found x. Oh, so that's not x star. What's x star then?
What is x star? You do. Oh, you need to. So you found.
We found x.
Like maybe. The book I have doesn't use X star. I think they might be using X hat here.
Oh, is that just make this a unit vector?
No, they're using hat in the estimation sense, in the stats sense, where you're estimating, not as in a unit vector. X transpose is it? Because star can mean different things. Star can mean the Hermatian matrix, which is not what because we're not dealing in complex times, so that's not really helpful. Unless they're using it as an estimation thing. I believe that A is linearly independent columns, you should always be good. Yeah, you should be fine.
So I think it's just 2 and 4. That's what people are saying.
I would just say it's 2 and 4. Yeah, it's 2 and 4. That seems like the.
It's interesting that they have like two different symbols there, though. No.
Yeah. Try to figure out what they mean by star.
Yeah, what's the star?
The book I have doesn't use star, so. It is what it is.
It is what it is. We think we're right.
Oh yeah.
I'm just gonna go with it.
I'm gonna go. You know, I'm gonna also go with it.
Final answer for the million.
2 and 4. We'll see what HNAT says. It's 2 and 4. I don't lose points on incorrect homework tries. This seems a bit cut and dry, but what's a good tip on remembering the dot for this? What's the dot? Sorry. Someone said something about the dot. Oh, the part of dotting these ones is where I get overwhelmed. What's dotting? You mean like doing the dot product?
Because like doing linear operations like this is technically a dot product. Like you're doing rows by column. So when you take a row and matrix multiplied by a column, that is a dot product, right?
I see.
Because I think that may be what's being talked about, but I don't know. I need more context.
I think maybe JHNat's talking about like how did we get this like kind of so easily? I guess like this.
Good question.
From this. My thinking was I saw that this times this were all the same thing. So I'm like, oh, it's just a bunch of ones times each other. So that's got to be 4. And then when I got to here, right, to get this element, which is this times this, I was like, oh, look, well, the middle 2 are going to be negative. That's going to counter out the positive 2 on the end, and that's why that's 0. And then the same thing here, right? Also, because this is 1, 1, 1, 1, 1, your sum here is just whatever the sum is here, here, or here, right? So here's just 1 minus 1, 1 minus 1.
Joppy is saying that the X star is estimation. I could see that because the book I have has X hat, which is used as an estimation thing. So I could see that X star being similar to this X hat. It's just a notation thing.
Yeah. Does that help you, HNat, with like how we got it? Because then I kind of saw the same thing here, right? By definition of them being transposed, it's interesting. They all kind of like they're like symmetries of each other. This one, I'm like, oh, well, anything times this is going to be itself. So that's 1 minus 1 minus 1 plus 1. And that's why that's 0. And then this is just like the mirror image of this. So that's going to be 4. Because anything that's negative gets hit with another negative. And then I guess this one was a little tricky. Because I was like, wait a minute. That one matches with that one. That one matches with that one. But then this is negative. And then this is negative. So that's why it's 0. Also, maybe just assume your teacher's being nice to you. We hope. So remember the row 1 times column 1 of the second, row 2 times column 2 of the second. Yeah. So the way I do matrix multiplication is I do this times this, and I know that that's like this part of the matrix. And so when I do, for instance, this one times this one, now I'm looking at this part of the matrix. And then if I do it times this one, now I'm looking at this part of the matrix. Yeah. I agree. It is kind of like tricky to keep track of it. But it was cool. There was some symmetry in there. Nice.
All right.
All right. Is it time? Is it time? Or we got 17 minutes?
16 minutes, yep.
16 minutes. All right. Let's find one. 1 second. Let me delete this. Jason, I'm going to post a solution for this in the Discord for you. Let me get that for you 1 sec. We got 16 minutes left of Zach. So let's find something fun for Zach. Zach loves fun.
Thanks.
He loves the
I appreciate
fun. He loves all the fun. Okay, there you go, JSnat. There's that. I put both your questions in one thread for you, JSnat. You're very welcome.
Wonderful.
Let's see what we got. This is the one that I think Poison won. You said you have the solution for this one?
That's not the one, but we can work on this one.
You want to work on this one? Let's work on it. Yeah.
Fourier transform.
Poison did leave us to us before he went to bed.
Okay, so let's do the Fourier transform.
Let's just do the Fourier transform. Let's
I
just
know,
do
right?
it.
Like, just do it. Just do it. So, let's plug it in.
Okay. So, I just like plug. What's this fucking Ada thing? Can I just make that X? Why is it Ada?
Tornado. Didn't you? No, it's not Ada. It's Kassi.
Oh, Kasai or something?
Yeah, Kassi. XI is how you say it.
I'm gonna make it X, dude. All right, well, okay, we'll take a look at it.
You know what? When I do these problems, I like to use omega. Omega is acceptable.
I like that. Let's do -2 pi omega e. I like that.
Use omega.
Negative pi omega. Like, dude, what the hell is this weird tornado thing? E to the 2 pi I omega. Oh, I see why I can't use X. Because there is an X in there already. And then this is d omega.
And that's, yes, it's d omega.
Okay. So I'm going to pull out some constants, no? Can I just pull this out?
So what you should do, pull out constants, that's fine.
Okay.
And
what do we do
different
next?
Authors use different things, but what I recommend is bringing the numerator or bringing the exponent together and factoring out a pi and that's it. Yeah, you can factor out the pi.
So we know it's this. And then I'm going to factor out... Should I factor out the omega or no?
Don't factor out omega. Actually, that's important that we don't.
All right, let's not factor out omega. So we're just going to factor out pi. Let me think how I want to do this. I'm going to say pi. I don't like the negatives where they are, so I'm going to move them away.
That's fine.
So I'm going to say this is 2i omega x minus omega squared.
It would be more clear if you use Kassi.
Surprise, motherfucker.
Stop, lonesome, bro. That's a sine plus cosine?
So
is it?
Here's just for our sake, factor out a negative sign, a -1.
Out of what?
Factor out a -1 because
out of this? Out of the.
So in other words, swap the order of the terms and bring out a minus sign in front of the pi. So that's all we're doing. So the omega squared is positive, and I want you to see something. This is a very not intuitive thing to do, but we're just going to do it anyway. No pi in there.
Oh, there's no pi. You're right. You're right.
It should have an X.
Yes, that's what I meant to put.
Just put an X in its place and it's fine.
Yeah.
Okay. So the key to this problem is doing something called completing the square.
I do love completing the square.
Good job.
So take that quadratic in omega and complete the square with respect to omega. So like on the side, I would just get this thing and move this over here. Yeah,
let's do it.
That's right. So complete the square.
You know what's so nice, Zach, about having like a tablet and like a board?
Hey,
is I can just copy.
I don't have to charge my chalk, okay? I don't have to charge my chalk.
You do have to keep. Do you have the nice chalk? You know what I'm talking about? The Kurigami nice stuff.
Chalk, yeah. I have Hagoromo. I have it on my desk.
Yeah, that's nice chalk. Okay. Okay, I'm gonna divide this by.
My chalk.
I don't charge my chalk, but you do get charged for your chalk. You do get charged for your chalk.
Whatever. I don't have to replace my technology as often as you do.
That is true.
I don't know. Maybe. I don't know. Maybe not. Maybe a box of Hagoromo has lasted me almost a year. So.
And how much that run you?
Somewhere in like the $40.
Okay. Yeah. No. I probably blow through tablets.
What's the cost of a box?
I think I blow through tablets every 2 years, and they cost me like 120, 130.
So white Hagoromo. I'm checking right now. If you go, it's about $40, $50.
Thanks, man. Both win. Oh,
Actually, the white chalk, I can get it for $28.
Ooh.
I can get it
For
for $28.
those that don't know, Zach's talking about a very specific type of chalk. Was it
Hagoromo. So I can find it for about $30 for a box, which lasts me a year. Which, if we take it conservatively, if I say that your tablet lasts for 5 years,
dude, I don't think my tablet lasts for 5 years.
I was gonna say I kicked. You can forget the the investment. I don't think it's worth it.
It's apparently really, really nice chalk, though. Oh, they have color chalk,
nice
too.
chalk. Yeah.
Other companies' chalk. Our chalk. Easily broken into... This was the thing, dude. I remember being a TA in grad school and just having to hunt for, like, the scraps of chalk. It was so bad.
It's true.
Good to see you, 23 Pro. Wait, did I complete the square, right? Completely, like, here, right? I divide this by 2, and then I square it?
You divide it by 2, and then you square it.
So I get xi, right?
That should be
square
okay.
Minus x squared, so then I add that and I subtract that.
So you should have omega minus
x squared?
xi, right?
Oh, you're so right. You're so right.
So
yeah,
omega minus xi squared.
Yeah, sorry. Let me.
Then,
actually, that's what I want to do. Yeah. I want this to be plus xi squared minus xi squared. That'll eventually become plus 1 or plus x. Yeah. Okay.
That's right.
Okay, so then this is omega.
Factor. Jeff, I don't know.
Is there another smart person coming on? God damn it, Jeff. Okay, I think this is it, right? I think this is it. This is my square is complete.
I think that's right. I'm looking. That looks okay.
Okay, it says it looks all right.
Yes, it is. Okay. So now we can write that whole numerator in that way.
Yeah, let's go do it. All right. Let's pull this.
When I do this problem, I usually have I write it a little differently, but this is equivalent, so it's fine.
Okay, so it's this.
So that whole thing needs to be multiplied by negative pi, by the way. There you go.
Yep. We got the negative pi.
So since we're taking an integral with respect to omega, you can factor out the e to the minus pi x squared. That whole thing can be pulled out, no problem.
Oh, that's brilliant. Yeah. This actually comes out. Okay.
Yeah.
Okay, and then this is omega e to the negative pi omega minus xi squared. I'm guessing this is this a u sub thing here going on?
You could do that. Yes. I think you can do a substitution here and it should work out.
Is there another way to do it?
I don't think I think this is the way. Like you do want to do a substitution. I don't see any advantage in not.
That's what I'm saying.
So go ahead.
Let u equal omega minus xi. Wait, no, squared.
Xi squared.
Good. So du is equal to 2 omega minus xi d omega, right?
That's right.
Ooh, how's that gonna work? Oh, okay.
So you can do. Think about this for a second.
Yeah.
Actually, you could do u equals omega minus xi.
Yeah.
And then you're going to end up doing integration by parts.
No.
I know it's not great, but do the substitution, but the substitution
will at least get rid of this. I got you. It makes my life a little bit nice.
So the issue is then you end up with a complex integral, and I don't know if I want to have you. The complex integral is not too bad.
Yeah, I'm not here for that. Not here for it.
I'm not here for that either. Now, I think what you want to. Do I want to do? You need to change the. How do I want to do this? This is is not quite calc 3. This is it's related to PDEs.
Oh, okay.
This is actually a Fourier transform, which is commonly used in PDEs to solve PDEs.
Yeah.
I've done this integral before.
Well, this is what I got to so far, right? And then I mean,
and that's fine.
Well, except this one kind of sucks though, no?
What happens is the imaginary thing, I think, goes to 0, and then the other part, the u to the minus pi u squared.
This part I can do. That's yes, that I can just do u sub. That's not bad at all.
2, and then you get the exponential.
Yeah. Well, I divide by. Sorry, divide by 2 pi though, right, or something.
You divide by 2 pi. Yes.
Yes.
Because substitution.
Okay, so we're gonna make the argument that the imaginary one goes to 0. Well, I'm totally cool.
Good night,
with that.
Joseph. Good night.
All right, night, Joseph. I'll see you in the morning. Yeah, I'll see you. We're on for another 17 hours. We'll be here.
And I thought my 10-hour marathon was bad. I did that in January.
I don't know.
July.
I
have to try and take it back someday. Maybe go for like
we go for the gauntlet. Yeah, it's 20. You know what you're gonna do? You're gonna do 24 hours in like 10 minutes. Just be like.
I don't think I have the stamina.
Oh my god.
Okay. Yeah, not.
I'm saving the coffee for later. I do not want to like wet my whistle on caffeine yet. I don't need it yet. We've only been going for 7 hours, so I'm okay. When I start hitting like the 12, 15 hour mark, then I'm gonna start hitting the stimulants, but I don't hit them yet.
So I think what ends up happening.
This goes to 0.
Here,
we think
this thing goes to 0. I'm trying to remember how I justify that, but that goes to 0, and then the other one you are able to evaluate directly.
Right, and then this is e to the negative pi u squared from negative infinity to infinity. Oh, but wait. U is equal to
really
omega plus xi.
But this integral, because it's from negative infinity to infinity, you can actually do double from 0 to infinity because you're squaring.
Because it's symmetric.
Yeah, because symmetry. So you actually are going to do from 0 to infinity.
Okay, but then instead of u squared, it's omega plus xi though, right? Or omega minus xi?
No, because you've already substituted. If you do your substitution,
yes.
You don't need to do the w minus xi because your bounds when you make your substitution for u.
Oh, are also still infinity to infinity.
Yes, that's still net infinity. You're shifting by a constant.
Wait, even with the Oh, sorry, because omega
That's a constant. Yeah.
Oh, yes, okay. Man, that X is tricky, dude.
And it is a Gaussian. The Japastock is right, but that's what this turns into ultimately. This is a Gaussian integral, but you're just gonna do.
Oh wait, well, integral dash is gonna be 0, right?
No, it's gonna be. You should change the variable from u to something else. Don't use u.
Don't use u?
Because you've changed from the u squared in the red integral. You did a substitution there to something else. So choose a different letter.
Oh, okay.
If you want tornado, you can have it.
All right, I got tornado.
So just not tornado squared, but just tornado.
Tornado, yes.
Because tornado is u squared, and then.
Got you. Oh no, I see. I did a phantom substitution in between here.
Yeah, but you're gonna need to multiply by 2, right? Because you have 2 sides of this. You have the range from negative infinity to 0.
Yeah.
And from 0 to infinity. So
right.
Those are both metric.
So 2 0 to infinity. And then we're good, right?
Should be. Then let me think. Do you have anything else? I think that's okay.
And then this is plus 1 over pi. Whatever, it's a 2 times all this. And then this is e to the 0. So is the answer just 2 over pi? This goes away, right?
Is that other integral not 0? It's been a while since I've done this. I was playing with this, I want to say recently, but I haven't done it recently enough.
Ladies man asks, what's a tornado? Tornado is this thing. I don't know. I don't know what this symbol is.
It's XI. That's the symbol.
Okay. 2 over pi seems legit. Don't worry, Alistair. I bought a 4-pack of Red Bull.
Feel right.
Oh, Jobstock wants to say this. The second integral is not 0.
Disqualified.
Yeah, I think.
Oh, we can't say this one's 0.
I'm doing a quick checky check here.
Checky check. He's got 30 seconds. Then he's got
30 seconds.
the pumpkin.
Yeah,
The pumpkin. The pumpkin.
Did I mess up? I don't think I did. The way... Hold on, can I see how the problem is stated?
Yep.
Because I've got it.
Why do you have X in the second integral? Why do we have X in the second integral? From completing the square.
I know you're supposed to complete the square, but there's a reason. It's been too long. Man, y'all challenged me today.
What's up, Clickbait? Jobbystock says the second one isn't X times I. Why isn't it? I thought when we made this substitution here, we said that u is equal to omega minus xi, so omega is equal to u plus xi, no? In order to get rid of this. And that's why I have one of these with u, and then one of these has xi on it.
If you want to see it worked out, this is a... I have to go, but...
You're good. I appreciate you, Zach.
Here's the link to a solution.
Okay.
That might be helpful. So I know it skips some steps, and I was trying to fill in those steps, but it wasn't working out. So that's just the way it goes. Sorry I couldn't be more helpful.
No, you were so helpful today, dude. We learned so much today. Yeah, give Zach a big round of applause for donating 3 hours of his time to come get roasted by you guys. I learned so much today, Zach. Thank you, dude. We should do this more often. It's fun.
That was fun. I enjoy it. I'm always happy to help out. And go give Dr. Gold all the things today. Because Dr. Gold is awesome.
Thank you, dude. I appreciate
that. Thank you, Fanbox.
Yeah.
I appreciate the enthusiasm. I appreciate it.
We had a lot of fun ones today. I learned about all sorts of set notation and fun stuff.
I will say that was the most grueling 3 hours I've had in a while.
We put him through the ringer.
We went from analysis, we did multivariable integrals, we did Fourier transforms, we did set theory, we did domain and range, we talked about linear algebra and least squares. We did oh my gosh.
Physics Olympiad stuff, you remember this stuff?
Physics Olympiad. That challenged me. You have to be, in order to do something like this, you have to be well versed. If you're ever going to try to take questions from chat, this is a daring adventure, Gold.
I used to be scared of it at first. Yeah, but now I call myself open format. We're open format
Yeah.
solvers. Yeah.
Yep. Well, thank you very much. I appreciate you. I'll gotta get off.
Thanks, Zach.
Yep.
We'll see you around. Peace.
I'll probably lurk in chat.
Okay, lurk in chat. You're totally cool. But no more roasting Zach, guys. Okay, one sec. W Zach. Zach is great. Isn't this xi exp minus pi omega squared d omega? I missed all the roasting. It's okay. The VOD is still recorded. The VOD is up. Okay. I'm gonna the queue is at like 16 questions, so I'm gonna start trying to run through some of the other ones that people submitted just to try to get the easy ones out of the way. But that being said, if you want to keep like talking about this one, please feel free to join our Discord. Please go join our Discord. Like that's where all the discussions are and all the fun stuff is, and where you can find Zach, and maybe links to his. He has his own Twitch stream where he does other cool, similar helping out with math stuff. But you saw Zach's knowledge. Zach knows a lot more higher level math than I do, and it's cool to learn from him. And so if you have high level math questions, I'm gonna highly recommend you go check out Zach's stream, which is right here. I'll post the link here in the YouTube for you guys too. You wanna here? I'll shout out Zach on. Yeah, I am about to speed run some of these. There is. Yes, I will help you out with E&M all the time, Zach. Dude, I got you, bro. Yeah, I can help out with the physics. You help me out with the math. Yeah, teach me, teach you, type thing. Where is my There's my... Is Tornado Kasai? Yes. I came up with saying Tornado was Kasai. Or Xi? Xi, I think, is what it was. But here you go. This is Zach's Twitch there on YouTube. So make sure, go give him a follow. He's a great guy. He's almost up to 1,000. Did we get him closer to 1,000? I want to see. What are you at, Zach, these days? It's pronounced Z, XE. 992, there we go. We got you at least 4 followers. Okay, Zach is only 8 followers away from 1,000. Go get him up to 1,000. That'd be really fun if he hit 1,000 during the stream. I'd be so happy. 8 away. I'm gonna be promoting you all night, Zach. Just telling people to follow you. And we'll see if in the next 16 hours and 54 minutes I can get 8 more people to follow you on Twitch. Anyways, but yes, if you want to keep working on that question, because I know a couple of you guys, Joppa Stock and Jorgen and stuff, you guys always have great insight on maybe where I'm screwing up. That's going to get posted in our Discord. So if you go to the website, actualofficehours.com, which is where people are submitting their questions, you can click here on Join Our Discord. And then what happens is we're going to go put that one in. Whose was that, by the way? Oh, that was Poisoned. Yes, it was Poisoned. Transforming a derivative? Was it question 12? Sorry, which one was this? It was that. Okay. So I'm going to mark question 12 done. And then let me download this. I want to send Kabbalah applications in the Dropbox, but no. So when are college apps due? Because you're not the first one, Laz, to ask me about that. I've totally considered doing a like a college app review stream. I think Zach showed some interest in this too. Where, I mean, we've gone to college, we've gone to grad school. I've helped people get into grad school and college and stuff. I'm sure Zach has as well. It would be fun to just like do a stream where we not roast, but you know, give you feedback on your essays and stuff. January 1st? Okay. Maybe we'll do something in December before the holidays. I know UCLA early stuff is due like next week. But anyways, yes, in the Discord, I'll show you where this question is going to come up. So this is... What's up, Omar? Test was BS. One question, the acceleration was 4,800 meters per second. I got it, and it changed it. Yeah, that does look fucking wrong, dude. What? Omar, your teacher is putting whack-ass numbers on their stuff. Okay, so this was Poison's question, and then here, we're just going to drop that in. So if you want to keep talking about this question, maybe you have like a nice solution that looks better than what we have, please join our Discord and discuss. What's the queue at? 16. I'm gonna start purging the queue a little bit. So I'm gonna start going through them. We were having some fun there with Zach. I was skipping through the queue trying to find the hard questions for Zach to have fun with. Zach had a great time. Yeah, college app review stream. Wouldn't that be fun? My main problem is I helped friends get to grad school, but I can't even write properly for my own applications. You just need an outside opinion, dude. A little outside opinion can help out. Okay, let me have about T. Okay, this question's in a different language. So, I am going to translate it. That's the other cool thing about doing this live stream for 24 hours, is especially once we get towards the later hours, we're going to start reaching audiences that are awake in different time zones. So, that's going to be like people in Europe, Asia. I think it's fun. It's kind of like a stream around the world. We're going around the world today. Yeah, the queue is not... Oh, wait, no, I don't need the solution. Sorry, what? No. No, just translate it. Not to mention, this might be the first gold stream I'm going to watch in the afternoon. Nice. So I didn't want the answer. I wanted to solve it. But also, this looks like... Dude, what? Yeah, this is engineering stuff. Excuse me? What? No. Oh, man. I am Norwegian. Yes, you are nocturnal. I'm pretty nocturnal too, honestly. All right, translate. You're gonna get JEE 18 hours in. I know. Yeah, once I hit like fucking IST, India Standard Time, I'm just gonna get mobbed by JEE questions. But I don't do those. Wow, you watch my streams the second you wake up? Wow. Start your morning with Dr. Gold's premium blend of math and science questions. JEE is AIDS, yeah. Pretty much. I hate JEE. It's fucking awful. So this is like an engineering question that got submitted, which uses like some very specific equations that I didn't really learn in physics. Like pipe friction coefficient? What the fuck is that, dude? What's a pipe friction coefficient? And how does that relate? So this is actually something where like we do have to kind of use ChatGPT to learn along. Cause I want to use the height difference. I want to use Bernoulli's equation. That's what I want to use, right? So what if we had like, where's Bernoulli's? A cup of gold instead of a cup of Joe. Yeah. This is what I want to use. 3 a.m. and me there with no flame in my eyes. Just the dead eyes of math. This is what I know. I know about Bernoulli's equation is this. What pressure difference? So that's gonna be like P1 minus P2. So I feel like you can almost do this, but I'm curious about the pipe friction coefficient, where that comes from. What is something you know GPT consistently is bad at solving in another type of situation where it does really well? It generally messes up with diagrams. Anything with spatial reasoning, it's not the best at. Otherwise, yeah, it's pretty phenomenal. Everything else, it's a dimensionless value for the resistance to flow. Yeah. So how do we think that works? Is that affecting like V, or is that like flux or something? Okay. So P1 plus 1/2 rho V1 squared plus rho GH1 is equal to P2. That's absolute pressure at 2. Plus 1/2 rho V2 squared plus rho GH2. The effective friction. Yeah, I mean, this is also the reason some people complain that if the pool isn't deep enough, they feel like they swim slower. And that is true. You start to feel the effects of the friction of the water against the ground as you get closer to the bottom of the pool. GPT is actually decent with chem, Narowski, from what I've seen. It's gotten stuff pretty well. Okay, we're trying to figure out the pressure difference. I assume that's P1 minus P2. So P1 minus P2 is then equal to 1/2 rho, and then this is V1 squared minus V2 squared. Or sorry, V2 squared minus V1 squared. And then plus rho GH, rho G, H2 minus H1. Biggest Q I've ever seen? No, I mean, I've seen it get up to 30. Yeah. Okay. Okay, so height difference is 10. So that tells me what H2 minus H1 is. That's 10, right? This is H2 minus H1. Something. And then here it says 46 meters cubed of water per hour. Okay. So 46 cubic meters. So I believe that's equal to the cross-sectional area times the velocity, right? This is like Q. So this is like flux. And that has to be meters cubed per hour. I don't like that per hour, though. So I think I want meters cubed per second. So I'm going to divide that by 3,600 to get meters cubed per second. The friction coefficient uses Reynolds number and the relative roughness. Okay. I'm curious where that comes into the equation here. It must be a loss of pressure, right? Friction means that you're losing like energy within the system. So, and pressure is kind of the energy within a liquid system. Okay. Okay, and then A. Well, we know some stuff here, right? So A. Wait, and I think Q is the same everywhere, right? Right? Flux in has to equal flux out. So that just tells you as A changes what the velocity would change as. Because A is going to be equal to pi times 0.006 squared. That's the area of the pipe. Because the diameter is 120 millimeters. So 60 millimeters. Oh, so 0.06. Sorry, my bad. 0.06. Yeah, 120 mils. Okay, cool. And then the length of that does some shit, too. Okay, so I think we're getting closer. P1 minus P2 is equal to... This is where I'm curious here. The velocity difference. So there can't be a velocity difference due to a change in the cross-sectional area of the fluid flow because the pipe doesn't change. But there is friction, so I think that's going to cause this. I think there's going to be a difference in the velocity due to the friction. So let's see what they get here. Yeah, this is it. Frictional pressure loss, Darcy-Weisbach. What?
Disqualified.
See, this is the garbage I'm talking about, dude. Like, where the hell does this come from? Right, cool. I think I probably got this the same for the velocity, right? Let's see if I got this for the velocity. I was pretty sure I did. So 46 over 3,600. 1 over pi times 0.06 squared. So 46 divided by 3,600 divided by pi divided by 0.06 squared. Yeah, I get the 1.13 is V. That's the fluid flow, which is what chat got. I agree with that. Cool. This is interesting, this head loss thing. I have no clue where this comes from. Fascinating. This is an engineering thing right here. Yeah, okay. Okay, so L was, length of the pipe, right? D is the diameter. V squared or 2G, this is the V we came up with. Okay, so then this is the change. I don't know what this HF is, but apparently that's, I guess, the change maybe in the effective gravitational height of the fluid due to frictional loss. And then you multiply that by rho g to get an effective change in pressure. Okay. So that's 1.6 times 10 to the 4th pascals. It's Darcy. Yeah, I've never seen Darcy frictional factor. That's cool. So I'm guessing, do I need this? I feel like I don't need this term, right? Because I'm assuming that the velocities are the same. So I think it's just this plus the other loss, right? So I think it's just rho g times the height difference of 10. And then plus the 1.6 times 10 to the 4th. That's a friction coefficient. Yeah. Okay. Yeah, there we go. Okay, cool. That's all we had to do. Okay, sick. Okay, because then this is 1,000 times 9.8 times 10. So that's 9.8 times 10 to the 4th plus 1.6 times 10 to the 4th. So that's equal to 11.4 times 10 to the 4th pascals. Nice. Yeah, not bad.
Well done! Well done!
Which I think is what they got here. It's the same. Okay, cool. Or 1.1 times 10 to the 5th, I guess, technically. Alright, nice. Good question from T. Let's put this in. Mark that's done. Equity, I'm going to do yours next. I'm going to try to go through the... We have quite a queue of questions to go through. All the way back from 11:30 a.m. All right, let's see what we got next. Thanks for the follow, Mad Bananas. Let's see. Live queue. Equity. Rectangular prisms. Okay, two identical rectangular prisms. Each have a height of 90 centimeters. The base of each prism is a square, and the surface area of each prism is k squared. If the prisms are glued together along the square base, the resulting prism has a surface area of 92/47k. What is the side length of each of these square bases? Oh, that's fun. Oh, okay. So it's a little bit less than 2, right? And that's because you're losing one of the bases. Yeah, I know how this works. Okay. So, yeah, this has 90. Oh, wait. They both have a height of 90. The base is a square. Oh, I might go get some coffee in a bit. Yeah. We've hit 8 hours. So 7.5. Okay, let's just call this equal to S. We know this is 90. So, and then surface area, which is equal to K. That's equal to 2S squared plus 4 times 90 times S. Right? Because you got surface area, and then 4 of these 90 by S sides. Okay. So K equals 2S squared plus 360S. Great. If the prisms are glued together along a square base, the resulting prism has an area of that. Okay. So if you glue these together, you don't get 2K. And the reason for that is you lose out on this bit of surface area. Okay. So what we can say here is that minus 2s. Yeah, exactly. Or 2s squared, I think. Right? So 92 over 47k is equal to 2k. That's what the whole thing would have been. Minus 2s squared. Yeah, all good. So, you subtract that. That's 94 over 47. So that's negative 2 over 47. K is equal to negative 2s squared. 2's cancel. So then I get k over 47 is equal to s squared. And then wait, what were they asking for? What is the side length? Oh, okay. Oh, okay. Wait. I know now that k is equal to 47s squared. I can now plug this into here. So we get that 47s squared is equal to 49, is equal to 2s squared. We're going to add that eventually. Plus 360s. So what is that? 0 is equal to negative 45s squared plus 360s. Or 0 is equal to s, and then this is negative 45s plus 360. So there's the trivial solution, which is that s equals 0. That doesn't really help us out. Or there's a solution that s is equal to 360 over 45, which is equal to 18. Or wait, no, 16. Wait, no. No, 8. S equal to 8. Uh-oh, making mistakes. Thank you, Machka. Okay, great. There we go. We got it. I don't know if I said 18. Y'all are going to start seeing me make more and more math mistakes as this gets further and further along. I can't wait for my brain to be absolutely melted when we start hitting the back 12. Alright. What are you guys writing here in chat, dude? Navier-Stokes existence is smoothness problem? Riemann hypothesis, dude? What? Bro, take a break. It's okay. I like Alistair, I appreciate your enthusiasm, dude. I appreciate your love of life and equations and stuff. Okay, nice, cool. Good question, Equity. That's a fun one, actually. I know I've seen that one before somewhere. Equita. Femistral says, me first. Okay, fam. You did redeem me first. I will do it. Which one is yours? Oh, did you not put it in the queue? Bro, are you going to be drowsy soon? Yeah, I'm going to be very drowsy. That's the point. Oh, I see. You did it here. God damn it. I already know where this is going, dude. I'm pretty sure I already know where this question's going. This is your division problem, famished? Okay. Yes, there's a lot. I know what he's doing too. It's okay. We'll let it happen. We'll let it happen. You cursed soul. Yeah, so I mean, yeah, the good question here, right, is how do you simplify this? So I think what goes into 96? Well, I know 12 does. It does that 8 times, right? I can divide this by 12. I can divide this by 12. So that's going to get me 8 over 12. Which I can then now divide by 4. Divide by 4. And we're just going to leave that as 2/3. We don't need to round it. We don't need to round it to the hundredths place. Yes, 2/3. Yeah, nice. Good job for Mistral, dude. Thank you, dude. It's 2/3. Yeah, do you want me to say it's 0.7? That's what we should say. There you go. No 6 for you. Okay, famished. Okay. That was famished. Which famished? Oh, yours was just in the Discord. Okay, cool. I need coffee. Yeah, I'm about to go get a Red Bull. I don't think yet. I think I'm okay. I don't think I need caffeine just yet. I think once we hit 10 hours, I probably definitely need coffee. Let's see what this one is. Ooh, stats. We got some stats today. Go get some coffee, Famist. Okay. The frequency distribution above summarizes a set of data where A is a positive integer. How much greater is the mean of the set of data than the median? Very cool. I mean, we can already tell what the mean is. I feel like the mean's equal to 3. Maybe give Navier Stokes a try. No, please, no, I don't want to. I feel like the mean is just 3, right? Because it's symmetric. It's symmetric about 3. Yeah, it's balanced. Perfectly balanced. Which means the median is also going to be equal to 3. Right, mean equals median. So the answer there is 0. Yeah, so that's a 23rd hour. I should have left that for the 23rd hour, shouldn't I have? Right. Symmetric means mean equals median. For those that are wondering, I mean, there are some cool times. It has to do with skew. There we go. Has to do like how there are outliers. I want like a better image. This is kind of a cool one. Unless A equals 0, kurtosis. That is true. The second moment, yeah. So this is kind of the key thing here. So I mean, and this has to do with, for instance, your grades. Has your teacher ever like posted grades and you have like mean and median and you like wonder like what's going on, like which is a better indicator of the actual performance of the class? So in the case that you have outliers, so this right here, I don't know why my TikTok chat fucks up every once in a while. All right, whatever. These are low outliers. Or salaries at large companies. Yes, that's another one. Yeah, if you look at the median salary versus the mean salary of someone at a company. Yeah, and these are high outliers. So in the case of your data set where you have a couple people that have really, really, really low values, what that does is that pulls the mean closer to it than the median. So if the mean is less than the median, it means you have a skewed left distribution, which is also the same thing as saying that, you know, there's a lot of like low outliers, right? The CEO example that Jeff brings up, this is a great example of why they say median salary at a company, not mean. Because in the case of high outliers, right? So if you have some people that are just like fucking crushing it, in this case, yes, this would be like CEOs. Like CEOs get paid a bucket ton of money. You can debate whether that's right or not, but what that ends up doing is if you look at the average salary of someone at like, say, Apple or whatever, the average or the mean is very, very high. But in reality, a lot of people, I mean, I guess probably the best one for this is actually Amazon, right? If you look at like the salary of Jeff Bezos versus like how much the people in the warehouse get paid, that's a very skewed right, positive, and then there's a lot of high outliers. And then when that happens, the mean is much higher than the median. So if you're reporting like the mean salary at Amazon is $300,000, that's not an accurate representation of what most people get paid. Most people get paid closer to the median. The most people get paid the mode. The mode is you've probably seen this in stats before, mean, median, mode. Mode is what happens the most times. Yeah. Okay. Cool. But yeah, if it's symmetric, then mean, median, mode are all the same. Everyone's happy. Perfectly balanced. So, cool. Good question there. That was 7688. Alright, so let's go put that in. What's 7688 backwards? 8867? God damn it!
That's done.
No, you didn't. No, dude. No, God! God damn it, Jeff. No, Jeff!
God, please, no! No!
Do not begin! Do not begin! Do not begin the card! What? Do not begin the card!
God damn it, Jeff. God damn it, Jeff. I vote to mute Jeff for 1 minute. We can't mute Jeff. Jeff's a mod. We can't mute Jeff. Okay. Fucking fuck. Yeah. What numbers go between 5 and 8? Can you help me remember? Yeah, anytime people say that, I now just say 8, 9. I think that's the ultimate way to like just to we need to snuff this out. We need this is a degenerate of memes. Oh man. All right, I'm losing my brain. I might actually go get that Red Bull in a second. Cuz I'm like trying to do things and my head is not working. Okay, here we go. Okay. 7688. Someone's asking, hey sir, I still don't get the difference between variance and standard deviation. So variance is just the standard deviation squared. Right? I mean that's the classic way to know, right? I think it's right, this squared is equal to the variance. I don't know. I mean, it messes up different equations for sure when you're solving for stuff. Rockstar 0 carb? Yeah, bro, I don't need 300 milligrams though. That shit'll fuck me up, dude. Okay, I'm gonna go get a Red Bull. I'll be right back, okay? Give me 2 seconds. Just hang tight. Hang tight. I need to be able to, like, think. All right. We're back. Yeah, I know, right? I probably will make some coffee later, actually. I do enjoy a nice espresso, but this was on sale at the grocery store. Fix this up. Come on, there we go. Yeah. You know what they call that? They call that the Bader-Meinhof effect. When you keep thinking something's always there because you're, like, specially attuned to it. The key example of that is, if you buy a certain type of car, like if you buy a Jeep or you buy like a Civic, you're gonna start seeing Civics and Jeeps all the time. Like you start noticing them more. I have given away a laptop. Yeah, Nick won the laptop. What's up, 23 Pro? Yeah, let's look it up. It's called Bader-Meinhof. This weekend is gonna fall on the. Oh no! Oh no! Yeah. Wait, what's Bader-Meinhof? Is it the Bader-Meinhof thing? Maybe it's not Bader-Meinhof. What is it? Okay, wait. The phenomena where you keep noticing things. No. It is Bader-Meinhof. Yeah. It's called Bader-Meinhof. The false impression that something happens more frequently than it actually does, which occurs when we learn something new. Suddenly, this new thing seems to appear more frequently when in reality, it's only our awareness of it that has changed. Right. And this is exactly the example I said. Yeah, if you buy a car with it, like let's say a blue car, every time you look out and see cars, you'll just keep seeing the blue ones. Yeah, it is Bader-Meinhof. I've started self-learning Calc 2 and also LaTeX. Do you have any good advice at getting good at LaTeX? Yeah, getting good at LaTeX is great. I mean, I agree that ChatGPT can do a lot of LaTeX formatting these days, but it's useful to know for sure. I use LaTeX all the time. Wow, Jeff, that's such a meta. Jeff's like, that's the 10th time I've heard the Bader-Meinhof effect. Is it because you just learned it as well today or recently? Yeah, I think it's good to understand LaTeX, especially if you want to like type things on the fly. Like you'll notice people in my chat are doing it, right? If I rack up 400 points, could I get a computer? The big prizes we do are usually during like events, so like summer camp or something. I'm trying to make my own YouTube channel, as you know, in conjunction to my own blog. I want to ask an AI model to just look at the math and then, yeah, you totally could do that. Yeah. ChatGPT again is really good at doing LaTeX. It's very good at coding, so totally cool. I think you should understand LaTeX at least. You don't have to remember all the jargon, but you know, at least know like how to do a fraction. I forget how to do like the up arrow sometimes. Well, that Red Bull's giving me wings. All right, let's do this. I have given away laptops, yeah. Yeah, if you ever go check, if you're in our Discord and you go to, where is it under? Server guide, maybe? Yeah, here. I need to update this. I haven't done the prizes in a while, but these are all the different prizes we've like given out. So that's included a laptop before. Yeah, so like giving out keyboards. I got a gaming desk for someone. Someone wanted a desk. That was Teacup. Teacup wanted a gaming desk. I bought him a gaming desk. And then, yeah, here's the laptop. It was a Dell gaming laptop that Nick won back in 2022. I even like wrote him a nice little letter. He won the grand prize. But yeah, we announce it when we have like big prizes. Yeah, I also gave out an Oculus. This was a Oculus Quest 2, I guess. Obama won that. And then I gave a PS5 out. Yeah. Someone won the PS5. Yeah, this was me. This was the first year I did summer camp. Look how different I look. This is me back in 2021. Yeah, 2021. We gave out a PS5 and an Xbox Series X. And this was when they were impossible to find these consoles. Yeah. We do a lot of cool stuff. So yeah, if you want to earn prizes, yeah, join our Discord. It's a nonprofit. That's why we fundraise, by the way. That's you'll notice there's a fundraiser going on. We fundraise because I like to buy cool prizes for students to like motivate them to like do well. And believe me, when there's a laptop on the line, they'll do everything to try and get the laptop. Like, you can't just sit around and do nothing and win the laptop. Nick, in that case, showed up to like almost every stream, participated in, like, we had a talent show, we had a bunch of tournaments, which bunch of like math homework and stuff. So yeah, if you work hard and do well in life and school, you win prizes and rewards, and that's how real life works. Yes, Bob. Almost 8 hours in. We're almost a third of the way there. Yeah, so young. That was me 4 years ago, I guess. I feel like I've aged like a decade. 1/3. Okay. In triangle ABC, the measure B is 90 degrees. Love that. Yes, I am doing a 24-hour stream. Yeah, we're 8 hours in. That's why it's called the 24-hour stream. This isn't a joke. It's for Giving Tuesday. Today's the day where people donate to charities and stuff. And we do have a charity. So if you feel like donating, you can do it on Twitch. You can buy me super chat, whatever, on YouTube. We also have a website. If you go to actualofficehours.com and click donate, there's a fun little donation page here. That if you want to donate crypto, they accept crypto. Anyone want to like drop some bitcoins? All the money does not go towards me. It goes towards our nonprofit being able to like buy prizes and fun rewards that again incentivize students to like do their homework and ask questions and learn and touch grass. We have all sorts of fun things that we have students do. Gold, if I get a gift card, I want to gift you a skin, so technically you'd be spending your own money. Yeah, I would be. Well, I'd be spending the nonprofit's money on myself, but I do fund a lot of the nonprofit myself. Um, 23 Pro says, last time I was in stream, you said you were going to stream around December because no one would join. Are you still going to... Oh, I'm going to stop streaming probably the middle of December. End of December. Yeah, because no one's really... I think what we may do is we may do some special streams to help out with college apps. But people don't need help with their homework. And that's mainly what this stream is for like helping people with homework. Yeah. Yeah, I do this from the goodness of my heart. Yeah. It's it's what I call the karma bank. I have a bank of karma that I just keep trying to deposit so I can withdraw it later. BD is an altitude. Okay, so this is D. So this is altitude means it does this. The length of AB is 15. Yeah. What you can definitely do AP Calc, River. You're smart. What, do you need me to like write a letter to your teacher or something? I can do that too. And the length of AC is 23 greater than the length of AB. Okay, so this is equal to 23 AB. Or let's call this 23X. Let's call this X. Yeah, my karma balance is negative. I definitely take some withdrawals over the weekend for sure. yeah, getting good at latex. I think getting good at latex is definitely worth it. 23 Pro. I think you can use ChatGPT to kind of teach yourself a little bit of it, and the best way to get good at stuff is to have a reason to do it. So if you have like a website you want to code, or say you want to like just take a moment to try to write your homework up in LaTeX, that's a great way to get good at LaTeX. PPGF receives the donation minus... Yeah, PayPal does take a little bit. I think the donation website we're also running through doesn't take anything, though. I think they ask for a tip, is what they do. You can choose to not tip them if you don't want to. Okay. What is the value of BC over BD? Okay. BC over BD. Okay, so these are inscribed triangles, no? Right? This triangle is the same as this triangle? I feel like it is. Let's see if that's true, right? You have a 90 and you have this. You have a 90 and you have this. AC is 38. Oh, you are right. Yeah, my bad. Thank you, Machka. All right. Oh, so we don't know this one. Dude, why did they just tell us it's 38? BC to BD. Okay. So that's the ratio of the hypotenuse to the side opposite C, which here is going to be... Okay, I got it. You have to make sure you have, like, your sides correct. Okay. So this angle corresponds to this side, but it also corresponds to this side in this triangle. Okay. So BC is the hypotenuse over BD. We don't know BD. But that has to be correspond to the hypotenuse of the big triangle, which is 38, over this side, which is 15. I think it's D. You guys think it's D? I think answer choice is D here. Yeah, 1 over 38 isn't an answer choice, unfortunately, Lord Jorgen.
You done messed up, Aaron!
This Red Bull's fucking delicious, by the way. What? I'm glad I got 4 of these. It's like muscles, you get stronger. Yes, that is true. I saw a pic of him at the gym flexing. Wait, who's flexing at the gym? Me? Nice, Jay Shan, what's up? Oh, when yes, yeah, I was. I'm missing out on 2 days of lifting today. My gym partner's very sad. I couldn't lift this morning because I had to start the stream, and I'm not gonna be able to lift tomorrow because I'll be up for 24 hours. I'm gonna go to sleep. Anyways, cool, good, fun question, KJ. I can't wait to get a job. I don't know, be kind of... I get it. It's awesome to, like, have money at some point. Oh, wait, I thought we did the answer to this one. Wait, where'd that other one go, then? 1 sec. So I can get my own Wi-Fi and my dad will stop glazing? Your dad's probably not wanting you to have Wi-Fi because he wants you to go do other things. There's always a reason for it. My parents would like hide the computer cord from me until I like read a book or I practiced the cello. Like it was kind of a, you know, a carrot type thing. I swore we did this one though. My dad makes me go outside, but if I have fun, I gotta go in. What? Oh, that sucks. You're having too much fun. A job puts food in your belly, but knowledge is forever. Yes. I try to always tell students this because I say getting a job while you're in high school is great, but not if it's at the expense of you doing well in school. Because trust me, like, whatever, the $10 an hour you're making working in high school is gonna suck compared to the $50, $60, $100 an hour you could be making if you just had better grades in high school. So yeah, don't get too focused on making money now, unless you're just bored and have nothing else to do, I guess. All right, let's see. This one's from Poisoned. I think this one's in Portuguese. Let's go translate it. I mean, also getting a job is cool if it's related to things you want to do. So, for instance, I had a job in high school where I worked in a biotech lab. And so that was great for my, college apps and stuff because I had lab experience. And also I learned a lot about coding. So that, and I wasn't paid very much. I think I was paid something like $9 an hour. It was very low wages at that point. A tutoring job is good. Yeah, that's a great job as well. That I would say is a great example of a job because you're also learning along the way. I'm saying, like, don't be super anxious to go, I don't know, work at Wendy's or something. Even though, like, I think everyone should have a service industry job at some point in their life to understand how people work. I tutor people with math for fun and pay once, $20 an hour. Nice. I charge $200, which I'm actually stopping because I just signed a contract with another place that I'm working, a new startup. But I had to do that because I was getting so many people asking me to tutor them, and I want to just tutor more for free. So the way to tutor more for free is just to charge a few people a lot of money so that I can go tutor everybody else for no money. So that was always my kind of like solution to it. And then I feel better about myself. I was ready to throw 200 at you. Yeah, don't. I don't let you. People ask me if they can have me one-on-one tutor them, and I say no. Like, I won't let you pay me. That's too much. The fact you need friends to survive college is potentially a myth? Alistair, what? Friends are great. Friends actually got me through college a lot. Okay. As a result of carrying out his practical work, the following equation for projectile motion was obtained. Based on this equation, determine the magnitude of the projectile's launch velocity. Oh, okay. So how this usually looks is x is equal to x naught plus v naught t plus 1/2 at squared. This is the general equation for it. So, looking at that, the term... And this should be y as a function of t. Your tuition's only $120 a month? Jesus, that's so cheap. Tuition here, they just voted to raise it again at UCLA. I think tuition is close to, what is tuition? I think it's like 20,000. UCLA in-state tuition, yes, 14K. Okay. Was that per semester? Per quarter? Wait, per year? Is that per year? That's actually pretty cheap. But yeah, if you're coming from out of state, it's 44.5. Oh, I see. Okay. It's just very hard to go to UCLA. You got a full ride scholarship for bachelor's? Nice. That's awesome, dude. That's dope.
That's dope.
Okay, this is the launch velocity because it's the thing that's linear with t. So you can say v naught is equal to 0.84 meters per second. The total horizontal distance before hitting the table if no thing was encountered. Okay, so that's just setting it equal to 0. So you just say 0 is equal to negative 0.82 t squared plus 0.84 t plus 0.23. This is a pain in the ass to solve by hand. I don't really want to solve it by hand, so I'm just gonna use a calculator. What's up, V Kenny? How's it going, bro? Yeah, out of state is ridiculous, Ryan. It is. Yeah, that's why some people will literally move or get like a PO box in the state that they want to go to college just to make sure that they don't get like absolutely like railed by the tuition prices. Thanks for the rose. What's the lowest age you tutor? On this stream, whatever the terms of service will allow you to be on. So I don't know what that is. I think it's 13 for Discord, maybe. Or is it 12? Australia just passed a law where, like, if you're under 16, you can't be on social media.
Discord for the United States is 13.
13? 13's like the general, like, online. I think if you're with a parent, you can do whatever, but
Yeah,
it's like
parental consent.
Yeah, it's like.
But Australia, yes, they did just pass a law that states that you cannot be under the age of 16 to be on social media.
Right? Yeah. Which I think honestly might be a good idea. I don't know. Social media is like kind of like toxic sometimes. We try to use it for good, right? We try to like help you guys out, put some math and science stuff on it. How much do I make live streaming? I don't really, not very much. I don't make hardly any money. Any money that this does generate just goes back towards the nonprofit. This is not my way of making a living at all. I have a bunch of other jobs I work. This is okay, cool. So T is equal, there's two solutions here, so you want the positive one. I'll post this for poisoned. You're 12 and you have Discord and social media? Cool, I can help you out then, for sure. We do everything from, I mean, earlier in the stream today, we had some really tough, like, college level, almost like graduate level questions. Like, if you look at some of the stuff we had, some of the stuff was, like, really, I mean, this actually wasn't too bad. This is linear algebra. But yeah, some of this stuff was, like, a nightmare, dude. What? Yeah. But then some of the stuff isn't so bad, you know? This is an example of, I mean, this was a great question. Thank you, Femistral. This wasn't too bad. This is kind of, I guess this is kind of high schoolish. But if you want to ask something like middle school, I'm more than happy to answer it. Actually, I would probably welcome it because it wouldn't require as much brain power as some of these other ones have. Yes, about 0.7. Yeah, so maybe don't say you're 12 too loud, I guess, so that the whatever, the algorithms at B don't try to, like, ban you. Okay, that was poisoned. Nice. Good question, poisoned. Yeah, 8th grade math and 7th grade. Cool. That's good. So are you in algebra, Willow? Or like maybe pre-algebra? Or is geometry 8th grade math? I forget which one it was. Anyone have the quadratic with y not 0? Wait. The quadratic equation is just x equals negative b plus or minus square root of b squared minus 4ac. Oh. What's wrong, Overcat? What are you saying, dude? A word? Okay. I was taking high school math in 7th grade. I basically had AP middle school. Wow. That's cool. Oh, ass. Okay, that's fine. You're in pre-algebra. Nice. Well, if you need help with pre-algebra, let me help you out. Just submit a question here to the queue. The website's actualofficehours.com. If you tell me, like, where your question is, I can try to, like, look at it. I'm trying to speed run through these so that I can get caught up to what we had. Oh, thanks, Laz. I appreciate that, dude. Don't feel obligated. Again, you guys are the students. You don't have to donate. It's more for people stopping by and being like, "Oh, wow, I like what you're doing." I'm like, "Cool. Help us do more of it." Okay. Rewrite the following into mathematical expressions. Use common names where applicable. Okay. The product of the radius and two numbers A and B. Is it just R equal... What? RAB, rab, the perimeter minus the sum of, so minus the sum of C. The sum of C and the product. The sum of C, this is interesting. The sum of C and the product of pi and 4 pi. Is it true math is easier with weed? I don't think so. I don't know. I can't do math if I'm like any sort of intoxicated. Some people can do it. I can't. I don't recommend it. Creative things are probably easier, but math to me requires like my like full focus to be able to do things. Don't do the Zaza. I mean, you probably think numbers are cool, I guess, but being actually able to do math might be a little difficult. The sum of the perimeter plus Euler's number, E, plus a number, N, the imaginary unit, I, and the side length, let's just say L. Okay, cool. Penile. God damn it. Did someone get me again, dude? You guys getting me with these questions?
You done messed up, Aaron!
You got me, dude. You got me. At least I didn't put S. I said penal. It's penal, not side S. The funny thing is, man, this looked so legitimate as a question, right? I was like, okay. That's fucking funny. Thank you, Joe. I appreciate the math jokes at least. That is a creative one for sure. Dude, that was very well masked. That's a very well masked question. Fuck, dude. It's a sneaky troll, Joe. At least I'm laughing from it. Thank you, Joe. I was wondering, I'm like, wait, what's the point of this math question? Mitchell says, we live in a society exquisitely dependent on science and technology in which hardly anyone knows anything about science and technology. True. That's true. Go back to my first question and find the product. What's the product? Okay. All right, let's see. Jeff, I think you were next on the list. You just keep submitting troll questions, though. They're funny. Yes, this. Oh, dear. Fun. Let's see. Pano? Oh, we agreed we couldn't do this one. I'm gonna mark that one. Okay, 1K. I think you're next. Nice. Okay, there we go. This I can do. You did. Right, I forgot to remove it. No, Carl Sagan's great, dude. Very cool guy. What is it? To bake a pie first, you must invent the universe? To bake a pie from scratch? Is that what he said? Oh, you want this on the ticker. Oh, my bad. How do I change the ticker? Where's my ticker, though? It's always kind of weird trying to find this. Stream Deck triggers. Where's the ticker? Oh, there it is. Okay. I'm getting the scroll bar for him. There you go, for Mistral. There you go. Okay. Chantel. Has a submersible pump in her basement. During heavy rain, the pump is turned off and on to drain water collecting under her house foundation. The graph shows the depth of the water below her basement floor in terms of time. The depth of the water decreased when the pump was on and increased when the pump was off. Is the function periodic? Does it happen with the same definite intervals? I feel like it is. Right? This happens after 8 seconds, and then this happens again after 8, and then this happens again after 8. So I want to say yeah. I think it is. At what depth does the pump turn on? When the depth is equal to 10, right? So once it hits 10, that's when it turns on. So at 10 centimeters. How long does the pump remain on? So it remains on from here to here, and then the water starts rising again. Oh my god, the answer to Joe's questions earlier in stream were 420, 69, and 69, 420? Wait, no way. Wait, how'd you figure that out, Machka? What? Wait, what? What were his numbers, Joe? That's a super deep troll. Wait, which one were Joe's questions? From much earlier? Wait, where did we do Joe's questions? Remember we did this. You got the product, but you never computed it? Was it this one? No. Which one was it? Oh, wow. Oh, it was the floor one. It was this. Oh, it was this? Oh, we never did. Wait. Yeah? This? Wait, I need to check this. Sorry. That's hilarious. 379 times 37 times 3 is 420.69.
Nice.
Wow. 5 times 20, 267 times 26. Dude, nice find there, Machka. Is 69,420. No way, dude. That's such an Easter egg. That's such a fun little Easter egg. Oh my god. Wow. That's a deep cut. All right, let's see. We're going back here. Okay, how long does a pump remain on? Well, it remains on from 6 seconds to 8 seconds. So that's 2 seconds. What is the period of the function? That's 8 seconds. Because that's how often it takes for it to repeat itself. What is the range? That's from 4 to 10. So that's 6 centimeters. What will the depth be at 3 minutes? Ooh, that's right here. So that's 7. Oh, yeah, sorry. Minutes, not seconds. I don't know why I said seconds. Yeah, that would be a fast pump, dude. What? Yeah, you're right. I was getting... anytime I see, like, meters, and I was like, oh, seconds, yeah. 3 meters is 7 centimeters. 3 minutes is 7 centimeters. When will the depth of the water be 10 centimeters? That's at 6 seconds. And 14 seconds. And 22 seconds. What will the depth of the water be at 62 minutes? All right, minutes again. Sorry, I don't know why I'm saying seconds. Sorry, minutes.
Yeah, get the baby voice on me. I need the baby voice. I'm making mistakes with this stuff. No, please. Sunbox, keep me honest. Keep me honest. What will the depth of water be at 62 minutes? Ooh. Well, I think we want to do like 62 mod 8. So 62 divided by 8 is like 7, remainder 6, right? Where's the baby voice? It's on. The baby voice should be on. Do you guys hear it?
It should be on. It's okay, Eric. Improvement. Yeah, he had an 85 in math. That's pretty decent, Eric. Good job. Oh, yeah, if you're listening through Discord, yeah, no, it's on Twitch. I can't get it to modify it through Discord. Thank you, I need to hydrate. Exactly, yeah. So, 6... Wait, 6? 6... is it 6 meters? Oh, 10 minus 2 minutes of water rise. Wait. What's the answer for E and F? E, I believe, was 6 centimeters. Right? Range refers to, like, the max minus the min. 10 minus 4 should be 6. And then, what is the depth of the water at 3 minutes? That's here. No. God damn it! Not again! Not again, dude. Not again. You all gotta stop. You're gonna make me go crazy. Oh man, I got hit again. Okay. Lock in. I think it's gonna be 10 centimeters. I did set myself up, yeah. I was like, wait a minute, why does 23 why is he wondering about E and F? Like, this is one case question. Got him! You did get him. Also, I need... $64 will be a max? Yes. Right, so 2 minutes back from the max. Wait a minute. No. 64 will be a minimum. Right, because it's every 8. Nice, Willow. You sent it. I'll look at yours next. Because I know you've been waiting for a bit. You're good, Jorgen. I mean, I could be making mistakes too. Okay, cool. I think we're good on this one.
Well done.
All right. Just tired? Yeah, believe me, dude, I'm tired. We're all tired. We'll get there though. We're gonna do it. I'm gonna probably go crazy live on stream, but I'm gonna do it. We're gonna get there. Okay. Let me see what Willow has. Willow, I'm gonna help you out. I need some nice questions before Jopastock's gonna like hurt me with whatever math Jop has. Okay, a grocery store manager tracked the cost of a 2-pound block of cheese since December 2020. What a time to be alive, December 2020. The line of fit models for the price based on the number of months since December 2020 is P equals 4.59 plus 0.03 M. What value of M would represent February 2022? And it's the months since December 2020, right? So, we can kind of graph this a little bit. So this is like what we call the y-intercept, so 4.59. And then this is a very, very small slope. So it's doing something like this. Okay. Yeah, so M is like what month would correspond to February 2022, all right? So you got to know a little bit about your months, right? So December, that's M equals 0, right? And then this was of 2020. So then January of 2021, that would be equal to M equals 1. And then we need to go all the way up to 2022. So we need to skip another 12 months. So that's going to be M equals to 13. Kids, don't do drugs. Yeah, don't do it. Mine is easy and fast. I'm totally not lying. You took clickbait. No, dude. And then we go one more month to February of 2022. So here, this was like plus 12, and then this is plus 1, and that gets us M is equal to 14. What month would July 2026 be? I wonder. No, Jeff. I'm not calculating that. I know what that number is. You almost got me. Okay. Okay, we'll get to there. Okay, use the equation to predict the price in February 2022. Okay, so that's P is equal to 4.59 plus 0.03 times 14. So that's 4.59 plus 42.42. So that's equal to what's that? 5.01. Yo, good luck, clickbait. Yeah, finals are coming up. Okay, predict how many months after December 2020 will a 2-month pound block of cheese first course cost more than $6? Okay, so now instead of figuring out the price based on the amount of months away, we're gonna figure out the months away based on the price. So this was my equation, right? I'm now gonna set the price equal to 6. I'm gonna say 6 is equal to 4.59 plus 0.03 M. Does this make sense how I set this up at least? Willow? Nice, much better grades. Eric there, good job. Make sure you post those. Post those if you have any good grades. Okay, so what I'm gonna do first, since we're trying to solve for M here, I look at what number is furthest away from the M, and we're going to do the opposite to it. So in this case, this is 4.59. That's the furthest away from M. And this is technically like adding to this, so I'm going to subtract from both sides. You do the opposite operation. So the opposite of addition is subtraction. This right here is going to get me 1.41. It's equal to 0.03 M now. Right? And now I look at the next number. The goal is to like get all the numbers away from the variable. So that's a 0.03. That 0.03 is multiplying. So we're going to divide both sides by 0.03. Okay. So then I need a calculator for this. So 1.41 divided by 0.03. M is equal to 47. Ooh, nice number. Okay, so we want to know, like, when that is, I guess, right? Oh, we need to know. Okay, so that's 47 months afterwards. So 47 months later. Which, this is pretty cool. Note that, like, 48 months would be 4 years. Because 12 months to a year. So this is 1 month behind 4 years. So that goes from December 2020 to December 2024, and then we subtract 1 month. And so that means it would be November 2024. Because this is like plus 48 minus 1. So now this is plus 47. Cool. All right, nice. Does that make sense, Willow? You can put it in, Eric. I might do it early. Oh. Yeah, this is a 24-hour stream. Nice. Okay, cool. All right, Willow. I'm going to post this in our Discord if you want to look at it. So, make sure, go join our Discord. Because all the questions that get done, this was you, Willow, number 9. Where is it? There it is. This is your question, and then I'm gonna pull the solution in for you. And there it is. And again, you can join our Discord the same way you uploaded your photo. Just go here to submit your screenshot, and then go to join our Discord. It's right there. Nice. All right. Yeah, and then here, I'll tag you in it. Willow. Is your name also Willow? Is it W Low Pillow? So I can probably see it. No. I'm gonna guess. Salem? Could be Salem. Or GG Rampage. I was just gonna tag you in it so you can see it. Salem, nice, Salem. Here, I'm gonna tag you in it. And then another thing you get, Salem, for why can't I tag you in this? I think you probably have to like accept the rules or something. Oh, this is it. Yeah, Salem Streeter. Can I tag you in this? What the hell? Discord? Alright, whatever. It'll figure it out. It's there. Alright, let's see. What's next? Oh, wow. What's this? Oh, my God. Let A be an unknown n by n matrix. Define its rotation 90 degrees clockwise as a to the r. An example of this operation would be that. Let A to the r plus B to the r equal B to the r A transpose, where A is the transpose of matrix A. Prove that AB equals BA. Huh. Norosky says this is cool. Yeah, you like this? Should I figure out what 90 degrees... I mean, we did this. We did what the transformations were. Where were they? I'm gonna go way back. There we go. I'm trying to study this type of matrix problem right now. Nice. It said anti-clockwise, counterclockwise, right? So, So, interesting. I'm trying to, like, see what happens here. This almost feels like a transpose, right? The rows are becoming the columns, but backwards. Let you talk? Eric, no, you have to have reasons to talk. What do you want to say, Eric? You're banned? What are you banned from? Why are you banned? I don't think you're banned. Doesn't let me... Yeah. Oh, on the chat? Oh, why? Do you have a timeout on you? Oh, he did? No, he's back. You got timed out, Eric. Yeah. Just you don't push the bot too much. It'll get mad at you. Cause look at this. This is almost like a transpose. If I wanted to do a transpose of, and let's say that's A, right? Rows become the columns. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see how this is? Oh man, it's close, right? Is it like transposed again? Let's transpose it one more time. 1, 4, 7, 2, 5, 8, 3, 6, 9. And then let's transpose it one more time. No, it just becomes itself, doesn't it? Yeah, duh. Ugh. Clean your mouth. Do you see how this is close to this? It's just, the rows are flipped. Okay. I want to know what, like, AR acting on A is. So let's look at that. So that's 3, 6, 9. Two, 5, 8, 1, 4, 7. Acting on 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just try to see what happens here. So this times this, what's that? That's not very nice, right? 3 plus 24 plus 56? 101? Right, 3 plus 24. Oh, plus 63, sorry. Oh, it's 100. Right? 27. 27 plus 63. No, it's 90. It's 90. Maybe there's a pattern here. If we do this times this, that's 6 plus 30. Yes, you can, Willow. You can totally get coins for putting in your grades. And then here you go. This is your question. And here, I'll give you points, Salem. You get a point for asking a question. Plus 30. 108. Yeah, it's nothing nice. I don't think it really works out nicely, does it? And 9 plus 36 plus 81. 126. Yeah. Okay, I don't think that does anything nice. It's close, though. I almost see how it's the transpose. What I wanted to do here... Oh, good job, Willow. Yeah, you get points for that. I wanted to do AR acting on A. Plus BR acting on A. And say this is equal to, like, BR A transpose A. And then I was hoping this would be something nice. But I don't think it is. Trauma bonding. All right, let's see. Let's see if Gemini has some stuff for us. I've been liking Gemini recently. I might start switching over to it, honestly. Solve and explain. Yeah, the transpose just moves them around. Yeah, we want to show that they commute. We can prove that BRAT equals ARBT by the symmetry of the left-hand side. Wow, this is getting very lengthy. One sec. Oh, okay, wait. You're saying that, oh, okay, wait. A to the R plus B to the R is equal to B to the R A transpose, but also B to the R plus A to the R must be equal to A to the R B transpose? Right, because this is just the what is it associated property? What is that? Commutative property of addition, maybe? Okay. So then if this equals it, so wait, B to the R A transpose equals A to the R B transpose. Can I transpose both sides? Can I do this? B to the R transpose A is equal to A to the R transpose B? Right? Because transpose is just the same? Yeah? Oh, I think we're close. I love how this all spells out like brat. It just spells out brat. And this I'm like art bat or something. You have to reverse the order on each side though, because AB transpose AB transpose is B transpose A. Oh, is that really how that works? Oh, okay. I didn't know that. Thank you. Okay, so you're saying if I have X, Y, and I transpose that, that's the same thing as Y transpose X transpose? That's a cool property I didn't know. Okay, so then this is A, BR. Nice. Nice, Fem. Thanks. And then this is B, AR transpose. I feel like I want to get this to be B somehow. Can I have them both act on BR, maybe? So wait, here's my next question here, Fem, real quick. If this is true, right? Then if I take the transpose of this, is this equal to B AR transpose? Maybe this turns into something. I don't know if I'm running in circles though. That's the issue. Transpose of the sum is the sum of the transposes. Oh, wait a minute. Oh, you're saying this is also... Ooh, I didn't know that. Okay. So this is BR transpose plus AR transpose. And then this is equal to, yeah, of course, like AR transpose plus BR transpose. I feel like we're just transposing things to death. Wait a minute. Wait. I think I see something. I'm wondering like how much I can get away with writing things in terms of algebra. Is this the same thing as BR transpose is equal to B AR transpose minus AR transpose? So is this the same thing as B minus 1 A to the R transpose? I'm tempted. Art. A to the R transpose. Okay, and then if I plug this back into here, right? So this is B, like sandwiching this. Is equal to A, sandwiching this. Does this, I mean, this is getting me closer, no? So then, AB minus AR transpose is equal to BA minus B BR transpose. Yeah, when I get true, dude, yeah. I feel like that's what's happening here. I'm unfortunately just gonna get 1 equals 1. But dude, I'm so close. I see like AB equals BA. I just want this shit to go away. How's it going now? We're in Struggle Street. BRT is B minus I ART. Yeah, that's what I have. I have this. You want me to plug that back in there? BRT is B minus 1 ART, which is B minus 1 I still got 14. Yeah, no. Well, I'll be here when you wake up. Wait a minute. Wait. Okay. I think Fem is probably onto something. We have this is equal to this. Right? And then ART is equal to this. Ooh, wait a minute. Yes. Wait. Okay. Yes. If BRT is equal to this times BRT, that means this must be the identity. Yes? Right? That's the only way for this to be true. Okay, wait. So B minus identity, A minus identity equals identity. I think we're gonna get it. Okay. So BA minus B minus A plus identity times identity equals identity. So this goes away, this goes away. So this gets me that A plus B is equal to BA. Oh, fuck yeah. Which means that B plus A is equal to AB. So AB equals BA. Oh, very nice job, Fembox. Fuck yeah, dude. That's great. Awesome. There we go.
Oh, we're so sorry to hear about your brother that passed away. He gets fine.
Hell yeah, dude. Oh my god. That was dope. Holy shit. That was so cool. That gets 5 big booms, dude. Dude, what is this? Okay, this was also Naroski's solution. Let's see what Naroski had. Nice, River. This is cool. I feel like there's a lot more going on here, but you did kind of get to the same here. Gold, what time are you going to sleep? I'm not going to sleep. I'm going to sleep in 15 hours. I think this is so cool that we still got to this. Just writing brat, like, just constantly. That's not very good for you. Yeah, it's not very good, but it's okay. This was a really fun one, Job, dude. Thanks, Job. Thank you, Fem, actually, for, like... My man! I needed to know this. This was important. I didn't know that XY transpose was Y transpose X transpose. No, I'm not gonna take a nap, dude. We're going 24 hours. Place... that. I mean, do people do that for 24-hour streams? That seems like it's cheating. I'll highlight this. So this was Narovsky's solution. Very cool. Or they film themselves sleep? That's kind of whack. No, we're gonna do shit for 24 hours. Don't pick up street vapes, Eric. Don't do that, dude. No. You don't know what's in that. Middle school's a lot. I have a quiz tomorrow for Math 7 semester exams in 2 weeks and another test on Thursday for civics. Oh no, dude. Taco Cat says, what am I going to do when it's midnight? I'm going to stream for another 9 hours. Yeah. That timer goes for 24 hours.
Yo, Gold.
What's up, Shaq, dude?
How long has it been, bro? I'm checking up on you.
Thanks, bro. It's been 9 hours.
9 hours? Damn, when did you
We're not at the
start?
halfway point yet. Oh, my neck's starting to hurt. I need a massage. Someone want to DoorDash me a massage?
When you start like 11, 12? Yo, what was that? What was that? What was that? No, damn, 9 hours?
9 hours, dude.
Yeah, well, at least it's more than 1/3 of the way, bro.
We're over 1/3. Can you DoorDash massages? If you pay enough, you can, I guess. I don't know.
You know you could DoorDash PlayStation controllers. So
yeah, you can DoorDash a lot of different things.
You might get a massager, whatever they're called. I prefer my government name.
Dude,
Bob.
Joe said, "I'm sorry, dude. Look at this." Thank you. No, Joe, you're fine, Joe. Joe says, "I'm sorry, dude."
Gold, I got a great math question for you right now.
What's up, dude?
It's
What's
gonna
up?
be like 5-10 seconds. Okay.
What's up?
Okay.
5-10 seconds. He says.
Okay. So a weapon, right? An AR, let's say, right? Does 30 damage, right? So you drink 6 mini shields and 2 big pots. How many shields do you take? Like, if you drink 6 minis, like at one time, you drink 6 minis and 2 big pots.
Wait. Let's get the images for this. Let's get the images for these, dude. we gotta make this look good. Here we go. It's the mini shield on Fortnite.
Yeah.
I want it, dude. There we go.
6
okay.
minis and 2 big pots.
We're gonna get 6 minis.
You drink them all at once, like in one.
You're gonna drink 6 of these, dude? 6?
So you drink 6 of them.
Dude, that's way too much. How much is a mini, dude? Aren't they like 25?
Uh-huh.
That's way too much shield, though, no?
Yeah, you have to finish the minis and the pots. You know, smallest to biggest, I guess, because it makes sense, right?
How many big pots are we doing?
2.
2 big pots. Okay.
Yeah.
Okay, 2 big pots. And then what's happening when I take all these shields?
You're about to get into a fight, so you need to consume all of that.
Okay.
How much shield are you getting? And you have to drink. You have to consume all of them. So
all right.
how much are you
1,
drinking?
2, 3, 4. So this is 100, right? Because they're 25 each.
Hmm.
This is another 50. This is another 100. So 250 shield.
No.
Wait, did I fuck up?
How you got 250?
Because
it's a horrible joke me and Justin made, but you can only drink 50 in one session. So how you gonna drink the other? You can only drink 2 minis. So how you gonna drink the other 4?
Oh, you have to go get shot. You gotta get shot a couple times.
Yeah.
Dude. You gotta take some damage.
So the guy's AR does 30 damage.
Oh, the AR does 30. Oh, like how many hits would you have to take? Oh, interesting. That's a good question, actually. Well, I would drink these first, right?
Yeah.
And then I would go take. Wait, but how much health do you have? You have 100 health, right?
Max health is just shields.
Okay, but I can drain my health, right? Oh wait, no.
Yeah,
Yeah, but it doesn't do anything to the shields.
But it doesn't do nothing to the shields, yeah.
Okay, so I need at least like 3 shots. That'll take me down to. Damn, this is actually funny. That'll take. Wait, 3 shots would take me down to 10 shield. Okay, so then I would drink another 3, which would get me up to 85 shield.
No, how you gonna drink 3 minis?
Oh, you're right. I can only drink 2. No, I can only drink. Fuck, I can only drink 1.
No, you gonna drink 2. And if you have 49, they'll still let you take 1 mini for that extra 1 shield.
Oh, really?
Max is 50 per 2 minis, yeah.
So I could take
two.
2 shield. Now I'm at 50 shield.
Yeah.
So maybe I should have. Oh, dude, Fortnite has such weird mechanics with the pots. Okay, so then I need to take another shot, just 1 more shot.
Yeah.
And then I can take a mini. Okay, so I gotta get shot 4 times.
Okay, but how much health and shield do you have? And then what's the remainder minis you have?
Well, you're done. You did all the minis.
How? Because you were 100, you took 3 shots, that took you down to 10. You took 2 minis, and you drank 1, so you have a spare mini left.
But then I take another shot. I get shot again. So then that drops me down to 20 health.
What's your full health and shield?
45. 45 shield.
And how much health?
100. Should have 100 health.
No.
Because we never went below the shield.
Look,
right?
Look, when you had 10, right, and you took the minis,
yes,
that took you to 50. You have to get shot twice to finish your minis. He hit you for 60, which means you wouldn't have 100 health.
Oh, I see.
Is that a good brain teaser? Should I get
this is a good brain teaser, dude. Yeah, this is a good one, dude. Oh man, what's up, everyone in the chat, dude? Okay, nice. 90 health. Love it. Okay, cool.
Yo, I'm gonna be so real with you guys. I don't think we ever had a Fortnite question, bro.
Dude, we've had Fortnite questions before. Let's see. This one's someone's asking a current and voltage question. This is a good one, actually. This is circuits. Y'all should learn some circuits.
Hey, do I look you get a coin for that?
Dr. Gold, can I get bond coins for being an amazing actual educator? Sure. And I'll give you one too, Shaq. That was a question technically.
Hey! Alright, cool. I mean, I only low-key, you don't really have to give me. Actually, yeah, I do want it low-key.
Yeah, I got you too.
But I only gave you that brain teaser to wake up your brain.
I needed to wake up. Actually, alright, I'm gonna do this question. I drank all this Red Bull, so I have to go to the bathroom. But I'll be right back. So y'all hang tight.
Hey, and we're gonna entertain the stream.
we're gonna do some we'll do some circuits in a second.
Hey guys. So who wants to come up here? Just don't say any like crazy slurs. I will get you down. Hold up. Wait, man. Wait, man. It's my first day modding for real, bro. Wait. Okay. I'm gonna let you up. Okay. Hello. I'm gonna let you up.
What's up?
I'm gonna let you up. I'm gonna let everybody up. Everyone's getting up.
Yo.
All up. Yeah, we all up.
Don't let Thumer up.
Why not Thumer?
Thumer, okay, fine. Let Thumer up.
What would he do?
Yeah, I don't really know why, but he's always like pissed whenever you say it. But when I say he's fine with it. I'm not inherently sure.
Thumer, come up, bro.
Wait, hold on. I'm gonna drink my yogurt drink.
Here, can I just bring Thumer up? No, I can't. Oh my god.
All right, intermission. What are we doing?
Let's talk. What are we talking? What do you guys want to talk about?
All right.
Let me think.
I'm still doing this one unsolved math problem ever since last
Eric,
night.
you got a request to get up. You got a request to come up and I'll let you up.
Yeah, anyone got jokes?
Oh my
y'all also gotta hurry up because if once gold come, I might have to kick all y'all back down. So
Wait, hold on.
freely, but don't go crazy, bro. Don't go crazy. Speak freely, but don't go crazy, bro.
Firms I can time out. Thumer, I'm gonna time you out.
No.
I'm
trying to
Yo, real quick, anybody in the stream, there's a Discord server you can join up and then, join the stream.
Promotions, bro. You're getting timed out.
Yeah,
What's
bro,
good?
I gotta take you down, bro. I don't know how to take you down, but I can server mute you.
There we go.
I'll just time him out.
Wait, who are you guys server muting?
Oh shit,
server muting River. Yo, I gotta go. Oh, y'all need to leave now. Y'all need to leave now. Y'all gotta go.
When you put everyone on the stage, dog.
Yeah. How do I take him down with that
Eric.
server?
Yo, Eric, what's up, man?
Move to audience. There we go.
There you go. Move to audience. Move them all back. Put them all back.
Yeah. My fault, Eric. My fault, guys. Yeah. Where's River?
Just don't get me banned on Twitch, please.
Yeah, I had to clarify that. River, I don't know.
Yo, what's up, Penn Center?
So when you come up, just let me know if you ever come up.
Everybody up. We're all up. I had to go to the bathroom and I had to eat some cookies.
Yeah, if you want to do self promo, just go to the bulletin board. That's it.
There you go. You know what's up. Bulletin board.
Hey, I finally did my job as a mod, bro. I've been mod for 3 years. I ain't do nothing till today.
Nice.
So.
The best of
First time
mods.
I've spoken in a gold stream. Alistair, come back on. Come speak to gold personally. Come on. You get up. I'm like Oprah Winfrey, bro. Everyone get up. Come on. Everyone's getting a chance to speak to gold. Come on. Get up. Speak with gold.
All right.
Chill out,
All right.
dude.
What's up, chat? What's up, gold?
Oh god.
Second time. Oh my god.
Everyone up.
Okay. Jesus. Alright. I'm gonna do some questions. Just got back from the brewery. I'm still on a dog walk, dinner, vacuum duty, but should be able to jump on VC later. Oh, thanks, man, dude. You're good, dude. Yeah, me and what was it? Me and Zach had a funny time doing all the like super hard math ones. I learned a lot about like set theory and all the different like symbolism shit. And what else do we do? All right, thanks, Shaq. Let's see what's in the queue so far. I haven't had anything like super crazy yet. I just did a really great one with this dude. Oh my god, this was kind of Fembox helped me out with this, but like linear algebra and stuff. What's up, Joseph? Yes, AFG. I'm in Los Angeles. You coming back from dinner? I just went to go to the bathroom and eat a cookie. I guess the mods let all the kids on the stage for a second. That's kind of funny. Please order me a cookie. Let's see. We got a circuits question coming up.
Good job.
All good. Cookie equals dinner. You heard it here. You heard it first. Shout out to Eric. Eric's a great guy. He does also math and science streaming. Or mainly math. You do some science though, don't you, Eric? Stay a little while.
Yeah.
Come in. The water's warm. Grace us with that. Dude, he's got a nice beard. Didn't Eric got a beard out of nowhere, dude. Eric's beard is dope. From what I remember. Should I write red on the blue? That would be a super annoying color to do, right? Green, can't even see it though. What about white? Ooh, yeah, we can write white. Oh, at least this isn't Germany land, where, what was it? The arrow, like, pointed towards the negative side? Here, what was that? This is what happens when I don't go to parties for too long. Dude, that's... Okay, the only way, Eric, I was able to grow this beard, because you're right, there is like a homeless phase you have to get through, was because it was over winter break, and I wasn't going to see anyone. And so I went through the homeless phase during winter break, and then I came out with a beautiful beard. Yeah. Alright, bye, FG. Good to see you, dude.
Bing bong.
I hate the homeless face. Yeah, you just gotta get through it. And honestly, I wasn't able to grow a beard until I turned like 30, 31. Exactly. No, we love you just the way you are, Eric. That's so true.
Good job.
Okay. This is fun. Wait, they give me the voltage of the source and the current of the source? Fascinating. I don't even know how that works, but okay. I see a loop. A beautiful loop. Well, actually, let's do it in like white, sorry. Or let's do it in yellow. Beautiful loop this way. So what is that? Is that just like VS minus I1 R1 equals 0? You might be still in the homeless phase. Huh? Got him! Someone wants to say current law. Yeah, well, I also know here, right? So current coming in has to be the same as like current going out. So 6 has to equal I1 plus I2, right? Let's do the white loop. Let's do this way. Is this right then? That VS minus I2 R2 is equal to 0? Ooh woo. What an interesting shape that's been created. Yes, very interesting, right? Yeah, okay, cool. Okay, so VS minus 2I VS equals 2I1 from this, right? If we just move that over. And then VS is also equal to 8I2. And then I1 plus I2 is equal to... Oh, okay, so let's just rearrange this then. Okay, cool. Got it. So let's say 4VS is equal to 8I1. VS is equal to 8I2. If I add these together, I get 5VS is equal to 8I1 plus I2. And then I1 plus I2 by whatever, the juncture current law thing is equal to 6. So 5VS is equal to 8 times 6. VS is equal to, I believe, 48 over 5 volts. Oh shit, the ideal resistance. Oh, I don't know about that. Did I fuck that up? Fem? Am I okay? I think I did it right now. Wait one sec, let me get my TikTok chat working. Troll Cats, what's going on, dude? How tired am I? I'm actually okay. I just did a Red Bull. Sorry, let me get my chat working on TikTok. TikTok's being dumb. I don't know why it's not showing my TikTok chat. Okay, there we go. Favorite streamer. Thank you, Trigonometry Boy. Yeah, sorry. Now they're coming through, Phenomenon. The TikTok, like, WebSocket thing fucks up on the chat every once in a while. Pen, I love you. Pen, you're getting much love today. Now wait, oh yeah, you could do that, right? Yeah. Let's see if we get the same result. I'm curious about that, actually. Yeah, you're saying I could have written this as... Yeah, let's do it. You're saying I have this, and then this is going into R1, R2. And this comes around. And so then this, 1 over R1 plus 1 over R2, inverted. So that's 1/2 plus 1/8. So that's 5/8. And then all to the -1 is 8/5. You're going to love my question, Gold. Love it, dude. Thank you. Okay. And then the voltage of the source. Oh, we don't know what the voltage of the source is. Oh, but we know the current of the source is 6. Got it. Okay. So VS is equal to 6 times 8 over 5, which is also equal to 48 over 5ths. Yes, nice. Okay, cool. We did it. Oh, it's the same. Wow, that's super dope. Okay. Okay, but it says the ideal internal resistance of a voltage source is... I think that's where you want the maximum power, right? Based and parallel pilled, yeah. Yeah. Oh my god. What is... I feel like, You want the maximum power, right? This is where, like... Oh, man. No. That was a question where, like, what should the resistance of the load be? The resistance of the load should match the internal resistance, I think, for the maximum power. I remember seeing this somewhere. I forget why it is. Infinity? No, you want internal resistance to be 0. Ideal internal resistance of a current source is 0. Okay, we know that. I think it has to do something with this, right? Okay. Blah, blah, blah. So power of the source is equal to IV, which is equal to IV, which is either I squared R or it's V squared over R. Is it 0 for both, though? Yeah, not the sources. E equals V plus IR. Yeah, because what happens when you have an internal resistance, right? Internal resistor, or whatever. You got, like, some little thing here. Where this is, like... Yeah, so EMF is equal to the voltage of the source plus IR of... This is the internal resistance. And they're in series, right? So if you want to maximize power, I think you want infinite resistance for a current source, and you want 0 resistance for a voltage source. Ideal voltage is 0. Yes. Yep. And then for a current source, it's infinity. And it has to do with this. So the power of your source... I don't think it's... I think it's this. I think if you want infinite power, more power, and let's say current is constant because it's a current source, right? Then in order to get the most amount of power, you want a very high internal resistance. If something has constant voltage, because it's a voltage source, then you want 0 resistance to get infinite power. I think that's what it is. You want to, like... Do we want to, like, Google this, maybe? Or, in this case, Gemini it? I think that's what it is. I remember they're different. Because like current sources are weird. We usually think about like I don't need Gemini 3 yet. I'll probably buy it at some point. You want a voltage source to be 0 resistance, but in real life there's always a little bit. Yeah. Okay, here's the explanation. The terminal voltage would drop as the current increased due to the voltage drop equals IR. Therefore, for the voltage to remain perfectly constant, the internal resistance must be 0. An ideal current source must supply constant current. If it had finite terminal resistance, some of the current would be diverted through this internal resistance instead of going to the external load, causing the load current to change with the terminal voltage. To ensure all current goes to the load, the path through the internal resistance must be an open circuit, which, corresponds to infinite resistance. Oh, wow. Current is infinity ohms because current should go in one direction and not backwards. Yeah, that internal resistance is in parallel, not in series. Oh, okay. Okay, cool. I learned something about circuits today. Nice. I think we all have a consensus on this, right? Whereas voltage source, the internal resistance in series, not parallel. Why does that change, by the way? It's just like how they're designed. It's how we design like a constant current source. We have to have like other things in parallel. Yeah. This was goats. The goat. Look at yours famished. Okay, I'll go check. One sec. Let me submit this one. Oh, what did you get for I1 and I2? Oh, sorry. We didn't actually get that, did we? Oops.
Disqualified.
Sorry, we just found VS. Sorry, sorry, I didn't actually do that. Whoopsies. Take that back. Okay. Sorry. 48, thanks, Goat. Sorry for asking this question. So, yeah. VS is equal to, so 48 over 5 is equal to 2I1. So I1 is equal to 4.8 volts. All good. Sorry, 48 over 5 is equal to 8 I2. So that's equal to 24. So 48 over 40 is equal to 1.2 volts. Yes. And then this is because, so this is constant I, this is constant V. So for this, you want R to equal 0. Sorry, R to equal infinity. Here you want R to equal 0. Cool. Peak. There we go, Goat. Okay. I put it in the Discord, by the way. So, Goat, if you're part of our Discord, it's right here. There's a solution for it if you want to take a look at it. We did it 2 different ways. I did it with, like, some loop laws and KCL. And then we also did it another way where, we just made that into a parallel resistor. Circuits are a little weird because current and voltage are related to the flow of electrons and the distance from a static charge. Oh, okay. Yeah, take a look at it, Goat. Yeah. If you need to know where to get to our Discord, just go here, click join our Discord. Will you be able to go the rest of the 14 hours? Hell yeah.
Good job.
I didn't set that timer for nothing. I didn't hear no bell. I didn't hear no bell yet. All right. God damn it, famished. What is this? No, there's no breaks. No, we're doing it straight. I mean, I may have some other guest appearances, like come help out and do questions, but I'm not leaving. I'm not going to bed. Famished, dude. What? Fuck. What? No.
Obviously, don't go and do that.
What is this, dude?
We can't condone anything of the sort.
No, we can't. Live!
God damn it. What the fuck is this famished? Okay. Millie with more. I do some trolling. I help. Yeah. You need help with Calc 3? Oh, cool. Yeah, ask it. Put it in the queue. Queue is only... What's the queue at right now? 11? 11 questions? Yeah. We're getting there. I may jump around if I just feel tired on certain things to just do some easy ones. I need some wins sometimes. We're approaching our record. Our record was 10 hours before this. And so in about 37 minutes, we're going to hit our previous record for the longest amount of time streaming. I've been doing this for 10 hours, not 9.5 hours technically. Yeah. We're doing 24 hours of education. That timer's going down. So, yeah. Yes, I love flux divergence. I've been doing a lot of it recently. Yeah, you are clickbait. You're next. Okay. Using theorems proved in class, find the limit as n approaches infinity of n plus I over n minus I. Fascinating. Sleep when you're dead, dude. Okay. I'm going to multiply both by n plus I, right? I just see conjugates. That's what I want to do. You're going to go to school now, Alistair? All right, good luck at school, bro. It's an imaginary number for sure. I should change my pants real quick. Oh, wow.
Good job.
About to get crazy, dude. Okay. So this is now divide the top and the bottom by n. Really? Can I do that? You think that's it? What's I over infinity, though? Is it also 0? Oh, Zach's still lurking. Zach says divide top and bottom by n. Okay, fine. This is the way? Okay. Okay, all right. We're gonna stop doing this then. Theorems proved in class. Yeah, what were the theorems? I don't know what the theorems proved in class were. Yeah. J is the engineering thing, right? Okay, so this is 1 plus I over n over 1 minus I over n as n approaches infinity. Are you allowed to just say this is 0? I mean, I know it's 0. I know anything divided by infinity is 0. Do I get the math god's permission to say that? Can I just say this is like 0? Can you use L'Hopital's rule? N is n an integer? Good question. Does it matter? Yeah, don't use L'Hopital's. He says don't do it. Isn't it 1? No, I's not 1, Joseph. Oh, is the answer just 1? I think the answer is just 1. That seems kind of silly, though. What are the theorems we proved in class? Should we go ask Gemini? Let's go ask Gemini. I think it's just that. Check the left and right limit. Ooh. Divide by highest power of n. Yeah, it just says the answer is 1. I'm gonna say, is there something special? Yes, the imaginary unit I is incredibly special. And the fundamental building block for... Okay. Here are the things that make I special. Yeah, I know I is special. Okay, but wait, no. In regards... Yeah, Gemini. Yeah, what? I know I is a special number, dude. Alright, Penn says, if I remember correctly, L'Hopital's only works locally, so you might have to flip this and have n approaches 0 to make the left hand LHS? LHR? What's LHR? Left hand rule? Left hand rule valid? I think you still get 0. Yeah, we've had some fun questions, Riley. Good job. You want a little like blast through the past? So we had some of this. Had some this was some matrices stuff we went through. Oh, L'Hopital's rule. Oh, thank you. We had a flow question. Someone was asking about fluid flow and stuff. I think you still get 1 too. This was interesting. This was Fourier stuff we did. We did some more matrices sets. Oh, this was a mess. Yeah. Some linear algebra. Yeah. We've done a lot of fun stuff today. I love that there's an abbreviation for L'Hopital's rule. Do you do organic? I have friends that do. Please submit an organic chemistry question. I have people who really want to go over okay. Okay, I think we're gonna call this one done. I call it done. If it helps to convince yourself, you can draw the complex plane of numbers on a diagram and see that the ratio should be 1.
Well done.
Both go to 0. Yeah. I think I see what you're saying. You're saying, for instance, if we had on the complex plane, right? So this would be, what is this? This is real. This is imaginary. Let's say, for instance, this is 1. And then this is like I over n, I guess? And so as n goes up to like infinity, you just keep like decreasing this down, right? And then this one, by the same virtue, also does the same thing. Narosky says, if you're still worried... Okay. Narosky did this. Oh. N plus I. Oh, so you did the complex conjugate way that I was thinking about. N squared minus 1 plus I times 2n. The real part is that. The imaginary part is that. So the limit is equal to 1. Oh, I see. Well, okay, wait. But sorry, you mean this goes to 0, right? Not 1. Yeah. I agree. Here, we'll fix the boo-boo. And this was the original way I was going to do it. I was going to break it out this way. But this also works. Cool. Nice. Awesome, Naroski. I appreciate that. This was Millie's. The next two are scary. Uh-oh. Alright, clickbait always gives me the fun ones. Naroski says, dear God. Alright, clickbait, what do you got for me? Okay. This is my work on it, but I am sure that there's a method I'm overlooking. I'm not sure about some of the logical steps, so a brief summary would help me if you don't want to solve through the whole thing. Yeah, maybe. Clickbait has such a difficult physics class that he's going through. I throw a thin uniform circular disc in the air so that it spins with an angular velocity omega about an axis, which makes an angle theta with the axis of the disc. Show that the magnitude of omega is constant. Look at the equation. Shown that, as seen by me, the disk's axis precesses about the fixed point of the angular momentum with angular velocity that... Oh my god. Dude, what? Okay, let's see what else he wrote. Okay. So omega was given by, I'm guessing this, omega naught cosine, whatever. Another omega. Uppercase omega bt. Plus omega naught sine omega bt plus omega 3. So then... Or maybe these are components? Yadavir is trolling. That's a hard JEE question. Disqualified. I'm putting a ban on JEE questions. I'm sorry, Yadavir. I won't do them. They're just going to get sent straight to the GPT slop machine. You guys are funny. Cool. This is equal to 1. And then, so if you do DDT, yeah, I guess assuming that these don't depend on T, right? Because you got rid of the T component. Sure, that's equal to 0. Awesome. Love. Okay, but then what's part B? Show that as seen by me, the disk's axis precesses. So we're talking about like you sitting right here. And then... this is what you see, and then this is the angular momentum vector, I guess, right? Omega is equal to omega naught cosine. Okay. And is this the omega that you as the observer see? They are components of the angular velocity vector with respect to the body's reference frame. Pink is W. Got you. That's this. Yeah, okay. No, this is physics. This is very hard physics. Brett, very hard physics. And then you want to show that it precesses with angular velocity, big omega s, (4 minus 3 sine squared alpha). Alright, let's see. Well, you had something else in here. Yeah, this is what you had. Oh, Jesus Christ. Oh, great heavens. This is all the work you did already for this? Oh, God. Here we go. Or this is the full thing you have. Clickbait, I gotta give you a lot of props for staying in this physics class. I would have quit by now. I would have like never gotten my PhD if this was the level of physics I had to do in undergrad. Normalize omega. Cool. Right. All right. We already found what omega was. It's equal to that. Okay. Rotational symmetry. I2 equals I3. Or I2 equals I1. Okay, sure. L equals I... I don't know if that makes me feel better. No, no. Dude, props, dude. Props for you, like... When you get through this, dude, this is gonna be the hardest thing you've ever done in your life. Trust me. dLdt is equal to 0. Isn't dLdt always equal to 0? Unless there's another force. dLdts is equal to 0. I don't know what the S and the B are. No, it's not JE, dude. This is just homework that he has in his class. Yeah, pretty nuts, dude. Okay, those cancel. And then you're left with those two components. Sure. Which, you say omega cross L has to be equal to 0? I don't know how to get to here. Yeah, how does it become 4 minus 3 sine squared alpha? I don't think this is JE, dude. This is just his teacher, dude. S is the inertial frame, B is the body frame. How do you submit something? Go to that website, actualofficehours.com. Just submit it. It'll get added to the queue and I'll take a look at it. This is common level of... Dude, how many people are left in your class? This is nuts. So what are these equations actually, by the way? The result... What are the results of these? Were these useful somewhere? No, yeah, JE just is traumatic. Here, let's throw this at chat. I want to throw this at chat. Come here, ChatGPT. Less than 20, dude. I imagine so, bro, dude. Holy shit. This is a very hard. To ChatGPT if he gets it, yeah. We're gonna put it on thinking. We're gonna put it on the extended thinking. Tries to catch the question, realizes it, dude. I don't know. Do you think you can do this, Zach? This is just nuts. There's a lot of physics in this, dude. I never did like moving inertial frames on like rotating shit, dude. Like what the fuck? Get out. Get out! Yeah. Physics is great. No, physics can be really fun. I think, unfortunately, stuff like this tends to, like, beat the fun out of it. Is this doing a diffie-Q problem using a linear algebra tricks? I can't get away from it. JXNet, we did some of your fun ones. Which ones did you have earlier? I'm trying to remember which ones yours were. We did this one. Where was this one? Whose was this? Oh, this was Topsky. feel we did another one of yours, JHNet. Wasn't the head loss one? Wasn't that one? Oh, we did these with you. Oh, never mind. That's right. You gotta go, Joseph. What's your name in the queue? I'll take a look at it real quick while chat like tries to do this. It's going. It's on the extended thinking mode. JJM? JJ Abrams? Alright, let's see. What do you got? Ooh. Okay, math gods. Alright, while we wait for chat to help out clickbait on this one. Let's see if we can do this one real quick. Let f of x equal some nasty ass limit, dude. Yadavir, yes. I think yours is also. This is also kind of ridiculous. So I know these. This is really hard stuff. I have kind of a ban on JEE questions. I don't do JEE questions, especially not during a 24-hour stream, just because I'm gonna kill myself. Literally, I'll literally kill myself if I have to do that question. My attempt at memeing failed. I think this is just like an order problem, right? This reminds me too of Elementary University. This reminds me of just like very difficult things. Okay. Because I think like, is n to the n bigger than n factorial? Which is bigger than like which is bigger than 2 to the n, or a to the n, which is bigger than n to the a. I think this is an ordering question. Excuse me. So this will beat this out. Let f of x equal the limit as n approaches infinity for all this, then oh, but interesting. Wait, how do you do like 1/3 factorial? How does this work? How does my hair look without the caps? This is my hair. It's still there. It's a gamma function? How the fuck do you do a gamma function? Dude, what is this problem? I don't know. Everyone's always like, hey, can you do my question real quick? I have to go.
Surprise, motherfucker.
It's an integral. Google it. Okay, I think this is always increasing. Just look it up, it's not too bad. What, if I literally just Google this question? It looks like it's one of those like troll questions. Where... Oh, you're talking about the gamma function is not too bad. It's on Stack Exchange. Asked 6 years ago. Put xy is equal to k. What? Oh, fascinating. He notices that this looks like a series. Maybe? Gamma function is just continuous factorial nightmare fuel. Oh, nice. Nice, Narowski. It's not a series unless you take the log. Yeah, he takes the log down here. That's what he does. Oh, okay. Wait, because what's the series of ln? ln is equal to sum of x minus 1 to the n over n factorial. Is that kind of what's happening here? Geometric series. Okay, cool. I got you. On Stack Exchange? Oh, it says which of the following are true. Apparently B and C are true. Put XY is equal to K. Sorry, I want to understand why this is. Yeah, it looks like the limit definition of a Taylor-Maclaurin series. So let's see. Let's see if I understand why this is. So, so what does he do here, sorry? How do we get n to the 2n? Are you just multiplying by n to the n? No, wait. N to the n times that. N to the 2n, right? Yeah, okay. Decide by n. Oh, wait. I think I see what I think I see what's happening. Divide by n. Yeah, he's pulling out an n squared here. Yeah, factor out. Well, you factor out n squared, and that's how you get x squared over n squared. Got you. And that's how that becomes x over n squared over 1 over n squared. Okay, cool. And then let me see what you're doing here. So then you're factoring out an n from here. Right? Okay. How does it become n to the 2n, though? Because that's n times n to the n. So then everything should be 0 over n. Correct. Yeah, I think that we're saying, right? Right? This is 0, this is 0, this is 0. But then you also have this. That's the issue. You have like infinity times 1 over infinity. Cancel. Oh, sorry, they're all multiplied. Oh, I see. Thank you, Zach. Yeah, sorry, these are not like plus. These are all multiplied. So I have to factor an n out of every single one. So I'm factoring out an n to the n. Okay. And then here I'm factoring out an n to the 2n. Oh, brilliant. Okay, got it. My 10 hours of tutoring brain. Okay, got it. Because these are all multiples. So you have to factor out an n to the n, because every single one of these gets an n pulled out of it. Okay, cool. So then we get to here. I agree with this. Only 14 more to go.
Good job.
Okay, so that's this. Okay, so then let me try to understand what's happening here. So then he takes the ln of both sides. Because ln of A over B is the ln of this minus the ln of this. Oh, wait, and the 2 to the n's cancel. Nice. Thanks, you gotta go. Bleep. Okay. Alright. I think I see how this works. Okay, so then that's this minus this. Okay, cool. Which... Is this telescoping then? This is telescoping, right? The 1 plus R minus 1 plus R? Wait, where's the Y coming from, dude? What? Oh, okay. Oh, because that's how he's doing the summation. Oh, wait, 1 sec. Oh. One sec. Okay, he pulls an ln. Oh, it's... Well, first of all, there's... Wait. He just added the fractions. Thank you. Okay, I think I get it. Yes, okay. He just added the fractions together. Okay. And then he says, okay, well, I can write this as an integral. Should this be from 0 to 1, though? Shouldn't this be from, like, 0 to n? Why is he saying 0 to 1? Where does the integral come from? Yeah, he's converting this into this. Oh, I think I see what's happening. This is the same thing as the integral from 0 to infinity of 1 plus Rx over y dy. Or he says definition of a Riemann sum. And I think, okay, yeah, no, I like the definition of the Riemann sum argument better. Wow, this is such an involved question. For someone to drop this on me and be like, oh, hey, yeah, I'm leaving. Dude, what? Fuck, what? Yeah. Where's, like, the fun way to look at this, though? I want one with the deltas in it. Yeah, this is what I want. Here we go. Yeah, this is it, right? So the sum from A to B of f of x dx is the same thing, or is it the integral of f of x from A to B is the same thing as adding up A plus I? What's this I, dude? What? Oh, I is like which number it is. Right? Okay. In this case, this is R. R equals I. You see how this is R? And then in this case, B is equal to 1, A is equal to 0. So then you get I don't like the ith terms. Yeah. And then this is the delta. Isn't A equal to 11? A is equal to 1. Yes. Well. Yes. So B is x plus 1. Wait, this is equal to R. Also, wait, this starts at R equals 1. Wait a minute. Wait, no, yeah, wait. This is wrong. Because we have to do it starting at... They have that one starting at 0. I don't think I want the 0th one. There's a nicer way to look at this one. I know Zach also says this. This is actually technically correct. But I remember like kind of seeing it. Yeah, okay, here we go. Flamingo math. Let's learn with flamingo math. Okay. It's it's k delta x plus a b minus a over n. Okay. So in this example, b minus a is 3. So let's look here what we got. Is this the over n maybe? Oh, I see. Oh, this is poor. This is poor. This is, sorry. This should have said, you want the 1 over n in there. Okay. Now b minus a is 1. So that's, okay, got it. The 1 over n here. Red Roach. This right here needs to like come inside. So now I have, yeah, this is poor form. You shouldn't have done this. K delta x plus a. In this case, a is equal to 0. Delta x. Yeah, delta x is x over n. Wait, no. Delta x is just 1 over n. So that means delta x is equal to 1. Oh, okay, wait. Oh, I see it. Yeah. Correct. I see. I think I get confused where this is. Okay, the K is the R. Uh-huh. Okay. I see it. This is Riemann. And this is x squared, y squared dy. There's just so many variables floating around. Okay. All right, so we get to here at least. We agree with this? I think I kind of see this, Red Roach, right? I see this enough. I can believe it. Okay. Now he says, like, let x, y equal to k. Oh, you don't? No. Okay, well, let's see it. Sorry. I want you to see it. I want to see it too. There you go. Let's say this is the sum. I'm going to use k here. K equals n. And then we're going to say ln of 1 plus k x over n. And then this is 1 over n. And then this is the form, right? Because this right here is like delta x. This is delta x. Okay, let's put different colors. This is f of k delta x plus a delta x. This here is delta x, which means that b minus a is equal to 1. K delta x has to be here. See how this is K? It's actually interesting. It's KX. 1 over n. Oh, I think I know what's confusing us actually, by the way. It's because the x is in the this is f. This is not supposed to be x, sorry. It is f of x. But in reality, treat this okay, sorry, I want to write it this way. This is what I want, sorry. It's f k delta y. The issue is that x is also a variable being used to define like the function. F of x is equal to this thing. Yes. Well, no, it's actually dy is going to be the integrating variable. Because watch, this is k delta y plus a, and then this is b minus a over n, where this right here is delta y. Oh, okay, Red Roach, got you, okay. So this is kx, and then this is now delta y. Okay. And then a in this case is 0. Or we could say, wait, where does that 1 come from though? Fuck. I feel like it should be like from 1 to 2 then. Oh, wait, okay, wait. F of b is equal to 1 plus... Nice, River. Ugh. Yeah, okay, sorry. My brain's hurting too much to get this one. Oh, we've now surpassed 10 hours. That's the most I've ever streamed. And yes, okay, let's just assume this is right. I think he may be wrong here. But let's just try it. Let's just try the next part, what he said. He said, put xy is equal to k. I'm serious about this, dude. I'm a man of my word. But then how does that help solve that? That's ln of 1 plus k, but then what does dy turn into? Wait, so y is equal to k over x? So then dy is equal to negative 1 over x squared k dx? Well, that's not good. Remember, x is just a constant. Yes. Well, technically it's a variable. Okay. So dy is just equal to 1 over x. Trees that. Okay, cool. Thanks, dude.
Oh, yeah.
Yeah. Wait, what did this one? Oh, dude, this one's still trying to think. One sec. I was trying to help you with this one. Okay, dy is 1 over x dk. Oh, I see. And then there's an x out here. Okay, so that's going to go away, right? So you have the integral of ln of 1 plus k dk. But then, sorry, what's the... Is this where you're supposed to take the derivative of both sides, maybe? And then this is minus integral ln of 1 plus k squared dk. Maybe you can combine these. So this is integral ln of 1 plus k over 1 plus k squared dk is equal to ln of f of x. And then, are they taking the derivative of both sides? No need, man? Okay. Tell me, Red Roach. What do you do next? Actually, I don't know. I'm curious about this one. But put in the bounds? Okay, sure. So if y goes from 0 to 1, then doesn't k go from 0 to x? Right? 0 to x? They're saying you get this. You get f prime over f of x is equal to... Oh, wait, whoa. I see this. Right, because this was equal to the ln of f of x. And watch this. If you take ddx, this is going to be 1 over f of x, f prime of x, and then derivative of this, fundamental theorem of calculus, right? That's ln of 1 plus k over 1 plus k squared. Right? I'm correct? Oh, we're getting close, baby. Okay, so f prime of x over f of x is equal to the ln of 1 plus xy plus 1 plus x squared y squared. Why should it be x by the same? Oh, because yes, I fucked up. Sorry, because when I take the fundamental theorem of calculus, I take the derivative of an integral, that just goes straight in for k. Yes. Got it. Yeah, get rid of the y. Got you. Okay, cool. So then that enables us to answer these questions, I guess. Sorry, what? Let's see. Okay, so let's see. So then f prime of 3 over f of 3 would be the ln of 4. Ln of 4 ninths. Oh, wait. Oh, this is all topsy-turvy, dude. Oh, I see. Yes. So ln of 4 over 10, is that greater than or equal to the ln of 3 over 5? Yes, because this is more negative than this, right? Wait. No, fuck. Wait. If I plug in 3, right? I get 4 over 9, 4 over 10. If I plug in 2, I get 3 over 5. Is this true? I think, what's... Yes, wait. This is 6/10. Wait, but the closer you get to a negative number, the closer you get to 0, the more negative the ln is. So this is false. Wait, I don't think D is true. What do they say? You got it? Yeah, so A and D are false. Okay, good. You said B and C are true, Narosky? So I agree D is false. F of a third is less than or equal to F of 2/3. Yeah, okay, let me look at it. I think this is cool that we got to this at least, but I don't know how that helps us answer the other things. So let's see what Narosky had. Narosky, I love your signature, by the way. This is super fun. This is really cool. This is pretty dope. Alright, let's see. Okay. So, yes, you identified it was product sums. You pull it out. You factor it out. Great. You got to this. Okay. I can try. Yeah, that's kind of nice, actually. Okay, so then g of x be the ln of f of x. Cool, so that's what you got. Okay. I like that you use dt, by the way, instead of dy. Jesus. Yeah, start... Yes. Dude, this is so nice. I love the signature you have, Narosky. I like the DT so much better than the DY. Okay. U sub. Oh, you have the whole 1 plus xt is equal to u. Okay. U just equals xt. Oh, okay. Is this integration by parts you're doing here? Where are the numbers? Bring me back to numbers, dude. All the symbols are hurting me. Yes, okay, that's integration by parts. Okay, cool. So, integration by parts. Fun. Yo, what? Where are you getting, like, arctan? Oh, Jesus. Oh, because that's what happens when you integrate this one. Okay. This is beautiful, Narosky. This is so much more. I'm not going to do all this. This is too much.
Oh, no.
I'm glad we got to hear, though. We did get to hear at least somehow. X between 0 and 1 plus like, okay. Oh, okay. It's decreasing. Okay. X is in 0 to 1, and then when X is in... Yes, okay. I got you. Oh, because f prime of x is equal to f of x, ln of that, and... 1 plus x is greater than 1 plus x squared. So that's going to be greater than x. Okay, so if the yeah, okay. F is decreasing. Can I help? What's the problem? Something very tough. Okay, I see what you're talking about. Okay, cool. All right, I'm marking this as done. Very cool solution, Narosky. Thank you. I appreciate that. Who's that? This guy, JJM. JJM was like, I have to leave. Can you do my question really quick? And I was like, yeah, sure. Doesn't look that bad. And then proceeds to take me like 40 minutes. JJ, dude. Okay. Let's post that one. It was tough stuff. Like, yeah, man, that was a heater, dude. Especially for me in my 10th hour of teaching. Yes, my solution would have worked as well. I should have noticed the boundary conditions here, right? On like 0 to 1. Like, the second like x is greater than 1, then this starts becoming bigger than this. You'll get to integrals, not bad. Okay, this was JJ's. With super help from Narosky. Thank you, Narosky. Okay, I need to feel better about myself, so I'm gonna help out with Stereo real quick with this question. That one just like hurt me so much. Okay. Take me home, country roads, dude. I just want to do law of sines and law of cosines. I got seriously hurt by that one.
Oh shit, not good.
Oh man. Also, dude, it stopped thinking. Don't stop. Go help. Go help. Go help. Don't stop. Why'd you stop helping? What level is this math? This is like high school. I'm giving myself some easy ones. I'm doing this one. Oh my god. I just got We're not even halfway. We gotta get to halfway at least. Oh, the other one? Oh, the other one's like super challenge math. I don't know what that is. That's just like nightmare fuel stuff. No one would do that in a regular class. That's like a competition question. Okay. Decide whether the cosine rule or sine rule will be used to calculate the value, then find the value of x. Here's my rule for things. So it depends on like what you have and missing. Okay? Or like trying to find. Let's say like trying to find. If it's 3 sides and an angle, that's law of cosines. If it's 2 sides and 2 angles, that's law of sines. I actually have some really good videos on these, Wisteria, if you want to go check them out. It's on my TikTok. Where is it? So many things today. Yeah, here. So here's, for instance, the law of sines.
Law of sines is off.
And then I think I have one also for the law of cosines. I think I just have the law of sines, because law of cosines is like great. The law of sines you have to be tricky about, because you sometimes have to do like pi minus the angle to get the right one. Nice. Narosky says, if the queue clears up, I have a ton of fun math for you in the chat to choose from. I'm author, co-author for most of them, so I can actually give constructive hints. Lots of stuff is very informative. Love that. You said you like puzzles. When we did that physics question, it got me thinking. Yeah, I do love puzzles. Let's see how I feel. Let's see if I'm in a puzzle mood in a couple hours. I may be just fucking tired. But also this is, I like, you know, these are fun and we are learning along the way, which is great. Love that. Okay. Yeah, yeah, but we can do them another stream, Narosky. If I'm not too tired. Let me just see how I feel. I would love, yeah, I love fun little puzzle questions. Okay, so this is, look, 1, 2, 3, 3 sides and an angle. This is law of cosines. 2 sides, 2 angles. This is law of sines. 2 angles, 2 sides, law of sines. 2 angles, 2 sides, law of sines. 3 sides, 1 angle. That's law of cosines. This is also law of cosines. Okay. So make a little bit more Wisteria, like which ones to use. Now here's a cool thing though. I want one where there's the ambiguous case. The puzzles one is fire. I love number 3. Okay, I'll take a look at it. How long will he sleep after this? I'll probably sleep like 12 hours. Although I don't think I can, actually. I think I have to teach like 8 hours later. Unless I just start canceling all my clients. Like, sorry. Dr. G's out. Okay, so I'll do one of each just to have fun. Okay, so here, I'll do A to help you out, Wisteria. So, law of cosines says that c squared is equal to a squared plus b squared minus 2ab cosine c. Yes, the ambiguous solution, River, is when you have law of sines. Yeah, law of sines. And then it's when the angle like needs to be obtuse. Okay, so for this one, you have x squared is equal to 11 squared plus 15 squared, right? So this is always opposite the angle that you have. Okay, so that's the x squared. And then a and b are the other two sides. Order doesn't matter. Minus 2 times 11 times 15 times the cosine of 97 degrees. Okay, so then you can just do it on your calculator. Let's do it up. So 11 squared plus 15 squared minus 2 times 11 times 15 times the cosine of 97 equals that, and then square root it. Have I done Yadavirs? I'm gonna pass on it. I don't do JEE questions. They're banned. I do not do JEE. Especially not 13 hours into a stream. I don't. Sorry, not 13. Sorry, we're only 10 and a half hours. I apologize. Okay, 19.65. This one's easy. Good. Let's do a law of science question. What is JEE? It's fucking nightmare fuel. That's what JEE is. Nightmare fuel, I swear, dude. Where's law of sines where you need to find the angle? That's where it gets tricky. Which none of these actually have that. Law of sines with the ambiguous case is when you have to figure out one of the angles. Yeah, so JEE is an exam that people in India have to take to like try to escape poverty. It's a very competitive exam that like everyone in the country takes, and the top performers get to go to like college and like actually live their lives or something. And so, as you can imagine, India has a massive fucking population and huge wealth gap. So, and also, I mean, very smart. I mean, yeah, the country, like these JEE questions, I can't even do. They're insane. So, because there's so much competition for so like few slots to go to like universities, they make like the most ridiculously difficult exam for you to try to take. And we've been over this before. Like JEE really just tests how much time you're willing to put into just memorizing ridiculous fucking tricks and solutions and stuff to like everything. I don't know if it's necessarily a measure of like how intelligent you are. I mean, you definitely have to be like somewhat intelligent to do these questions, but a lot of times it's, do you know like this random obscure 100-page proof trick to do this problem because you've seen it somewhere else. It's the worst. It beats the living shit out of like fun. Do we like 3D geometry? I've been doing a lot of it recently. Okay. Yeah, let's just do B. Where do you teach? I've taught at UCLA. I don't currently teach anywhere right now. I'm about to actually start taking up a job somewhere else, so I won't be teaching. But I will still stream. I'm not gonna leave you guys. His question was mostly just using angular momentum equations. Sure. I just know it's a nightmare. And I don't want to be bamboozled anymore. I just have a general, I have a general ban on JEE questions. There's enough YouTube videos of people doing these, and bro, they're like 20-30 minutes long. And I'm not going to figure it out in 20 or 30 minutes. It's going to take me like hours. Okay. So you just got to do this. This is nice. I like this. This is cozy. It's like cozy math. You know when like people talk about like, oh, I'm a cozy gamer, because they don't really play like any sort of intense game. It's just like fucking, what is it, Animal Farm or something? Or no, that's a movie. Sorry. What's it called? Animal Crossing. Animal Crossing. Or Stardew Valley. Yes, these are all examples of like comfy gaming. This is comfy math for me. Like, I like this. This is nice. Okay. Animal Crossing neuron activated me, yeah. Okay, cool. Alright, that's an example of law of sines, law of cosines. Oh, yeah! Hope that makes sense to you, Wisteria. Wait, with JEE, is it where you just do Newton's method and a left-hand side, right-hand side, and then just get really good at guessing? I'm a physicist. By trade. My degree's in physics, but I do a lot of math. I'm slowly becoming a mathematician as I hang out more with these math people on Twitch. Zach turned me more into a math person today. I learned more math today than I learned physics. Yes, I can definitely do trig identities. Submit that shit, please. What do I specialize in? I mean, my PhD was in plasma physics. Nowadays, I mainly teach like high school or undergrad level physics. Is Rust a comfy game? I don't think Rust is. Okay. Let's see what else we got. Also, did this figure it? Okay, nice. Dude, dude, look at this. Look at this. Clickbait. I went in on it and I said like, don't fucking stop. Like, did I hear the bell?
You're not that guy, pal. Trust me. You're not that guy.
Yeah. Oh, what's up, GetFit with Arian? Actualofficehours.com. Just submit your screenshot right there. We'll do it. So I told it like, don't quit, and it was like, nice one. This is a sneaky problem. Let's go step by step and not bail out halfway. Good job, chat. Had to think for 4.5 minutes though. Wow. Okay, there's a lot of stuff going on here. But I think maybe it got to it. There you go. This doesn't look too bad. I don't know exactly what's going on here, but I'm going to send it to you. What is this problem? This was a problem asked a couple times ago. It was clickbait. So if you go to the queue here, this was clickbait's question. Pretty advanced physics mechanics question. You can always see everyone's questions that are being submitted. And then here, I'm going to post this one in the Discord though. It doesn't look too bad. Do I do mech-y? Depends. If it's like statics, yes. If it's like mechatronics, like no.
You done messed up, Aaron!
There you go. But I'm gonna post this for your clickbait. I would try to understand it with you right now, but my brain is not in the mood. I mean, it doesn't look that bad. More like gaslight GB. Did it gaslight us? Let's see. I'm just curious, actually. With no torque, the Euler equations in the body frame are this. You're gonna still be streaming after I wake up? Yeah. If you wake up in the next 13 hours, which we hope you do. That'd be a lot of time to sleep for 13 hours. For symmetric top, I1 equals I2. Okay, so then it gets to this. From the third equation, omega 3 is constant. So then look at the time derivative. Uh-huh. And then use Euler's equations. So use this to replace omega 1 dot. You get this, you get this. And then from the second one... Okay, you can combine that with that to get this. So therefore, omega 1 dot plus wait, whoa. Where did this step go for this step? Excuse me, what? Oh, wait. I see. This plus this does equal 0. Oh, very cool. Okay, that's actually kind of cool. It does it. Sorry. Okay. What was your username? Oh, Arian? Okay. I'll take a look at it. I just want to see this real quick. L is I omega. And then it puts some fun little components on it. And then, L squared is L perp squared plus L3 squared. Okay. Hence, sine of beta is L perp over L is equal to that. This is kind of what you wrote, right? Omega cross this. Omega cross Z is dz dt. Wow. This is nightmare fuel, dude. Holy shit. Okay. What's up, AFG?
What's up, Dr. Gold? I had a question.
What's up, bro?
I wanted to, I need help on, some, triple, should I just put it in the office hours queue or no?
Yeah, just put it in the queue. I'll get to it. I'm hopping around the queue, honestly. I'm trying to go in order, but I'm kind of skipping around, depending how happy I feel.
Yeah, I thought office hours was ending 6 p.m. I thought.
No, office hours ends in 13 hours.
Oh, actually, you're streaming the whole time?
Yeah, I've been streaming. Yeah, we're streaming for 24 hours today.
Oh, bet then. Okay, thank you.
Yeah, so just add it to the queue. I'll get to it at some point, as long as you're up.
Alright, bet.
Okay. All right. Let me see here, because I some people have asked questions 3 hours ago, and I don't know if y'all are still here. But so I'm gonna hop around every once in a while and just help out someone who asked a question just now. What's up, Arian? I'm gonna do yours right now, just because I feel good about this one. I do need. Thank you, Sam, with another hydrate today. Is this before or after you went to class or something? So, Arian, it's your lucky day. Second to last day, buses run normal time, and it's a half day, so it's a half a day free. I am. Okay, if I completed the problem, where can you submit the answer? The Discord, Jake. if the question's already in the Discord, if you want to join the Discord, again, I highly recommend it. Go to actualofficehours.com, and then go click join our Discord, and then it'll be in this channel. All the questions we've done so far will be here. If the screenshot hasn't been posted yet, it's because I haven't gotten to it. But feel free, if you have the screenshot for the question, you can just post it as a new channel thread thing or something. All right, let me help him out real quick with this. Okay. Prove each identity. Nice. I think I want to like turn these. Why does Thumer only get pissed? Whatever you call. I don't know. Okay. Okay, let's just do A. So, sine squared theta is equal to 1 minus cosine squared theta. Okay. Use this identity. It's great. Cosine squared plus sine squared equal to 1. So I can now rewrite. Use Zach's formula. Thank you, this is, bro. Always looking big. I didn't go to the gym today, unfortunately, because I started streaming. We're going for 24 hours today. 2 cosine theta minus 1. So all I did here, Arian, is I just replaced this with this. And then underneath here, I'm going to get 1 minus cosine squared theta plus 3 cosine theta minus 3. Okay, here's the cool thing. I got 1 minus 1. That goes away. And so now I'm left with 2 cosine theta minus cosine squared theta, I think. Up here. And then here. Fascinating. What do we got? I think I'm eventually actually just want to like take the negative out or something. Let me think. 1 minus cosine squared theta. 1 minus 1. Yep. Okay. We are going to factor a quadratic, Jeff. Yep, pretty sure. So negative cosine squared theta plus 3 cosine theta minus 2 is, if I combine that, right, 1 minus 3 is negative 2. That's a negative. That's a plus. I don't like factoring when there's a negative in the front. So I'm going to pull the negative out and make this plus minus plus. So then... Oh, the answer... Which question was it? Is it one that was already in the... Is it in the queue? You can just tell me which question in the queue it is. Just tell me which question number. I love these ideas. They're kind of fun. Which one is it in the queue? Or is it not in the queue still? Jake? If the minus goes... I can take this minus, pull it back up here, and then this is going to become cosine squared theta minus... It's a trig one. Oh. Whose submission is it, Jake? Yeah, you just have to tell me whose submission it is. So I think I'm gonna factor this. Oh, Henry. Yes. Okay. Let me post Henry's. I'll post Henry's. Henry's is number 3. Got it. There you go. You should see it now. Yes, we're gonna get to that. Okay. So this is a trick I see, Arian. Do you see how I see like something squared, something, and then not something? That's a good indicator that this is kind of like a quadratic. So I'm going to say let u equal cosine theta. So u squared is equal to cosine squared theta. And now when we rewrite this, okay, this is going to be equal to u squared minus 2u all over u squared minus 3u plus 2. Okay. This I can factor out of u, so we get u minus 2. And then this, you know, what multiplies to 2 and adds up to negative 3? Well, that's negative 1 and negative 2. Yes, it should be on Discord now. Check it out. So then this is u minus 1. This is u minus 2. Right, from factoring this. Oh, look what happens. Very cool here. This goes away, this go away. Okay, so there's a restriction here. The restriction... I can, Ming Ming, just, yeah, submit the question. There's a website, actualofficehours.com, submit it there. The restriction is u cannot equal to 2, which I think is okay, because u is cosine of theta. And there's no way the cosine of theta can only go from 1 to minus 1. So this restriction is actually okay. We don't really care about this. You got to be careful. Anytime you divide the top and the bottom, you got to make sure that thing couldn't have been 0. Because technically you're taking out a solution. Yeah, of course. Yeah, I'll ping you, dude. Okay, so this is u over u minus 1. And let's remember, use cosine theta. So that's cosine theta over cosine theta minus 1? Oh, fuck. But they wanted cosine squared theta plus cosine theta? Did we get rid of too many things? Polar stuff can get really hard. You can tweak the right-hand side too? Okay. Let's... I hate doing that. I feel like that's cheating. To tweak the right-hand side as well. But okay, fine. Because what I need to get cosine theta minus 1 on the bottom? Okay. So this is cosine theta, and then this is cosine theta plus 1 on the top. And then minus sine squared theta is minus 1 minus cosine squared theta. Which, yeah, okay. This is a difference of squares. So this is cosine theta. I'm going to write this as 1 plus cosine theta. All over negative, and then this is going to be 1 minus cosine theta, 1 plus cosine theta. Okay? Because this is a difference of squares. This is a squared minus b squared, so this cancels. So now you get cosine theta, and then minus on a minus is going to switch the order. This is cosine theta minus 1, which that is the same thing as this. Okay? So this is like the left-hand side. This is the right-hand side. And then technically you showed that these equal each other. We do have a restriction. Yes. Cosine theta can't equal negative 1. Yes. Yeah, here's a restriction here. Again, you can't divide by 0, right? So cosine theta cannot equal negative 1. Yeah. And so cosine theta is negative 1 only at theta equals pi. Pi plus 2 pi n. Yo, is the person who sent this question in chat? Yeah. Arian is, yeah. Arian's in chat. Does that make sense, Arian? Yeah, can I show the left side again? So this side? So first thing I did is I rewrote. You always want to have like the same trig function. So I'm writing sine squared as 1 minus cosine squared on both sides. 1 and minus 1 cancels. 1 and minus 3 becomes minus 2. So now I'm left with this and this. I pulled a minus out to make everything positive though, because I don't like this being negative. And then this becomes negative, this becomes positive. So then what I did is I took this minus, I put it up here, and I just switched the orders of these. Because here's the thing. So a minus b is the same thing as negative b minus a. Anytime you just want to like multiply the whole thing by negative 1, you just switch the order of the minusing stuff. Okay, so that's why I got to this. And then from here, I said let u equal cosine theta. Such that this becomes u squared minus 2u. This is u squared minus 3u plus 2. This is now a trinomial that you can factor. Because you're like, what things multiply to positive 2 but add up to negative 3? That's negative 1 and negative 2. And so that means this can be written as u minus 1, u minus 2. Use Gold's rule for factoring. Oh, that's it. Gold's rule is if the first coefficient isn't 1. So you can cancel the u minus 2 minus u minus 2, and you get u over u minus 1. Remember that u is cosine theta, so it's cosine theta over cosine theta minus 1. That's the left-hand side. And then the right-hand side is pretty much the same thing, except you use a different as squares for the right-hand side. That's an interesting way to do it too. Jacob says just multiply by cosine theta plus 1 cosine theta plus 1 on the left-hand side. Oh, you're so right, actually. Yeah. This is actually pretty cool. Okay, yeah, this is another way to do it. Thank you, Jacob. Jacob has another cool. So we didn't even have to mess with the right-hand side. I could have just taken this, and then you're so right, Jacob. That's cool. I could just multiply this by cosine theta plus 1 over cosine theta plus 1. You're basically doing the reverse thing. So now this gets you cosine squared theta plus cosine theta. And then this is all over. This is a difference of squares. This is cosine squared theta minus 1. Which is the same thing. So remember, sine squared theta plus cosine squared theta equals 1. So cosine squared theta minus 1 is equal to negative sine squared theta. So this is now negative sine squared theta. And I think you had what you started with, right? Which is cosine squared plus cosine theta. Thank you, Jacob. That's cool, actually. Nice. Plus cosine theta. Okay, this also works. You don't have to mess with the right-hand side then. Cool. Does that make sense, Aaron? All multiples of pi. Yeah. You play with the devil. Yeah, dude. Yes, you understand now? Yeah, perfect. Yeah, exactly. Yeah, join the Discord. Do you want me to do this one real quick? I'll probably do this one. Let me do part B on the same page real quick. And then I'll post the solution. Gold, I think it's a Red Bull time. I think it is too. Yeah, after this question, I'm gonna go grab not a Red Bull. I'm gonna go grab. I need a snack. I'm dying. Highest level of chem. Okay. I got 2 Doritos and they're good. They're gone. Okay. Which one do we think's easier to mess with here? Okay. I think I'm gonna do this. I'm gonna say sine squared alpha minus cosine squared alpha minus tangent is sine squared. Also, fuck alpha, dude. I'm just gonna say x, dude. Just pretend x is alpha. Sine squared x minus cosine squared x minus tangent is sine squared x over cosine squared x. This is important because now what I'm gonna do is I'm gonna multiply everything by cosine squared over cosine squared. So let's do it. Multiply this one by cosine squared x over cosine squared x. Because now what I get is they all have the same denominator. And so I have sine squared x cosine squared x minus cosine to the 4th x minus sine squared x all over cosine squared x. It doesn't get canceled, no. No, this is just tangent, right? Is sine over cosine. So if you square that, you have to square both. The only way squares go away is if it's the same thing. If it's like x squared over x squared. Then that does cancel. But sine and cosine are 2 different functions. Okay. Cool. Cosine squared is the same thing as 1 minus sine squared. And then we got to go do this. So, cosine to the 4th x is the same thing as cosine... Man, that's really fucking annoying. Fuck. Fine. Cosine squared squared. So that's equal to 1 minus sine squared x squared, which is equal to 1 squared plus sine to the 4th of x minus 2 sine squared x. Okay, that's that. But then this is something special. Sine squared cosine squared I think is something special, no? Yeah, what is sine squared? What it's sine cosine is something. What's that identity? No, that's the double angle. I don't want a double angle. Ooh, no. Oh, I think I see what I have to do. I see what I have to do. I have to write this one as 1 minus cosine squared, 1 minus sine squared as well. This is also 1 minus sine squared x. Oh, actually, ooh. I think I see something cool here. No. I don't want any more cosines, I don't think. I was like, maybe we can group these? Sine squared and then... Right? Can I group these? So that's sine squared x, and then it's cosine squared x minus 1, right? And then we have minus all this. Because then this is equal to negative sine squared. Wait. No, cosine minus 1 is negative sine squared. So you get sine to the 4th of x. You're good, Rhett. Good job. You get negative sine to the 4th of x minus 1 minus sine to the 4th of x plus 2 sine squared of x all over 1 minus sine squared of x. Oh, we're going to combine some stuff. Okay. So this is equal to 2 sine squared of x minus minus is minus 2 minus 1 all over 1 minus sine squared x. Nice. That's the same answer I wanted. Nice. Good, we did it. Whoa. Nice, okay. Damn, that was kind of a heater, Arian. Alright, number 12. River says, my turn. You are next, River. W problem. It was actually kind of fun. Yeah, there's a lot going on there. But it's a fun little puzzle, yeah. So yes, Arian, I will post this in our Discord. So if you go check out our Discord... where is it? There. there's Aaron's question, right? And then I'm just gonna drop the screenshot in. Join the Discord, sick. Okay, there it is. Go comment on it if you can see it and stuff. You get points for answering questions. Let me see. What else? Nice. Thank you, Darth. Darth actually went ahead and solved this JEE question. W, dude. Thank you, Darth. I'll give you a point for that. Cool. And then Jacob solved this one by... Oh, this is fun. Oh, this is another trig identity one. It's another trig substitution one someone did. Thanks, Jacob. Good job. Jacob. Okay, cool. Did you verify the trigs? Oh, is this yours? Haha. Yeah, learn your identities, boy. Well, you really just need to know just 2 identities, like sine squared plus cosine squared equals 1. That's really it. Was this the green one? Oh, this one. Yes, Henry. Oh, this is yours, Henry. Yes, one of my other awesome friends, Jacob. Thank you, Jacob, by the way. He went ahead and solved it and then verified it for you. So it's in there. So this is great. I have other people like kind of running support while I get while I go through all these questions. Okay. River, what's your question? I might actually just go like stretch for a second because my neck really hurts. I've been sitting in the same position for 12 hours. It is a lot of work. Okay, let's see. And you want to solve this implicitly? Okay. Okay. Alright, I'm gonna grab a little bit of food, go to the bathroom. I'll be back in like 5 minutes, so hang tight. Next, we're gonna go over this one with well, let me get rid of this. Sorry, we're gonna go over this with River. Yeah, trig identities are really super important. All good. Okay, I'll be back. Hang tight. Oh, all right. You're welcome, Arian, dude. Go get some sleep. I'm certainly not getting it. Ooh. Yeah, something I didn't, I think, prepare for is that your back starts to hurt if you just sit in a computer chair for, at this case, almost 12 hours. So I had to go stretch my back out. I was like, oh my god. Holy shit. Okay. Yeah, I had to go stretch. Solve the implicit equation, he says. That's what Narosky did. X is equal to cosine t plus cosine 2t. Y is equal to 2 sine t. Wow, clickbait. Thanks for the donation, dude. Appreciate you, dude. Thank you, man.
$5 to Actual Education.
Love it, dude. Helping fund my potato salad dinner. No, I'll still do it. It's fun. So... cosine squared plus sine squared equals 1. So y squared is that. Cosine squared of t is equal to 1 minus y squared over 4. Oh, okay. So then you plug that in for x. In terms of... okay. plus cosine t minus 1. Okay, so that at least becomes 1. And then cosine t is equal to x minus 1 plus y squared, but cosine squared is equal to that. Oh, okay. So you square this. So you get x squared minus xy squared minus 2x. These are all the cross terms, right? Plus y squared over 4 plus 3y squared Yeah, I think trying to find y of x, right? Because cosine of 2t is 2 cosine squared t minus 1? Oh. TikTok doesn't think we're real. Well, I think he went for the double angle just at the beginning, right? And then use this cute little identity. Four sine squared t is 1 minus cosine squared times 4. Okay. Jeff says it's easier to solve x of y and then flip. Okay. So you're saying from this part. Let's see, maybe we get the same thing. You're saying from here? Might have been easier to say that t is equal to the arc sine of y over 2. And then just plug that in. Okay. And then what you draw your triangle, right? Is that what you do? So this is a triangle where the opposite is y. The hypotenuse is 2. So then this is... Dude, what? TikTok, chill. I already solved this. Dude, verify again, dude. Stop. There you go. Mm. 4 minus y squared, right? Yeah, arc side, I'm so tired. Okay, cool. So then cosine is adjacent over hypotenuse. So you have 2 times 2 over the square root of 4 minus y squared. Squared. Plus... Oh, same thing. Minus 1 is all equal to x. Oh, yeah, sorry. He's sorry. Yeah, I had seek. Yeah, thank you. It's adjacent over hypotenuse. Yeah, duh. Oops. Got you. Okay, so then this is x, right? So that's 1/2. 4 minus y squared plus... Oh, I see. I see. You want to keep it like that? That gets x in terms of y. Norofsky says, when you want to parameterize, don't think about trig functions the normal way. Treat them like parameters. What are you eating? Just some chicken salad. Or I think it's egg salad, potato salad. If I solve the quadratic, I think I get x as a function of y, though, no? Right? Oh, you already have x as a function of y. Yeah, sorry. As long as it gets you there, I don't think... Okay, I think I see what you're saying. And then this is minus 1 plus x, I guess, right? So then this and this is all equal to 0, right? Jeff does like inverse trig and coordinate systems. And then so what? This is you have to say this is like u. So then u is equal to -1 plus or minus the square root 1 minus 8 1 plus x. All over 4. So then the square root of 4 minus y squared all over 2 is equal to -1 plus or minus the square root of 10 plus x all over 4. Very interesting. Well, I can at least get rid of this. Make this a 2. Check for extraneous roots. Oh. This has to be positive, right? So I don't think we can have negative. Right, because then what is x? Because x is bound on, the lowest x can be is -1. The most it can be is 2. You definitely want the you don't want the minus, right? Just based on this. What grade level is this? I don't know if this is a certain grade level. Quantum skill. I think it's just like, it's so cold now. How cold is it over with you, Alistair? Right, yeah. So -1 minus won't work. Okay, so we keep the positive. So then I square both sides. I get 4 minus y squared is equal to 1/4. And what is this? This is -1. This is 1 plus 10 plus x plus 2 or minus 2 square root of 10 plus x. What's up? Yep. Then we're gonna take another square root though, man, because I gotta get this y. I do, yeah, 12th grade math for sure. That's not a nice shape. How do you send your math problems? Website down there, actualofficehours.com. Just submit it to the queue. Sure, and sorry, this is plus or minus then, right? Because I square rooted it. Wait. I think we need one more square root. Okay. Is that what it looks like? Ta-da! Let's see. Let's go graph this. Do you go live every day? I usually do. Five days a week. If you want to find out when we stream, the website, actualofficehours.com, click on the streaming schedule. That has... Sorry, let me put the calculator away. Sorry. This has all the days that we stream. We're doing a 24-hour stream today. It's a very special stream, so I'm not streaming tomorrow because I'm going to bed. But I will be streaming again on Thursday. Okay, let me graph this. I want to see if we get the same graph as he did. You're good. Am I good, Pen? Did I get this? I don't know. We'll come back next stream. You're very welcome, Kazi. What is this graph, dude? Let's make sure we have this right, sorry. You're good, Pen. 4 minus 1/4. It's a parabola with bounds? Oh. Wait, is that the correct answer or the wrong answer? It's wrong. We messed up, Jeff.
Disqualified. You done messed up, Aaron.
Apparently. I think they said this is the correct graph. This is what it should be. You mean, what do you mean we, Kimosabi? I liked your method though. Are you into politics? Yeah. Yeah, of course, dude. It's hard not to be into politics these days. Everything is politics. It is a boomerang. Or a sideways Star Trek logo. Nice, Jacob. Yeah, I'll post it. Thank you. Goats. The second one. One sec. Jacob's just going here just like solving questions. The Lord's work, dude. Do you have a girlfriend? No. Math is my girlfriend at this point. Do you have a fiance? Congrats, dude. Fire. Okay, so this method didn't work, unfortunately. It looked kind of legit, though. I think there's probably some domain stuff we kind of screwed with. Wait, there's integrals going on here now? Wait, what's going on here? What are you integrating, Narowski? Jacob says, I'm bored as a senior aerospace engineer on a Tuesday night, so I thought I'd help. Thank you, Jacob. I appreciate that. That's super dope. Okay, cool. All right. This was fun. This was fun. I appreciate the exercise. Wherever Narowski, I think, has the more proper way to do it. I like that he's just doing all the trick. I agree with you, Jeff. This is usually how I would see it. I'd be like, fuck it. We're gonna go brute force this with inverse trig functions. You need more multivariable calc, dude? Well, submit a question. I'll do it. It says solve for the implicit one, not the explicit, Jeff. That's apparently where we messed up.
You're not that guy. You're not that guy.
You should be able to do it with Arcane. Okay. Alright. A mental break from calculations. I might, honestly. Alright, let's mark Rivers done. Everything's getting put in the Discord. Let's see. What do we have so far? A lot of you guys are awesome. Here, let me post Rivers in so far. There's Rivers. Oh, nice. Oh, sick. Yeah, this was the Thenovan voltage. Oh, yeah. This is gonna take me a while, dude. Thenovan is like not my wheelhouse. But thank you, Jacob. Jacob went ahead and just like did this. First notice of parallel circuits, right? Okay, you wrote that as parallel. Yes, Thenovan's. Yeah, you turn off the voltage supply, you cut the current, and then you measure the voltage between the two. I think, or no, you find the new resistance. Okay, and then you do an open circuit, and you solve for V Thenovan, and then, you find R Thenovan, and then you find V Thenovan with the new current. Okay, very cool. Thanks, Jacob, for this. This is sweet. This is sweet. It feels like a war zone here. Texas A&M. Nice, dude. My sister went to A&M, Jacob. I went to UT. Hook 'em. No. I grew up in Houston. Whoop, I'm leaving now.
Surprise, motherfucker.
Whoop, gig 'em. You're from Houston too? Nice. I grew up in the Woodlands. I went to the Academy of Science and Technology. That was my high school, which was at College Park High School at that time. Wait, I'm from the Woodlands. Oh, damn, bro. Sterling Ridge? How much closer do we want to get? This reminds me of a time I was at Creekside. Okay, I know Creekside. Cool.
Good job.
Yeah, isn't that fucking random? I don't think Creekside was really around when I was there, maybe? Or, I don't know. Creekside Park, I remember, was there. It was on Kirkendall or something. I think it was like new. It was like opening. I graduated from high school in 2008, so I didn't really go back to the Woodlands after that. Which I know the Wood. You graduated in 2022. Yes, 14 years later. That's cool. That's cool, man. It's a small fucking world. I had this. I was at Tomorrowland, which is a big music festival in like Belgium back in like 2014. And I remember I was at one of the stages, and I ran into someone who literally, I think, grew up in Panther Creek. And I was like, oh shit. Like, here we are, the middle of Belgium at some random music festival. And you grew up like no more than a couple miles away from me. Yeah, that was crazy. I mean, this is pretty crazy too. I mean, this is a random person on the internet. Yeah, we've probably been in a 5-mile radius at some point in our lives, probably. Because I did go back to the Woodlands for like Christmases every once in a while. That's fucking crazy. Crazy! Small world. It is a small world, but it also isn't at the same time, because I say like the vibe attracts the tribe. So the fact that you did aerospace means, you know, that's kind of a very Woodlands thing, because our parents are very... If you have parents in the Woodlands, they're more predisposed to like wanting you to do well in school and probably like go to engineering and then like do this type of stuff, you know. It's not like you grew up in Compton or something.
No.
It makes sense. But it is still super, yeah, it's super fucking random that it's, I mean, then again, Texas is like one of the biggest states. Houston's one of the biggest cities. But it is still really random. So it is cool. The probability is low. But I think the association is like, makes sense. My parents were crackheads. I'm third year engineering. Nice. Congrats for escaping crackheadery, I guess. Yes. I'm actually in your living room right now. Oh shit, dude. Where are you? Two smart, handsome guys from being the same town makes total sense. Except you're engaged, right? Did you say you were engaged, Jake? Are you the one that said you were engaged? Someone said they were engaged in my chat. Oh, you have a fiance. Oh, fuck yeah, nice. Do you still live in Texas? As an engineer, I do not know how this happened. I mean, as an aerospace engineer, you definitely have prospects of having secure income, which is a great thing. You're still A&M attending your master's. Nice. Okay, so I'm not surprised because wait, that's Baylor Ring by Spring, right? Where like you have to get married your junior year so that you can like live together on campus. They're like super Christian. Baylor University, I remember, yeah. A&M's not super Christian, but it's a little bit more Christian than most colleges, and so tends to be a little bit more traditional on values and stuff, which is great. I mean, I'm all for it, dude. Congrats, man. Like, college is probably the best time to try to get married because you're around people all the time. When you get older, it's like it's fucking difficult. It's difficult to like meet people, meet similar people and keep bumping into them. NSF funded, baby. That's nice. You got the GRFP or something? Right. So yeah, you're especially smart. You got the GRFP, which is the Graduate Research Fellowship Program. I got runner-up for that like fucking twice, dude. I was so mad. Yeah, because it's like $100,000, right? It's fucking sick if you get it. Yeah, $40K per semester for I think 3 semesters. Maybe it's different for engineering, or maybe it's changed over the years. I don't know what it is these days. Oh, thank you, Pen. Yes, let's see. What do we got? Do we got any stuff? This one's not too bad. You like puzzles? Here's some puzzles. Oh, it's every semester in college. I think there's a limit on the top end of it. What are these ones for Narosky? Was this the puzzle? Which one is this for, Narosky? It's the inverse trig guy. Oh, it's this one. Oh, nice. Okay, yeah, let me just post that. Okay, cool. You guys are great. I love that I have people in my chat just like blasting through questions. Are there any more JEE questions? Maybe. Let's go see. Sorry, let me post. This is Thuma's. There, that's done. Yeah, congrats, dude. This is from Narosky. Practice problems and puzzles. Okay, do I want to do the puzzles though? I want to be a cowboy. Easier set. Oh my god, look at this. Actually fun. Wait, are these all yours, Narosky? Are these the fun ones you said you were creating for us? Moss. This one's all... Oh, Jesus. Moments of... That looks like Indian writing pass. This is physics. Or I think this is quantum mechanics. Sorry, I'm just looking at what we got so far. You're working on I Want to Be a Cowboy? Okay, cool. Thanks. Okay. Alright, I'll leave that then. This is great. Oh, this just touches my heart, dude. Yeah. Okay, so we have some awesome people who just found us on our stream, on our Discord, and they're going through the queue and helping you guys out while I'm eating my potato salad, entering the 12th hour of streaming today. Beautiful. I can do this one real quick, and then Pen, you want to hop in and like we'll do one of the puzzles or something? You want to do these? These look fun. I have no fucking clue what this is. Narosky says it's not Indian Trust. It's not that bad. It's not JEE. I think AFG also needed help. Yeah. This is cool. We could do this one, I think. Pen, right? Do you think we could do this one? They don't look fun. How about we do this one, Pen? You want to help me with this one? And then we'll tag AFG. Divergence theorem? I think a divergence theorem is not bad. And then we'll look at one of the puzzles. I made sure to sprinkle in a bit of everything. Got inequalities, analysis, matrices, and logic stuff. So pick whatever. Yeah, what's up, AFG? Yeah, we're going to work on yours. My multivariable calculus is rather not good. I think yours is probably pretty good. Let me see what the divergence... This is for like flux or something, right? I didn't skip yours. Nope. Narosky got it. Yeah. Yeah. We have other people. Narosky, Jacob, or Jacob. Sorry, I'm probably pronouncing your name wrong. Who are doing a great job. So I think we can just do this. I think it's a volume integral, Pen. I love this diagram. This reminds me of like some like a kid's book or something. It's like, this is the wheel, and the wheel makes the car go forward. Yeah, f.ds. I think this is missing an n, right? Is equal to the divergence of f dv. So what? Divergence. I love how they put the dot there. Wait, both of these things don't know how to put a dot. Dude, bro, it's bro, what? It's just it's a dot. Okay. Div.f. That's the same thing as df dx, comma, df dy, What's up, Jeff? DFDZ? And then I think it's like FX, FY, FZ. C dot. Yeah, right? Isn't that all it is, Oak Spirit? What's up, dude?
My man.
Dot product insinuates a scalar answer. Oh, yeah, it should be a scalar answer. I'm dumb. My bad. You're totally right. Thank you, Jacob. I don't know why I was writing a vector. Good night, Tuma. Yeah, thanks, dude. Appreciate your question. Because F is sine pi x, comma, zy cubed, comma, z squared plus 4x. Right? And this should be a scalar then, right? Because this is an operator dotting with F. And then I think we're just gonna do dx dy dz. Yeah? Okay. So this is just going to be pi times cosine pi x, right? This is going to be 3y squared z. And then this is just going to be equal to 2z. Did you know the divergence theorem is actually derived using the fundamental theorem of calculus? I did not. I'm thinking, like, isn't there the fundamental theorem of calculus for like line integrals? Oh, that's kind of what this is, right? I never took PDEs. You guys are above me. Okay. So, correct me if I'm wrong. I think this is just a simple dv is just dx dy dz, right? I don't have any like funny business going on because it's just a fucking box. So you have pi cosine pi x plus 3y squared z plus 2z. And then this is dx dy dz, where dx goes from -1 to 2. dy goes from 0 to 1. And then this goes from... Is this also the flux, technically? 1 to 4. Okay. I think we're on the right path. Alright, integrate this dx. That's hilarious. Well, I'm just going to do the opposite of what this is. So I'm just going to get sine pi x, because integral of cosine of pi x is 1 over pi sine pi x. Pi's cancel. So I get plus 3y squared zx plus 2zx. And then that's evaluated from -1 to 2. So what's that? Sine 2 pi. Sine of 2 pi is 0. Beautiful. Plus 3 plus... I want to learn math, but it's too hard. It's not too hard. You just got to practice a lot, dude. You just got to do it a bunch. Just do it till, you know, things start to click. Plus 4z. And then that's minus... plugging -1 into this, so minus sine of negative pi, which I believe that's also 0. These are both 0. Love that. Those are gonna go away. And then that's minus 3y squared z, and then minus 2z. Yeah. So what are we left with? 6y squared z minus plus, so that's 9y squared z. 4z minus 2z is plus 6z. And now we're on to dy dx. And then this is from 0 to 1. 1 to 4. So integrating this with respect to dy, this is going to become 3y cubed z plus 6yz. Right? Raise the power, divide by new power. And that's from 0 to 1. Beautiful. I don't care about the 0. So that's just going to be 3z plus 6z. Wait, we already did the dx. Sorry, this is dy dz. Already did the dx. Okay. 1 to 4 dz. So that should just be 3z squared over 2 plus 6z squared. So 3z squared? Oh, wait. Bro, I should just add these. What am I doing? Fairly simple. I don't know why I found this hard. I'm actually devolving to an ape. No, you're not, dude.
Surprise, motherfucker.
This gets harder when you need to parameterize. Yeah. I know this gets harder because I've done this. Is when you have to parameterize, it really sucks. Sorry, let me just fix this. Sorry. This is also 9z. So you get 9 halves z squared. And then from 4 to 1, that's going to be equal to 9 halves times 16 minus 1. So 9 halves times 15? So what is that? 135 over 2? Yes. Do you mind posting I want to be a Cowboys question? Yep, I'll do it right now. That is number 12. Should be posted. There you go. Okay. I think this is right. If you want to see, actually, we can just like throw. I like just throwing things to the AI bot just to see what happens. Gemini's been cracking at it recently a lot better than ChatGPT these days. Nice. You're doing New Jot's question? Thank you, dude. 135 over 2. Nice. We did it. We did it.
Hey, come on, baby! Come on! Yes!
Yeah. Hell yeah.
Come on! Ah! Yes! Yes!
Oh, thank you, dude. You're $6 away from a $10 gift card. I'm gonna use it on bits to donate here. Check. I appreciate the bits, dude, for Mistral. Oh, you're 5 bond coins away. Oh, okay. You just have to submit some things. Just keep the money laundering going. Okay, nice. So that was AFG. That was question 10. Now give yourself a bond coin. Okay, Gold. I'm a low-key go to sleep. I have school tomorrow. Can't believe I'm still in high school. Yeah. Crazy. Y'all are all really smart. I mean, I can't believe even, like, Jacob is just doing his master's. Like, he's at, like, PhD level intelligence. Nice. Okay, so we did question 10. Yes, money laundering. AFG. Nice. Saw for N, har har. What's that remaining math for? What's that? Here, Pen, you want to come up and just chill? We can just chill. We can just see like what we want to work on. Because we're about to hit 12 hours. What's up, Pen Center?
Amazing.
Amazing. I think what was it? Zach said his record was 10. He's like, oh, now I gotta one up you, dude.
Yeah, I think, what was mine? I think I've done a 12 hour-ish stream before.
It's nuts.
It's a lot.
It's a lot. I can't believe this is only halfway, though.
I was gonna say, it's only halfway, too. Oh
what did I do? I fucked up, dude. It's okay. Oh, man.
You got this. You got this. You got this.
All right. Yeah, I think so. I learned a lot about like set theory earlier with Zach, which is cool. Learning all the weird ass jargon for things. You guys have all like the weird little symbols and stuff, which is fun.
Like set theory is wild, man.
Yeah,
I don't like linear algebra. Linear algebra, my bae.
Linear algebra is your bae. You taught a course on it, right? On your Discord once? I think you did, yeah?
Yeah, I've done two. I did one with Zach, and then I did one with like one of the big math servers.
Oh, nice. And then do you do complex analysis?
The Mandelbrot math server.
Yeah, not the asshole math server. The other one eat a bag of dicks, dude. They like get on my case, dude, for trying to help people.
We don't speak about the toroidal math server.
Yeah, we don't speak about the toroidal math Discord. Yeah, those kids, they can't sit with us, dude.
Yeah, seriously. Yeah, I did complex analysis twice, I think. Yeah.
Nice. Complex, I need to like redo. It was like complex is the highest math class I took in college. I stopped at complex.
It's the best one though.
Yeah, you're going around like poles and holes and residues and stuff. It's a fun game.
It's just it's fucking Saturday night at the bar.
Saturday night at the bar, holes and poles and going around and just see what happens.
Residues. Holy shit.
Narosky, you want to come say hi? You can come say hi, Narosky. Narosky got baited by 6'7". Oh no, who got you with the 6'7", Narosky?
Damn.
Who hurt you? Dude, someone almost got me to write penis on the fucking stream, dude. You want to see that? Watch here, I'll show you. It was hilarious. Let's where is it? We hit the 12 hours on this. Here, where is it? Here, where is it? Can't change while loading. Come on. There you go. No, come on. Wasn't this one? Where was it? We've done so many questions today. This was it, dude. Someone almost got me. It's funny because it was so innocuous.
No.
Yeah, dude, look at this, bro. Look. It was like the product of the radius and two numbers A and B. I was like, oh, okay, yeah. So R and AB, rab. Okay, great, awesome. And then it was like the perimeter minus the sum of C plus the pi and 4. I was like, okay, cool, nice. The sum of the perimeter, Euler's number, and number n, imaginary unit, and the side length. So I put L for side length. I was like, you almost got me. Yeah. I was like, no, you're not gonna get me.
Yes, that's awesome. That's amazing.
Oh man. J-Hat says, Mr. Penn likes linear algebra. He does. Could he talk about the QR factorization tips real quick? I got 2 problems left and I'm stuck. Oh, submit them right now, JH. Throw them in. We'll do them right now. Just throw them. Are they in the queue, JH?
I can do that in 9 minutes, but
we can at least try. It's better than nothing. You get partial credit, right? 9 minutes to submit. That's fucking rude.
You're not that guy, Charles. Trust me. You're not that guy.
Yeah, JH, send it to us. If anything, we'll learn. I'll learn linear algebra from Penn.
Oh, hello. I should probably turn that off so you guys don't have to hear that.
It's okay. Let me see. Where's JH? JH, send it in.
Oh, this is where we're trying to unitary matrix. Okay. Can I remember how to do this? That's the question.
What does the QR stand for? The QR code?
No, Q is what is it? Q is we need it to. One of them's a right triangular matrix, I think. Upper triangular, right upper triangular, and Q is usually what we use for orthogonal matrices.
Oh, okay.
For some, I don't know why. For some reason.
Is LU decomposition the same or different?
LU decomposes into a left, a lower and upper triangular matrix, I think. So where QR is a bit different.
Okay. Oh, I think I see. Oh, you guys. Oh, this is where you get like all zeros on the bottom left. Oh.
Yeah. So the R stands for that kind of right upper triangular matrix, and then Q. Forget how we get Q. It's something to do. You have to find a basis, and then you have to like normalize the basis or something crazy.
I see. Find the QR factorization.
Gram-Schmidt. Yeah.
Yeah. Gram-Schmidt. What? Wait. What? Wait. Whoa. Set of vectors formed by the columns of the given matrix. Gram-Schmidt normalization. Yeah. Okay.
Yeah, so you take the columns and you use a Graham-Schmidt process to create the basis. Those become the columns of the Q matrix.
Got you.
And then
And then you find the transpose.
Yeah, if you're working with complex variables, you conjugate transpose.
And that's now matrix R, I guess. Oh no, R equals Q transpose times your original matrix.
Right, because if Q is orthogonal, it's its own inverse. So that's the whole point of normalizing it. So we can take its transpose, left multiply the original matrix, and then you can find that upper triangular matrix that you need. It's kind of like finding a. It's like multiplying by the inverse on the left side, if that makes sense.
Got you. Okay, that's Q. That's R. Okay, so Q is the orthonormal. Okay.
What we need to do is take those two columns and we need to orthonormalize them. So we can probably just get chat to do that quickly.
Okay. So here, let's just throw this in chat.
Since JNat put us on a 9-minute time crunch.
Yeah, you put us on a 9-minute time crunch. Here we go. Wait, what I need? Orthonormalize this?